Hey, chick. Hey.
नमस्कार, सगळ्यांचं स्वागत आणि विनंती आहे कृपया लवकरात लवकर स्थान ग्रहण करावं. आपला अल्पाहार झाला असेल तर आपल्याला विनंती आहे कृपया तिथे गर्दी करू नये आणि खुर्चीवर स्थान ग्रहण करावं. माननीय मंत्री महोदयांचं आणि मान्यवरांचं आता काही वेळातच या ठिकाणी आगमन होत आहे आणि आजच्या या कॉन्फरन्सला उद्घाटन सोहळ्याला सुरुवात होते. नमस्कार. माननीय मंत्री महोदयांचं आगमन होतं आहे. आपल्या सगळ्यांना विनंती आहे आपण कृपया स्थानापन्न व्हावं. माननीय नामदार आशिषजी जयस्वाल यांचं मी मनापासून स्वागत करतो आणि विनंती करतो त्यांनी कृपया स्थानापन्न व्हावं. आणि सगळ्या डेलिगेट्सना आणि इथे उपस्थित असलेल्या सगळ्यांना मान्यवरांना विनंती आहे आपणही स्थानापन्न व्हावं. माननीय नामदार आकाशजी फुंडकर आज विशेषत्वानं उपस्थित आहेत, त्यांचंही आम्ही मनापासून स्वागत करतो आणि सगळ्याच मान्यवरांचं सन्मानपूर्वक इथे स्वागत करतो. श्री धवल अंतापूरकर साहेब, संचालक बाष्पके, संचालनालय महाराष्ट्र राज्य, आणि संजय मारुडकर, संचालक महाराष्ट्र राज्य वीज निर्मिती, यांचंही मनापासून स्वागत. आणि सगळ्या इथे उपस्थित असलेल्या मान्यवरांना नम्र विनंती, कृपया आपण स्थानापन्न व्हावं. आणि या सगळ्या मान्यवरांना मी सन्मानपूर्वक मंचावर आमंत्रित करते. टाळ्यांच्या गजरात आमंत्रित करूया माननीय नामदार श्री आकाश फुंडकर साहेब, कामगार मंत्री महाराष्ट्र राज्य, माननीय नामदार श्री आशिष जयस्वाल साहेब, कामगार राज्यमंत्री, श्री धवल अंतापूरकर साहेब, संचालक बाष्पके, संचालनालय महाराष्ट्र राज्य, आणि श्री संजय मारुडकर, संचालक महाराष्ट्र राज्य वीज निर्मिती, आणि श्री भानू राजगोपालन यांनी मंचावर स्थान ग्रहण करावं अशी विनंती. आजच्या कार्यक्रमाला आपण सुरुवात करतोय. आपल्याला विनंती आहे आपणही स्थान ग्रहण करावं आणि एक नम्र विनंती आहे आपण आपले मोबाईल फोन सायलेंट मोडवर ठेवावेत. BWU WeldConnect अर्थात बॉयलर वर्ल्ड अपडेट WeldConnect या एकदिवसीय कॉन्फरन्समध्ये इथे उपस्थित असलेल्या सगळ्या मान्यवरांचं मनापासून स्वागत. बॉयलर टेक्नॉलॉजी, बॉयलर परफॉर्मन्स आणि वेल्डिंग या विषयावर प्रकाश टाकणारी ही कॉन्फरन्स आहे. सर्व अतिथींचं मनापासून स्वागत करते. पहलगाम इथे झालेल्या भ्याड हल्ल्यामध्ये धारातीर्थी पडलेल्या आणि देशाचं रक्षण करत असताना शहीद झालेल्या आमच्या जवानांना आपण सुरुवातीला श्रद्धांजली अर्पण करणार आहोत. मी मंचावरील मान्यवरांना आणि समोर उपस्थित सगळ्यांना विनंती करते आपण काही क्षण आपल्या जागीच उभं राहावं आणि श्रद्धांजली अर्पण करावी. ओम पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते. आपण स्थानापन्न व्हावं अशी विनंती करते आणि आजच्या कार्यक्रमाला सुरुवात करते. सगळ्यांचं मनापासून स्वागत. ही परिषद वीज निर्मिती, सिमेंट, पेपर, स्टील अशा उद्योगातील बाष्पकाचा वापर करणारे तसेच बॉयलर उत्पादक, दुरुस्त करणारे तसंच वेल्डिंग NDT यामधील तज्ज्ञ लोकांना एकत्रित आणणार आहे. या एकदिवसीय परिषदेच्या माध्यमातून वीज निर्मिती करणारे पॉवर प्लांट अर्थात पेपर, स्टील, सिमेंट या उद्योगातील बाष्पकाचा वापर करताना येणारे अडथळे, समस्या याचं निराकरण तर होणारच आहे, पण जगभरातील नवनवीन तंत्रज्ञान याबद्दल देखील आज आपल्याला माहिती मिळणार आहे. वेल्डिंग हा बॉयलर उद्योगाचा अविभाज्य घटक आहे. BWU WeldConnect ही एकदिवसीय परिषद वेल्डिंग, बॉयलर तंत्रज्ञान आणि त्याची कार्यक्षमता यावर आधारित आहे. या परिषदेचा उद्घाटन सोहळा आता संपन्न होतोय. BWU WeldConnect याची मध्यवर्ती भूमिका औद्योगिक विषयाशी निगडीत आहे. महाराष्ट्रात विशेषतः विदर्भातील प्रमाणित IBR वेल्डर्सच्या मर्यादित उपलब्धतेचा प्रश्न आणि विदर्भात औद्योगिक क्षेत्राची झपाट्यानं होणारी वाढ हाही महत्त्वाचा मुद्दा आहे. याशिवाय वीज प्रकल्प, सिमेंट, स्टील, कागद उद्योग यासारख्या उद्योगातील सुरक्षाविषयक आणि नियमांच्या अंमलबजावणीकरताही याचा परिणाम होणार आहे. BWU WeldConnect हे एक व्यासपीठ आहे जिथे याविषयीच्या सगळ्या मुद्द्यावर चर्चेला वाव मिळणार आहे. आपल्याशी संवाद साधता यावा, आपल्याला सुचत असलेले उपाय एकमेकांना कळावे, कुशल मनुष्यबळ एकत्र यावं आणि भविष्यात विषयाला चालना मिळावी, यासाठी ही परिषद महत्त्वाची आहे. सांगायला आनंद आणि अभिमान वाटतो की ही BWU कनेक्ट सिरीज ही WeldConnect ही पहिलीच कॉन्फरन्स आहे आणि अशा प्रकारची ही पहिली कॉन्फरन्स आपल्या नागपूरमध्ये होते याचा आपल्याला अभिमान आहे. त्यामुळे एकदा टाळ्या वाजवून या परिषदेचं आपण स्वागत करूया आणि मान्यवरांना विनंती करते की दीप प्रज्वलन करून या परिषदेचं त्यांनी विधिवत उद्घाटन करावं. माननीय नामदार श्रीयुत आकाश फुंडकर साहेब, कामगार मंत्री, महाराष्ट्र राज्य, आज विशेषत्वानं उपस्थित आहेत. टाळ्यांच्या गजरात त्यांचं स्वागत करत त्यांना विनंती आहे त्यांनी दीपप्रज्वलन करावं. दीपप्रज्वलनामध्ये माननीय नामदार श्रीयुत आशिष जयस्वाल, कामगार राज्यमंत्री, विशेषत्वानं उपस्थित आहेत. त्यांचंही स्वागत. श्रीयुत धवल अंतापूरकर, संचालक बाष्पके, संचालनालय महाराष्ट्र राज्य, श्रीयुत संजय मारुडकर, संचालक महाराष्ट्र राज्य वीज निर्मिती, आणि श्रीयुत भानू राजगोपालन यांना विनंती आहे की दीप प्रज्वलन करून त्यांनी कार्यक्रमाची विधिवत सुरुवात करावी. धन्यवाद. दीपप्रज्वलन हा खरं म्हणजे आपल्या आतल्या प्रकाशाला प्रज्वलित करण्याचा एक उपक्रम आहे आणि ज्यातून आपल्याला नवनवीन प्रेरणा मिळत असते आणि म्हणून दीपप्रज्वलन खूप महत्त्वाचं असतं. आपले आधीचे पंतप्रधान अटलजी लिहितात, भरी दुपहरी में अंधियारा, सूरज परछाई से हारा, अंतरतम का नेह निचोड़े, बुझी हुई बाती सुलगाए, आओ फिर से दिया जलाए. हम पड़ाव को समझे मंजिल, लक्ष्य हुआ आँखों से ओझल, वर्तमान के मोह जाल में आने वाला कल न भुलाए, आओ फिर से दिया जलाए. असा दीप आपण सतत प्रज्वलित करत राहावं आणि विकासाचा मार्ग आपण स्वतःच शोधावा. या दीप प्रज्वलनानंतर मंचावर उपस्थित असलेल्या मान्यवरांचं आपण स्वागत करणार आहोत. मी विनंती करते श्रीयुत भानू राजगोपालन यांना त्यांनी माननीय नामदार श्रीयुत आकाश फुंडकर साहेबांचा सन्मान करावा, सत्कार करावा. आज विशेषत्वानं त्या या कार्यक्रमासाठी ते उपस्थित आहेत. कामगार मंत्री, महाराष्ट्र राज्य. टाळ्यांच्या गजरात आपण या सत्कारामध्ये सहभागी व्हावं अशी विनंती आहे. मी राजगोपालन साहेबांना विनंती करते त्यांनी आजच्या कार्यक्रमाची आठवण भेट म्हणून शाल, श्रीफळ आणि एक छोटीशी भेट माननीय नामदार आशिषजी जयस्वाल यांचंही स्वागत करावं अशी विनंती भानू राजगोपालन साहेबांना करते. कामगार राज्यमंत्री आहेत आणि विदर्भामधलं लाडकं नेतृत्व म्हणून आशिषजींकडे आपण सगळे बघतो. त्यांनाही एक छोटीशी आठवण भेट. मी विधी अग्रवाल यांना विनंती करते त्यांनी श्रीयुत धवल अंतापूरकर साहेबांचं स्वागत करावं. श्रीयुत धवल अंतापूरकर, संचालक बाष्पके, संचालनालय महाराष्ट्र राज्य. विधी अग्रवाल त्यांचं स्वागत करतील. धवल अंतापूरकर साहेब, त्यांचंही स्वागत. या सगळ्या मान्यवरांचे अनुभवात्मक विचार आज आपण ऐकणार आहोत. आणि संजय मारुडकर साहेबांचं स्वागत, संचालक महाराष्ट्र राज्य वीज निर्मिती, संजय मारुडकर यांचंही स्वागत करावं अशी विनंती. टाळ्या वाजत राहिल्या पाहिजेत कारण मान्यवरांचे विचार आज आपण ऐकणार आहोत. परिषदेच्या माध्यमातून हे सगळे एकाच छताखाली आलेले आहेत. यानंतर या कार्यक्रमाला पुढे नेत मी श्रीयुत भानू राजगोपालन यांना या ठिकाणी आमंत्रित करणार आहे. एखादी व्यक्ती ध्येयवेळी असते. भानू राजगोपालन मुळात सिव्हिल इंजिनियर आहेत. मेटाफोर्सचे फाउंडर आहेत आणि गेली 34 वर्ष ॲडव्हर्टाइजमेंटच्या क्षेत्रामध्ये कार्यरत आहेत. विशेष सांगायचं म्हणजे हीट अँड स्टीम इंडस्ट्री व्हर्टिकलमध्ये जागतिक स्तरावर जे एकमेव प्रदर्शन भरवलं जातं, बॉयलर वर्ल्ड आणि भारतात बॉयलर इंडिया यामध्ये त्यांचा सिंहाचा वाटा आहे. या क्षेत्रात ते प्रचंड काम करतायत. बॉयलर वर्ल्ड जगात विविध ठिकाणी विषम वर्षांमध्ये म्हणजे 21, 23 आणि आता 25मध्ये बँकॉक इथे भरवण्यात येणार आहे. 23मध्ये ते नैरोबीमध्ये झालं. तर बॉयलर इंडिया समवर्षांमध्ये म्हणजे 20, 22, 24मध्ये भरवण्यात आलं. या विषयामधलं हे जगातलं सगळ्यात मोठं प्रदर्शन असतं. 15 ते 20 सेमिनार्स असतात. 28 ते 30 हजार लोक जवळपास 42 देशातून या प्रदर्शनाला येतात. असं हे एक युनिक एक्झिबिशन आहे आणि अतिशय तळमळीनं भानू राजगोपालन ही चळवळ राबवत आहेत. या आजच्या कॉन्फरन्समध्ये सुद्धा त्यांचा महत्त्वाचा वाटा आहे आणि त्यांना विनंती आहे की त्यांनी स्वागतपर भाषणासाठी इथे यावं आणि आपल्याशी संवाद साधावा.
Thank you, madam. Respected dignitaries, Honorable Shri Akashji Phondkar, Honorable Shri Ashishji Jaiswal, Sanjayji Marudkar, Dhaval Antapurkarji, industry leaders, distinguished guests and friends. Today marks a meaningful step ahead, not just for the Boiler World update, but for our entire heat and steam industry. This community has been very supportive in creating a wonderful knowledge platform. It is an honor and privilege to welcome you all to the inaugural BWU WeldConnect conference. When we began Boiler World Update as a monthly newsletter, it was a clear vision to share knowledge freely, to write freely, to read freely across the world. Boiler World Update now reaches to over 120,000 people across the world. We want to share knowledge freely, foster collaboration, and build a unified, thriving industry community. Over time, our newsletter has transformed into a powerful knowledge exchange, guided and enriched by industry experts, thought leaders, academicians, passionate professionals like yourself, and very supportive leaders from our state. But our true growth doesn't happen behind the screens alone. It happens when we come together, connect face to face, and ignite meaningful conversations. BWU WeldConnect is the manifestation of that belief. It is about creating a platform that celebrates our collective expertise, sparks dialogue, and encourages lasting collaborations. This is where we move from knowledge sharing community to a community building conference. Our industry fuels progress, supports economics, and touches lives in more ways than we can often recognize. Why WeldConnect? Because welding is the backbone of the industry, a foundational process that unites metals, binds our equipment, and symbolizes the strength of our collective aspirations. In much the same way, WeldConnect aims to unite minds, bind ideas, and forge relationships that drive innovation and growth. Our community is not just manufacturers, suppliers, or engineers. It is a dynamic ecosystem of thinkers, innovators, and creators. We represent the engine that drives the industries, economies, and subsequently nations. It is through your expertise, your commitment, and your relentless pursuit of excellence that we achieve collective progress. Our mission is very clear. We must continue to build a knowledge-driven community that is resilient, adaptive, and future-ready. As we embark on this exciting chapter, I urge you to engage openly, challenging ideas respectfully, and share generously. Let us harness the collective wisdom present here today and transform it into actionable insight that uplift our industry as a whole. Thank you for joining us in the journey. Together, let us shape a brighter, stronger future for the heat and steam community. Welcome once again to BWU WeldConnect. Let the conversations begin.
धन्यवाद. यानंतर या कॉन्फरन्सचं औचित्य साधत एका बुकलेटचं अनावरण मान्यवरांच्या शुभ हस्ते होणार आहे. मी मान्यवरांना विनंती करते की कृपया आपण त्या बुकलेटचं अनावरण करावं. बॉयलर वेल कनेक्ट या सेमिनारचं औचित्य साधत एक महत्त्वपूर्ण बुकलेट आता ज्याचं अनावरण मान्यवरांच्या शुभ हस्ते होतंय. संपूर्ण माहिती असलेलं हे बुकलेट आपल्या सगळ्यांच्या सेवेत आणि अर्थातच वर्षभर आपल्याला ज्याची माहिती मिळत राहणार आहे असं हे बुकलेट. धन्यवाद. सगळ्या मान्यवरांना आम्ही हे बुकलेट देतोय. ज्याचं अनावरण आत्ताच माननीय मंत्री महोदयांच्या शुभ हस्ते झालं. माननीय आकाश पुणकर साहेबांच्या शुभ हस्ते. धन्यवाद. आणि यानंतर एक छोटीशी फिल्म आपण बघणार आहोत. कन्सेप्ट ऑफ बॉयलर वेल कनेक्ट आणि या कॉन्फरन्सचे हायलाईट्स नेमकी ही कशासाठी आपण करतोय आणि याचं वैशिष्ट्य काय आहे हे सांगणारा एक छोटीशी चित्रफीत आता आपल्याला दाखवण्यात येणार आहे. मी विनंती करते चित्रफितीला सुरुवात करावी.
In every industry that powers a nation, steam rises, metal fuses, and futures are forged. At the core of it all, boilers and welding. Strength you can't see, but everything stands on it. Today, as industries surge across Maharashtra and Vidarbha, new challenges rise with them. Higher demands, tighter safety norms, a shortage of skilled welders to fuel the next leap forward. Every weld, every boiler carries the weight of performance, of reliability, of lives. BWU WeldConnect was built for this moment, to bring industries together, to raise the bar on safety, efficiency and skill, to spark new ideas and new standards. Here, power plants, cement giants, steel makers, paper mills, all need to share, to question, to push limits. From metallurgical breakthroughs to welding excellence, from digitalization to life assessment. This is where challenges meet solutions. Because behind every plant that runs safer, every project that lasts longer, every industry that grows stronger, there are minds that dared to connect, to learn, to lead. Welcome to BWU WeldConnect, where strength is not just built, it's reimagined.
धन्यवाद. या कॉन्फरन्सच्या पाठीशी अनेकांचे महत्त्वपूर्ण प्रयत्न आहेत आणि आमचे सपोर्टर्स आमच्या पाठीशी उभे आहेत. त्यांचा सन्मान करणं हे आम्ही आमचं कर्तव्य समजतो आणि म्हणूनच माननीय आकाश पुणकर साहेबांना मी विनंती करते की या सपोर्टर्सचा त्यांनी सन्मान करावा. मी सपोर्टर्सना इथे आमंत्रित करते आणि विनंती करते त्यांनी हा सन्मान स्वीकारावा. पहिल्यांदा आमंत्रित करते GMR वरोरा एनर्जी लिमिटेड यांचे प्रतिनिधी आले असतील तर त्यांनी कृपया वर यावं आणि आपला सन्मान स्वीकारावा अशी विनंती. मी माननीय नामदार आकाश पुणकर साहेबांना विनंती करते की त्यांनी या सपोर्टर्सचा सन्मान करावा. त्यांना एक छोटीशी आठवण भेट आपण देतोय. टाळ्या वाजत राहिल्या पाहिजेत कारण या सगळ्यांच्या मदतीशिवाय ही अतिशय सुंदर आणि महत्त्वपूर्ण अशी कॉन्फरन्स होणं अशक्यच होतं. GMR वरोरा एनर्जी लिमिटेड. यानंतर अदानी पॉवर लिमिटेड तिरोरा यांनी कृपया समोर यावं. अदानी पॉवर लिमिटेड तिरोरा. पुणकर साहेबांनाच विनंती आहे त्यांनी हा सन्मान करावा. अदानी पॉवर लिमिटेड तिरोरा. यानंतर आमंत्रित करते रतन इंडिया पॉवर लिमिटेड. रतन इंडिया पॉवर लिमिटेड कृपया समोर यावं. प्रतिनिधींनी समोर यावं. रतन इंडिया पॉवर लिमिटेड. रतन इंडिया आले आहेत का? यानंतर साई वर्धा पॉवर जनरेशन प्रायव्हेट लिमिटेड. मी जयस्वाल साहेबांना विनंती करते त्यांनी सन्मान करावा. साई वर्धा पॉवर जनरेशन प्रायव्हेट लिमिटेड. साई वर्धा झालं. चंद्रपूर सुपर थर्मल पॉवर स्टेशन जयस्वाल साहेबांनी करावा अशी विनंती. चंद्रपूर सुपर थर्मल पॉवर स्टेशन. नॅशनल थर्मल पॉवर कॉर्पोरेशन लिमिटेड NTPC. नॅशनल थर्मल पॉवर कॉर्पोरेशन लिमिटेड. यानंतरचा सन्मान संजय मारुडकर साहेबांनी करावा अशी विनंती करते. आयडियल एनर्जी प्रोजेक्ट्स लिमिटेड. आयडियल एनर्जी प्रोजेक्ट्स लिमिटेड. संजय मारुडकर साहेबांना विनंती, त्यांनी हा सन्मान करावा. आयडियल एनर्जी प्रोजेक्ट्स लिमिटेड. टाळ्या वाजत राहिल्या पाहिजेत, कारण अतिशय महत्त्वपूर्ण व्यक्ती आहेत या, ज्यांच्या सहयोगितेशिवाय ही कॉन्फरन्स अशक्य होती. आयडियल एनर्जी प्रोजेक्ट्स लिमिटेड. धारीवाल इन्फ्रास्ट्रक्चर लिमिटेड. धारीवाल इन्फ्रास्ट्रक्चर लिमिटेड. यानंतर आमंत्रित करते खापरखेडा थर्मल पॉवर स्टेशन. धारीवाल इन्फ्रास्ट्रक्चर लिमिटेड. खापरखेडा थर्मल पॉवर स्टेशन आणि कोराडी थर्मल पॉवर स्टेशन. खापरखेडा थर्मल पॉवर स्टेशन आणि अंतापूरकर साहेबांच्या शुभ हस्ते हा सन्मान. पारस थर्मल पॉवर स्टेशन. पारस थर्मल पॉवर स्टेशन. इवोनिथ व्हॅल्यू स्टील लिमिटेड. इवोनिथ व्हॅल्यू स्टील लिमिटेड. आणि इवोनिथ व्हॅल्यू स्टील लिमिटेड. आणि गॅलेक्सी सोलार इंडस्ट्रीज. गॅलेक्सी सोलार इंडस्ट्रीज. धन्यवाद. मान्यवरांना विनंती, आपण स्थानापन्न व्हावं आणि यानंतर आपल्याशी संवाद साधावा अशी विनंती मी माननीय धवल अंतापूरकर साहेबांना करणार आहे. त्यांना विनंती आहे, त्यांनी आजच्या या कॉन्फरन्सविषयी आपल्याशी संवाद साधावा. माननीय श्री धवल अंतापूरकर साहेब.
नमस्कार. कसे आहात सर्व? ब्रेकफास्ट अँड ऑल डन? ओके. ब्लड डोनेशन केलेत का? ज्यांनी ब्लड डोनेट केले त्यांनी हात वरती करावा. त्यांना अर्धा दिवस सुट्टी द्यायला मी त्यांच्या हेड्सला सांगेल पॉवर प्लांटकडून. तर मित्र, आज पुन्हा इथे नागपूर नगरीमध्ये, जे की महाराष्ट्राचं पॉवर हाऊस म्हणून ओळखलं जाते, इथे आपणा सर्वांचं स्वागत करताना खूप आनंद होतो आहे. पॉवर हाऊस दोन सेन्समध्ये आपण म्हणतो. पहिले की इथे सर्वात जास्ती पॉवर स्टेशन्स आहे विदर्भामध्ये आणि नागपूर रिजनमध्ये, आणि दुसरं आपणा सर्वांना माहितीच आहे. तर मित्र, BWU चं पहिलं एडिशन बॉयलर BWU WeldConnect याचं उद्घाटन आज ज्यांच्या हस्ते होत आहे ते महाराष्ट्राचे आणि आपणा सर्वांचे अतिशय लाडके, अतिशय धडाडीने काम करणारे आणि तळागाळातील लोकांपर्यंत ज्यांचे काम पोहोचलेले आहे असे कामगार मंत्री महाराष्ट्र राज्य आज इथे आपल्याला लाभलेले आहे. खूप खूप धन्यवाद सर. आज आणि सर आले खामगाववरून, वेळात वेळ काढून आले, त्याबद्दल त्यांचे खूप खूप आभार. त्याचप्रमाणे नागपुरातीलच आणि जे अतिशय धडाडीने काम करतात, पहिल्याच दिवशी जॉईनिंगच्या दिवशी त्यांनी कामाचा इतका धडाका लावला, इतक्या मीटिंग्स घेतल्या, असे आपले कामगार राज्यमंत्री श्री आशिष जयस्वालजी पण इथे आलेले आहेत. सर आपलं पण खूप स्वागत आहे. त्याचप्रमाणे महाजेनकोचे जेवढे पॉवर प्लांट्स आहे त्याच्यामध्ये जे काही रेकॉर्ड्स बेंचमार्क तयार झालेले आहेत, मग ते PLFचे असो, मॅक्सिमम जनरेशनचे असो किंवा अवेलेबिलिटीचे असो, हे ज्यांच्या निदर्शनाखाली महाजेनको अचीव करू शकले ते आमचे जवळचे मित्र संजयजी मारुडकर सर, डायरेक्टर ऑपरेशन्स, हे सुद्धा इथे आहेत. त्यांचं मी स्वागत करतो. आणि ह्या BWU कनेक्टची ज्यांनी संकल्पना मांडली ते भानुराज गोपालन, OBTचे म्हणजे ऑरेंज बिग टेक्नॉलॉजीजचे CEO, ज्यांच्या संकल्पनेतून हा कार्यक्रम उभा झालेला आहे. त्यांनी हा कार्यक्रम केल्याबद्दल मी त्यांचे धन्यवाद देतो. त्याचप्रमाणे आमच्या गव्हर्नमेंटमध्ये ईज ऑफ डुईंग बिझनेस असतं, तसं मंत्री महोदयांचं ईज ऑफ डुईंग बिझनेस हे पाहणारे असतात त्यांचे PS. तर दुर्जड साहेब इथे आलेले आहे. मी दुर्जड साहेबांचं स्वागत करतो. त्याचप्रमाणे ईज ऑफ लिव्हिंग पाहणारे मिनिस्टर साहेबांचे पेसोडे सर पण इथे आलेले आहेत. त्यांचे मी स्वागत करतो. तर मित्रहो, आपणा सर्वांना माहितीच आहे की बॉयलर डिपार्टमेंट किंवा डायरेक्टरेट ऑफ स्टीम बॉयलर्स काय काम करत आहे. याच्यामध्ये डायरेक्टरेट ऑफ स्टीम बॉयलर्स जे काम करतं ते मुख्यत्वे 4 अंगावरती किंवा 4 फ्रंट्सवरती आपण काम करतो. याच्यामध्ये बॉयलर मॅन्युफॅक्चरिंग जो भाग आहे त्याचे मॅन्युफॅक्चरिंगच्या दरम्यान इन्स्पेक्शन करणे हा एक भाग आहे. दुसरा भाग आहे की इन्स्पेक्शन ऑफ बॉयलर्स इन यूज अँड देअर रजिस्ट्रेशन, हा दुसरा भाग आहे. तिसरं महत्त्वाचा भाग आहे की एक्झाम्स घेणं, बॉयलर अटेंडंट्स आणि बॉयलर ऑपरेशन इंजिनियर्सचे एक्झाम घेणं, हा एक महत्त्वाचा भाग आहे. आणि चौथा जो भाग आहे ज्याच्यावरती हा आजचा कार्यक्रम आधारित आहे तो आहे वेल्डर्स सर्टिफिकेशनचा. वेल्डर्सची परीक्षा घ्यायची आणि त्यांचे सर्टिफिकेशन करायची. तर असं हे महत्त्वाचं काम या डिपार्टमेंटमार्फत केलं जातं. मित्र, महाराष्ट्रामध्ये जवळपास दरवर्षी 1200 बॉयलर्सची निर्मिती होते आणि एशिया खंडामध्ये आपण सर्वात जास्ती बॉयलर्स बनवतो. मग हे बॉयलर्सच आहे फक्त असं नाही आहे, तर याच्याबरोबर आपण प्रेशर वेसल्सही बनवतो, हीट एक्सचेंजर्सही बनवतो, नंतर लागणारे त्याला माउंटिंग फिटिंग्स, या सगळ्यांमध्ये महाराष्ट्र हा अव्वल आहे. आणि याच्या जे एक छोटंसं श्रेय की एक्सपोर्ट्स वाढण्यामध्ये बॉयलर इंडिया जो प्रोग्राम करतो किंवा बॉयलर वर्ल्ड जो प्रोग्राम करतो आपण, त्याला नक्कीच जातं आहे. बरेचसे बॉयलर्स महाराष्ट्रातून एक्सपोर्ट होतात. 1200 बॉयलर्सपैकी महाराष्ट्रामध्ये 300 बॉयलर्स रजिस्टर होतात. बाकी जे बॉयलर्स बनतात ते नक्कीच इतरत्र दुसऱ्या स्टेटमध्ये किंवा एक्सपोर्ट होतात. तर असं हे मॅन्युफॅक्चरिंगचं आहे. आणि याच्यामध्ये सर्वात जास्ती जी स्किल रिक्वायरमेंट आहे ती आणि जी मिळत नाही ती आहे वेल्डर्स. वेल्डर्स जी आहे ते एका फॅक्टरीमध्ये, आता एक्झाम्पल म्हणून मी सांगतो की थर्मॅक्स एका कंपनीमध्ये जवळपास 460 वेल्डर्स आहे IBRचे. तर असे जे मॅन्युफॅक्चरर्स आहे महाराष्ट्रामध्ये 127 बॉयलर मॅन्युफॅक्चरर आहेत. तर रिक्वायरमेंट पहा वेल्डर्सची किती आहे. आणि मला सांगायला खूप खेद वाटतो की वेल्डर जे तयार होतात ते इथे विदर्भ रिजनमध्ये होत नाही आहे. तर इथले मुलं बसतच नाही आहे. म्हणजे त्यांचं क्वालिफिकेशन रिक्वायरमेंट काय आहे की त्यांनी पॉलिटेक्निक आपलं हे केलं पाहिजे, ITI केलेलं पाहिजे वेल्डिंग ट्रेडमध्ये, आणि त्याच्यानंतर त्याला 2 वर्षाचा एक्सपिरियन्स पाहिजे. तर असे मुलं आम्हाला इथे मिळतच नाही. तर तो एक फार मोठी त्रुटी आहे. दुसरं जे आपलं विषय होता तो रिन्युअल ऑफ सर्टिफिकेट्स. 5,000 बॉयलर्स चालू आहे महाराष्ट्रामध्ये, आणि सांगायला खूप आनंद होतो सर की ॲक्सिडेंटचे जे प्रमाण आहे ते अतिशय कमी आहे. मागच्या 10 वर्षामध्ये आपण ॲक्सिडेंट्स पाहिले तर नगण्य आहेत. पर्सेंटेज जे आहे ते 0.06% फक्त ॲक्सिडेंट्स महाराष्ट्रात झालेले आहेत. एक्झाम्स आपण घेतो बॉयलर अटेंडंट आणि बॉयलर इंजिनियर्सची. तर एक्झाम्सचं जी पूर्ण प्रक्रिया आहे ती संपूर्ण प्रक्रिया आपण ऑनलाईन केलेली आहे, आणि सर्वात जास्ती बॉयलर अटेंडंट्स आणि इंजिनियर्स महाराष्ट्राने तयार केलेले आहेत. आजपर्यंत जवळपास 18,000 आपण अटेंडंट्स दिलेले आहेत, आणि 8,000 इंजिनियर्स आपण क्वालिफाय केलेले आहेत. आणि ह्या इंजिनियर्सला पूर्ण भारतातच नव्हे तर भारताच्या बाहेरसुद्धा मोठी डिमांड आहे. तर आणि याचं मोठं एक गड वेल्डर्स इथे होत नाही, मात्र अटेंडंट्स आणि इंजिनियर्स या भागामध्ये मोठ्या प्रमाणामध्ये तयार होतात. चौथा जो भाग होता की वेल्डर्सचा, सर त्याच्यासाठी नागपूरला स्वतःचं ऑफिस नाही आहे जॉईंट डायरेक्टरचं. भाड्याच्या जागेमध्ये आपण होतो आतापर्यंत. आता इथे लेबर इन्स्टिट्यूटमध्ये एक छोट्या ह्याच्यामध्ये आपण आहोत. तर मागच्या काही वर्षांच्या फॉलोअपमुळे आम्हाला जागा अलोकेट झालेली आहे, आणि तिथे एक 26,000 स्क्वेअर फीटची जागा आहे, आणि तिथे आपण आता बॉयलर ऑफिस प्लस वेल्डर ट्रेनिंग इन्स्टिट्यूट आणि अटेंडंट्स आणि इंजिनियर्ससाठी रिफ्रेशर कोर्सेसचा आपण एक आराखडा तयार केलेला आहे, ज्याला सर आपण मान्यतासुद्धा दिलेली आहे. आणि आपण ह्या 100 डेजच्या जो माननीय मुख्यमंत्र्यांचा प्रोग्राम आहे 100 डेज, अतिशय स्तुत्य असा प्रोग्राम आहे, ज्याच्यामध्ये आपण हा घेणार होतो, पण ते पुढच्या 150 डेजमध्ये सुद्धा आपल्याला काहीतरी कामं पाहिजे नवीन, त्यामुळे आपण तो पुढच्या ह्याच्यात ठेवलेला आहे. आणि ते इन्स्टिट्यूट जे आपण तयार करू ते सर एक वर्ल्ड क्लास सेंट्रल इंडियामधलं असं एक छान इन्स्टिट्यूट आपण करू. वेल्डिंगसाठी वेल्डिंग रिसर्च इन्स्टिट्यूट त्रिचीलाच आहे. त्याच्या व्यतिरिक्त असे काही सर्टिफाईंग हे नाही आहेत कॉलेजेस किंवा हे गव्हर्मेंटचे. तर ते एक फार चांगलं स्टेप आपल्याकडून होईल अशी आशा आहे. या वर्षामध्ये 150 डेजमध्ये त्या बिल्डिंगची पायाभरणी आपण करूया, आणि येथील सचिन चौधरी जॉईंट डायरेक्टर ते काम पूर्ण करतील अशी आशा बाळगतो. बाकी वेल्डर्ससाठी वेल्डर्स इथे तर आज मला वाटतं इथे आज वेल्डर्स नाही आहे. आपल्या इथे फक्त इंजिनियर्स आणि अप्पर लेवलचे लोक इथे आलेले आहेत. तर आपण हे जे सेमिनार आहे याचे जे टॉपिक्स आज घेतलेले आहे अतिशय चांगले टॉपिक BWUनी घेतलेले आहे. तर याचा फायदा आपण नक्कीच घ्यावा. स्पीकर्स जे आहे ते खूप अक्लेम्ड स्पीकर्स इथे आपल्याला लाभलेले आहेत. पहिलं सेशन जे आहे तो आहे सर याचा फ्लेक्झिबलायझेशनचा. सर फ्लेक्झिबलायझेशन म्हणजे पॉवर प्लांट्सला सध्या जे थर्मल पॉवर प्लांट्स होते ते बेस लोड कॅटर करायचे, पण आता जे पॉवर प्लांट्स आहे त्यांना पीक लोडसारखं चालवायला भाग पडलेला आहे. तर ही जी फ्लेक्झिबिलिटी आहे पॉवर प्लांट्समध्ये जी आणतो आपण की 500 मेगावॉटचा प्लांट आहे आणि त्याला टर्न डाऊन करून कमी लोडवरती चालवायचं, असं करताना खूप अडचणी येतात. तर हा एक विषय याच्यामध्ये घेतलेला आहे. म्हणजे एखादी मोठी गाडी आहे आणि ती आपण बॉम्बेच्या ट्रॅफिकमध्ये चालवतो, तशी जी परिस्थिती होते तशी परिस्थिती हे पॉवर स्टेशन चालवणाऱ्यांची होते. म्हणजे कोळसा कुठला आहे त्याच्याबद्दल आपल्याला बोलता येत नाही, मात्र एफिशियन्सी आपल्याला मिळाली पाहिजे कमी लोडवर सुद्धा. तर असे जे प्रॉब्लेम्स आहे ते प्रॉब्लेम्स आपल्या इथे सॉल्व करून घ्यायचे आपल्याला आज. त्याच्यानंतर आहे वेल्डिंगचे एक्सपर्ट्स आपण बोलवलेले आहे. त्या वेल्डिंगच्या जे इश्यूज आहे सध्या, हाय सुपरक्रिटिकल बॉयलर्स आहे आणि व्हेरी हाय अलॉय स्टील्स आपण वापरलेलो आहोत. तर याच्यामध्ये वेल्डिंगमध्ये खूप इश्यू होतात. तर वेल्डिंगचे मुळे ट्यूब लिकेजेस जे होतात ते ऑलमोस्ट 26% ट्यूब लिकेजेस इथे वेल्डिंगमुळे होतात. तर ते कसे अवॉइड करायचे याचंसुद्धा ट्रेनिंग इथे दिलं जाणार आहे. तर याचा नक्कीच आपण फायदा घ्यावा. नंतर आहे एक आपण सोलारचं ठेवलेलं आहे. सोलारमध्ये नॉन कन्व्हेन्शनल एनर्जी यूज करून आपण जे ग्रिडची कनेक्टिव्हिटी करतो आहे ती पॉवर प्लांटसाठी कशी यूजफुल राहणार आहे, हे एक अतिशय महत्त्वाचा टॉपिक हा सुद्धा याच्यामध्ये घेतलेला आहे. तर ह्या सगळ्या टॉपिक्समध्ये आपण नक्की फायदा घ्यावा. नंतर आमचे जॉईंट डायरेक्टर आहेत ते RLAवरती देणार आहे. RLA म्हणजे सर रेसिड्युअल लाईफ असेसमेंट ऑफ बॉयलर्स, तो एक अतिशय महत्त्वाचा विषय आहे. बरेच जुने बॉयलर आहे, त्यांना सेफली कसे चालवायचे, त्यांचं उर्वरित आयुष्य किती आहे, हे याच्यासाठी ती RLA स्टडी आहे आणि त्याचंसुद्धा इथे प्रेझेंटेशन आपण ठेवलेलं आहे. तर या एक दिवसीय सेमिनारचं आपण फायदा घ्यावा. आणि जो उद्देश आहे आमचा, जो आम्ही मागे 10 वर्षापासून अवेअरनेस प्रोग्राम्स घेतो, तोच उद्देश हा BWU जो कनेक्ट आहे त्यांनी साध्य होणार आहे. आणि त्याचं फलश्रुती अशी राहणार आहे की आपल्याला एफिशियन्सी वाढेल पॉवर प्लांट्सची तुमची. नंतर आमच्यासाठी म्हणून ॲक्सिडेंट्स कमी होतील. नगण्य जरी असले तरी 0.06% ॲक्सिडेंट आहेतच. तर हे सुद्धा आपल्याला 0% पण आणायचं टार्गेट आहे. ते ह्या अशा प्रोग्राम्समुळेच अचीव होतं. तर मी एवढं बोलून माझं भाषण संपवतो. थँक्यू सर फॉर कमिंग हिअर. थँक्यू.
धन्यवाद अंतापूरकर साहेब. यानंतर आज मंचावर विशेषत्वानं उपस्थित असलेले संचालक महाराष्ट्र राज्य वीज निर्मिती श्री संजय मारुडकर साहेबांना विनंती आहे त्यांनीही आपल्याशी संवाद साधावा.
आज या BWU कनेक्ट याच कॉन्फरन्ससाठी इनॉग्रेशन सेशनला उपस्थित असलेले महाराष्ट्र राज्याचे कामगार मंत्री माननीय श्री आकाशजी फुंडकर साहेब, महाराष्ट्र राज्य कामगार राज्यमंत्री माननीय श्री आशिषजी जयस्वाल साहेब, आमचे मित्र आणि डायरेक्टरेट बॉयलर श्री धवल अंतापूरकर सर, आमचे मित्र श्री भानुगोपालजी, सर्व उपस्थित डेलिगेट्स, consultants, all engineers in this field, आणि आज जे पर्टिक्युलरली आजची कॉन्फरन्स जे डिलिव्हर करणार आहेत, म्हणजे जे टॉपिक्स चूज केलेले आहेत ते डिलिव्हर करणारे आजचे वक्ते. मित्रांनो, दिस इज द राईट टाईम. म्हणजे अंतापूरकर साहेबांनी जो हा विषय घेतलेला आहे हा आपल्या सगळ्यांसाठीची ही सध्याची एक मेजर समस्या आहे. इट्स अ मेजर प्रॉब्लेम. वी आर इन द एरा नाव की आपण आता जुना जो कन्सेप्ट आहे आपला की पॉवर स्टेशन चालवायचे 90% PLF घ्यायचा, 100% PLF घ्यायचा, फुल लोडवर चालवायचे. जसं जसं रिन्युएबल आता आपल्या ग्रीडमध्ये येत आहे तसं तसं आपली विजेची गरज आणि दिवसाची वीज, पीक लोडची वीज याच्यामध्ये बराचसा फरक तफावत आपल्याला जनरेशनमध्ये दिसते. सर, महाराष्ट्र राज्याची या उन्हाळ्याची जर आपण परिस्थिती बघितली तर रात्री आम्ही 31,000 32,000 मेगावॅटपर्यंत आपल्या विजेची मागणी केली आणि दिवसा तीच मागणी 5-6 हजार मेगावॅटनी कमी होऊन जाते. त्या केसमध्ये आम्हाला काय होतं की दुपारी जे सोलर एनर्जी आपल्याकडे येते, सोलर एनर्जी जवळपास 5-5.5-6 हजारापर्यंत आपल्या ग्रीडमध्ये येते. 5.5-6 हजार ग्रीडमध्ये आली की आपल्याला दिवसा मग 6,000 मेगावॅटनी आपली थर्मल वीज निर्मिती कमी करावी लागते. या सगळ्या याच्यामध्ये सगळे जे आपले बॉयलरचे म्हणजे बॉयलरचे आपले थर्मल प्लांट्स आहेत ते बॉयलरला आपल्याला कमी लोडवर हळूहळू कमी आणावं लागतं. आणि जसं काय ग्रीडमध्ये ग्रीडला आपल्याला मेंटेन करायचं असतं एका फ्रिक्वेन्सीला, ती फ्रिक्वेन्सी मेंटेन करण्यासाठी डिमांड किती आहे आणि लोड किती आहे याचं बॅलन्स साध्य करावं लागतं. ते काम आपलं ग्रीड कंट्रोल म्हणजे LD सेंटर्स जे आहेत आपले महाराष्ट्रातले, नागपूरला आणि मुंबईला, ते दोघंजणं करतात. या केसमध्ये आता बॉयलरचं विअर अँड टिअर खूप वाढत आहे. एक तर आपल्याकडे म्हणजे महाराष्ट्रातली 50% कपॅसिटी, जवळपास 40% कपॅसिटी 30 वर्ष जुनी आहे, 30 इयर्स अँड अबोव. आणि जुने बॉयलर्स झालेले आहेत, त्याची विजेचे दर जास्त होतात कारण जुन्या काळातले डिझाईन्स आहेत ते. त्या केसमध्ये या प्लांटमध्ये मग डिस्कॉमही आजकाल आपल्याला लोकांना विजेचे दर कमी करायचे आहेत, तर स्वस्त वीज लोकांना द्यायची आहे. तर या सगळ्या गोष्टीचं तारतम्य साधताना आपल्याला आपल्या या थर्मलच्या बॉयलर्सवर ज्याचे आणि जे बॉयलर कमी करायची जी म्हणजे लोड कमी करायची जी पद्धत आहे, तर जे सगळ्यात कॉस्टली ज्याची वीज आहे ते पहिल्यांदा कमी करतात, त्याच्यानंतर दुसऱ्या 2 नंबरची कॉस्ट कुठली आहे ते दुसऱ्यांदा कमी करतात. असं करत 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 5,000 कमी येईपर्यंत आपल्याला कमी करावं लागतं. तर हे सगळं करताना बॉयलरवर कंटिन्युअस लोड फ्लक्च्युएशन्समध्ये स्ट्रेसेस डेव्हलप होतात आणि हे स्ट्रेसेस डेव्हलप झाले की बॉयलरच्या टेम्परेचर एस्कर्शन्स, वेल्डिंग जॉईंट्स फेल्युअर्स अशा टाईपचे बिघाड निर्माण होतात. त्याच्यामुळे फोर्स आउटेजची संख्या यावर्षी आपली जास्त झालेली आहे. आपण फोर्स आउटेज करतो, बॉयलरचं वेल्डिंग म्हणजे ट्यूब लिकेज अटेंड करतो, वेल्डिंग करतो, एक दिवसात बॉयलर घेतो. पण एखाद दिवशी जर अशी इमर्जन्सी आली की ग्रीडमध्ये 100 मेगावॅट कमी असेल आणि आपलं बॉयलर अवेलेबल नसेल तर आपल्याला पुन्हा महागाची वीज बाहेरून घ्यावी लागते. अशा टाईपचं हे चक्र आहे आणि हे डायनॅमिक म्हणजे युटिलिटी किंवा डायनॅमिक क्षेत्र असल्यामुळे याच्यामध्ये कंटिन्युअस आपल्याला काम करत राहावं लागतं. आणि या सगळ्या गोष्टीमध्ये आता हे जे चॅलेंजेस आहे की आपल्याकडे जसं धवल सरांनी सांगितलं की आपल्याकडे वेल्डर्सची कमतरता, म्हणजे आता याच्यामध्ये जे वेल्डर एखादा जॉईंट मारतो आणि आपण त्याच्यात 2-3 टेस्ट घेतो पण तरी पण तो याच्यामध्ये फेल होऊन जातो. तर द स्किल ऑफ द वेल्डर्स दॅट इज द मोस्ट इम्पॉर्टंट दिस टाईम. मी बरेचदा धवल सरांची चर्चा करत असतो की आपल्याला जसं आपले सगळे लोक आपण त्रिचीकडून आपण सर्टिफाईड करून घेतो, टेस्टिंग करून तिकडचे वेल्डर्स घेतो, आपल्याकडे आल्यावर आपण त्यांच्या टेस्ट घेतो. पण तरी एक बघितलं की वेल्डिंग जॉईंट फेल्युअर्स म्हणजे माझे ऑब्झर्वेशन असे आहे की आमच्याकडे एखादा जॉईंट अटेंड केला की काही 1-2 महिन्यात पुन्हा दुसऱ्यांदा तोच सेम जॉईंट रिपीटेडली फेल होतो. सो दिस शुड स्टॉप. याच्यामध्ये काय आहे की आता आपल्याला चांगल्या स्किलचे वेल्डर्स आपल्या महाराष्ट्रात, आणि जसं आपण सांगितलं की पॉवर सेंटर आपलं नागपूर आहे, तसं महाराष्ट्र सर देशातला पॉवर सेंटर आहे. वी आर दी हायेस्ट अमंग ऑल दी जनरेटर्स इन इंडिया. त्याच्यामुळे महाराष्ट्रात नागपूरसारख्या ठिकाणी जर ही आपण संकल्पना आता सुरू केलेली आहे की इथे एक चांगल्या क्वालिटीचं आणि मी तर म्हणतो बेस्ट इन इंडिया जर आपल्याकडे एखादं इन्स्टिट्यूट सुरू करताय आणि शासनाच्या माध्यमातून ते होते आहे. सर, महानिर्मितीचे इथे 2 मोठे प्लांट्स आहेत. कोराडीचा 3x660 आहे, 210 आहे. खापरखेड्याचे 1340 मेगावॅट आहे. परत आम्ही इथे 2 प्लांट अजून 660चे आता मंजूर केलेले आहे शासनाने. त्याचं पण आमचं काम सुरू होईल आता थोड्या दिवसात. आणि परत इथे प्रायव्हेट IPPचे आहे, NTPC आहे. म्हणजे विदर्भ आणि चंद्रपूर एक मोठा पॉवर हब आहे आपला. चंद्रपूर, वरोरा, देन महाराष्ट्र, अमरावती ह्या सगळ्या याच्यामध्ये या झोनमध्ये जर एखादं असं इन्स्टिट्यूट झालं तर हे आपल्या राज्यासाठी, आपल्या म्हणजे शासनासाठी, पब्लिकसाठी आणि देशासाठी ही खूप महत्त्वाची एक आणि एक इट विल बी अ इनोव्हेटरी म्हणजे कसं म्हणतात त्याला एक आयडियासारखी आहे आणि हे झालं तर आपल्या सगळ्यांचा खूप फायदा होईल याच्यामध्ये. या उपक्रमाला मी माझ्याकडून महानिर्मितीतर्फे जो काही सपोर्ट लागेल आमच्या शासना थ्रू आम्ही तुम्हाला देऊ. माझं अंतापूरकरांना विनंती करेल की कोराडी ट्रेनिंग सेंटर आमचं ए ग्रेड CA सर्टिफाईड ट्रेनिंग सेंटर आहे. इथे काही तुम्हाला इमिजिएट स्टार्टिंग करायचं असेल, इकडचं काही समजा आपलं कन्स्ट्रक्शन वगैरे असेल तर तिथे काही कोर्सेस चालू करता येत असेल तर आपण वरच्या लेवलला बोलून आपण ते सॉल्व करू शकतो. तर इमिडिएटली सर ही गरज आहे. आणि आपल्या इथल्या याच्यामध्ये दुसरा एक फायदा सर आपल्या भूमिपुत्रांना इथले जे वेल्डर्स आहेत, ITIमध्ये आजकाल लोक ॲडमिशन घेताना वेल्डिंगचा कोर्स करायला जात नाही पोरं आजकाल आपले, तर त्यांनाही एक चालना मिळेल की बाबा इथे चांगलं काम आहे. आणि त्यांचे रेट्स पण आहे बाकी जो कामगार कायद्याप्रमाणे आपण रेट देतो त्याच्यापेक्षा हाय प्रेशर वेल्डरची रेट्स कॉस्ट जास्त असते. एक जॉईंटप्रमाणे त्यांची कॉस्ट असते. तर इथल्या आपल्या तळागाळातल्या लोकांना जे आपले मुलं आहेत त्यांना पण तो खूप फायदा होईल. हा मी एक खूप चांगला उपक्रम अंतापूरकर साहेबांनी संकल्पना मांडलेला सुरू होतो आहे याचा मला आनंद आहे. आणि मी सरांचे पर्टिक्युलरली कामगार विभागाचे खूप आभार मानतो याच्यासाठी. दुसरं म्हणजे आजच्या या कॉन्फरन्समध्ये यू आर गोइंग टू डिस्कस ऑल द डिलिव्हरी म्हणजे तुम्ही टॉपिक्स घेतलेले आहेत तेही खूप छान टॉपिक्स आहेत. RLA एक चांगला विषय आहे. रेसिड्युअल लाईफ असेसमेंट ते जुन्या बॉयलरसाठी आपल्याला करणं गरजेचं आहे. आपल्या महाजेनकोमध्ये सर 32 बॉयलर्स आहेत टोटल. आणि 32 बॉयलरचं ओव्हरऑलिंग नंतर फेल्युअर्स अटेंड करणे त्याच्यासाठी लागणारे वेल्डर खूप मॅनपॉवर लागते. तर हा एक उपक्रम एक चांगला सुरू केलेला आहे तुम्ही. आणि आजच्या या कॉन्फरन्समध्ये सगळे टॉपिक सिन्सिअरली डेलिबरेट करा. एक चर्चासत्रासारखं क्वेश्चन्स विचारा, आपले डाऊट्स क्लिअर करून घ्या आणि या सगळ्या गोष्टीचा आजच्या या कॉन्फरन्सचा भरपूर फायदा घ्या अशी मी आपल्या सगळ्यांना विनंती करतो. आणि सरांचे आभार मानतो की मला इथे अपॉर्च्युनिटी दिली. थँक्यू व्हेरी मच.
मनापासून धन्यवाद साहेब. यानंतर ज्यांना ऐकण्यासाठी आपण सगळे उत्सुक आहोत, आपल्या वैशिष्ट्यपूर्ण कार्यशैलीसाठी प्रसिद्ध असलेले आपल्या सगळ्यांचे लाडके नेते माननीय नामदार श्री आशिष जयस्वाल साहेबांना विनंती आहे त्यांनी आपल्याशी संवाद साधावा.
बॉयलर वर्ल्ड अपडेट वेल्ड कनेक्ट या कॉन्फरन्सला उपस्थित माननीय आकाशजी फुंडकर, अंतापूरकरजी, संजयजी माडुकर, भानू राजगोपालनजी आणि उपस्थित या क्षेत्राचे प्रत्यक्ष अप्रत्यक्ष संबंधित असलेले सर्व उपस्थित मान्यवर बंधूंनो, एक अतिशय महत्त्वाच्या विषयावर ही कॉन्फरन्स आयोजित करण्यात आली त्यासाठी मी सर्व आयोजकांना मनापासून धन्यवाद देतो. आपल्या सर्वांना कल्पना आहे की आपला जो महाराष्ट्र आहे तो अनेक गोष्टीमध्ये आपण अग्रक्रमात आहोत. इन्फ्रास्ट्रक्चर प्रोजेक्टमध्ये आपण अग्रक्रमात आहोत. या देशामध्ये आपण नेहमी म्हणतो की सर्वात पुढे महाराष्ट्र माझा. अनेक गोष्टीमध्ये आपण काम करत असताना नवीन इनोव्हेशन, नवीन टेक्नॉलॉजी, स्किल्ड मॅनपॉवर या सर्व गोष्टीवर आपल्याला काम करणं अत्यंत गरजेचे असते. मागील 10 वर्षात विशेष करून किंवा 15 वर्षात आपण खूप मोठ्या प्रमाणामध्ये कौशल्य प्रशिक्षणावर भर दिला. सरकारतर्फे जेव्हा एखादी योजना येते तेव्हा त्या योजनेमध्ये जी आपली उद्दिष्टाची पूर्तता आहे ते पूर्णपणे होत नाही. जेव्हा आपण एखादा विशिष्ट अभ्यासक्रम सुरू करतो तो अभ्यासक्रम केंद्रित असतो एखाद्या युवकाला प्रशिक्षित करण्यासाठी, परंतु तो युवकाला प्रशिक्षित करण्यासाठी अभ्यासक्रम चालवणाऱ्या लोकांसाठी देखील ती एक सोय निर्माण होते. आणि मग त्याचा परिणाम असा होतो की ज्याची डिमांड आहे त्याचा सप्लाय होत नाही. आपला साधा प्रिन्सिपल आहे की डिमांडनुसार सप्लाय व्हायला पाहिजे. आपल्या राज्याला, आपल्या देशाला कशा पद्धतीचं प्रशिक्षित मनुष्यबळाची गरज आहे त्या पद्धतीचं प्रशिक्षण आणि त्या पद्धतीची डिमांडनुसार सप्लाय करणं खूप आवश्यक असते. बॉयलरच्या क्षेत्रामध्ये जसं आपण सांगितलं की वेल्डरची खूप मोठ्या प्रमाणामध्ये गरज आहे आणि आपण विदर्भामध्ये या गोष्टीमध्ये फार मागे आहो, हे देखील एक कटू सत्य त्यांनी या ठिकाणी सांगितलं. व्यवस्थेमध्ये किती दोष असला तरी राज्यकर्ते म्हणून आपण सर्वांनी मिळून हा दोष दूर करायचा असते. व्यवस्थेला दोष देऊन होणार नाही, तर व्यवस्थेतील दोष आपण दूर करायला पाहिजे. आणि हळूहळू त्या दृष्टीने आपली वाटचाल सुरू आहे. आणि आजच्या कार्यक्रमाच्या माध्यमातून अतिशय काही महत्त्वाच्या सूचना या ठिकाणी दिलेल्या आपलं सेंटर नागपूरला सुरू होणारच आहे. परंतु त्यापुढे देखील आजच्या दिवसभराच्या वेगवेगळ्या टॉपिकवर जेव्हा चर्चा होईल, त्यातून देखील जे काही आउटपुट होईल त्या संदर्भामध्ये जर आपण योग्य शिफारशी केल्या तर त्यावर निश्चितच आम्ही दोघंही विचार करून त्या संदर्भामध्ये उचित निर्णय करू. परंतु ही बाब सत्य आहे की अजून महाराष्ट्राला आपल्याला खूप पुढे न्यायचं आहे. आणि त्यामुळे जी नवीन तंत्रज्ञान येत आहे, नवीन इनोव्हेशन येत आहे, त्या दृष्टीने आपल्याला अपडेट होणं, त्यापेक्षाही पुढचा विचार करणे आणि त्या सर्व जी काही जिथं जिथं आपलं कमतरता आहे त्याला भरून काढणे, हे एक मोठं टास्क आणि महत्त्वाचं टास्क आहे. आणि मला विश्वास आहे की या पद्धतीच्या आयोजनातून जे काही आउटपुट आपलं बाहेर निघणार आहे त्या दृष्टीने तिथंच आपण न थांबता ते उद्दिष्ट आपलं साध्य करेपर्यंत आपण त्याचा पाठपुरावा करावा. आणि आम्ही या विषयासाठी सदैव सोबत आहोत. आम्ही दोघे विदर्भाचे आहोत आणि त्यामुळे विदर्भाला या संदर्भामध्ये या सेक्टरमध्ये लवकरात लवकर जी काही आवश्यक निर्णय ते आपण निश्चितपणे करूया. दुर्दैवाने आज अशी परिस्थिती आहे की आपण किती जरी विचार केला तरी आपण व्यवस्थेतील काही दोष आहे मी नाकारत नाही. आज इंजिनियरची गरज नाही आहे, परंतु आपण सर्व अभ्यासक्रम फ्री करून टाकले, त्यामुळे कॉलेजवालेच विद्यार्थ्यांना पकडतात. 100% SC/ST फ्री माफी आहे, OBCला माफी आहे आणि आता मुलींना शिक्षण फ्री केलं. मग फक्त पैदा करायचा, परंतु ते निर्माण केलेले आपले प्रशिक्षित मनुष्यबळ याचं काम किती आहे, त्याची गरज किती आहे, याचं कधीच मूल्यमापन होत नाही. आणि ज्याची समाजाला गरज आहे, ज्याची उद्योजकाला गरज आहे, त्याची निर्मिती करण्यासाठी आपल्याला प्रयत्न या ठिकाणी होत नाही. परंतु वेल्डरच्या सेक्टरमध्ये आपल्या भागात जी काही कमतरता आहे ते निश्चितपणे पूर्ण करण्याच्या दृष्टीने आपल्या सर्वांनाच प्रयत्न करणे गरजेचं आहे. मी देखील या विषयावर लक्ष घालेल एवढं मी आपल्याला या ठिकाणी आश्वस्त करतो. आणि आज एक अतिशय महत्त्वाच्या विषयावर हे जे चर्चासत्र या ठिकाणी होईल, त्यातून भविष्यामध्ये आपलं एक विजन डॉक्युमेंट, आपलं प्लान हे देखील करणं आवश्यक आहे. सर्वात महत्त्वाचं आहे की अपघातापासून सुरक्षा, अपघात होऊ नये. आज दुर्दैवाने मागील 2-3 महिन्यात अनेक अपघात वेगवेगळ्या इंडस्ट्रीमध्ये झाले आणि त्याच्यातून अनेक प्रश्न त्या ठिकाणी उद्भवतात. त्यामुळे सेफ्टीमध्ये कुठल्याही तडजोड करता कामा नये. महाराष्ट्राला आपल्याला अधिक पुढे न्यायचं आहे. जगामध्ये भारत आता महासत्ता होण्याच्या मार्गावर आहे. एक वेगाने आपण विकसित भारत आणि विकसित महाराष्ट्राच्या संकल्पनेवर काम करत आहोत. माननीय देवेंद्रजी यांनी पहिले 100 दिवसाचा कार्यक्रम दिला होता, नंतर 150चा आता आम्हाला टार्गेट दिलेला आहे. आणि एखादा 100 दिवसाचा कार्यक्रम जेव्हा ठरतो तेव्हा त्या कालावधीतच आपल्याला तो टार्गेट अचीव करायचा असतो. महाराष्ट्रामध्ये प्रत्येक विभागाला तशा पद्धतीचा टार्गेट आहे आणि एक सक्षम नेतृत्व महाराष्ट्रामध्ये देवेंद्रच्या स्वरूपात आपल्या नागपूरमध्येच आपल्याला तो लाभलेला आहे. आणि विदर्भाचे आणि आपल्या भूमीचे जे काही प्रश्न आहे ते सर्व प्रश्न सुटले पाहिजे, त्याच्यातून योग्य मार्ग निघाला पाहिजे. त्यासाठी अतिशय योग्य ही संधी आहे. आणि मला विश्वास आहे की अशा पद्धतीच्या चर्चेतून निश्चितच काहीतरी चांगलं साध्य होईल आणि भविष्यामध्ये सर्व सेक्टरमध्ये विदर्भाची आणि नागपूरची प्रगती व्हायला पाहिजे. आपल्या सर्वांना या गोष्टीचा अनुभव आला असेल की नागपूरला नेतृत्व मिळाल्यापासून आपण महाराष्ट्रामध्ये जो विदर्भ मागासलेला होता तो अतिशय वेगाने पुढे येत आहे. अनेक गोष्टीमध्ये आता विदर्भ आणि आता भविष्यामध्येच आता माझ्यापूर्वी संजयजींनी सांगितलं की आता हा जो दिवसाचा आहे, आता सोलरवर आपण खूप मोठ्या प्रमाणात जाणार आहोत. आता आपण घरामध्ये रूफटॉप देणार आहोत. घरामध्ये आपण देवेंद्रजी आणि माझी एकदा चर्चा झाली एका कार्यक्रमात की आता दर महिन्याला आपण विजेचं बिल भरत आहोत, परंतु एक दिवस असा येईल की आपण दर महिन्याला म्हणू की महावितरणला की माझे पैसे काढ, माझी एवढे वीज जनरेट झालेली आहे. म्हणजे जे 50 वर्षापासून आपण महावितरणाला पैसे देतो किंवा MSEBला पूर्वीच्या, आता आपण MSEB पासून पैसे घेणार आहोत. इतक्या पद्धतीची वीज घराच्या टॉपवर जनरेट होणार आहे. आणि त्यामुळे दिवसामध्ये आपली वीज ही जास्तीत जास्त जनरेट होणार ना, रात्रीची आपली घरं जास्तच राहणार आहे. ही जे चॅलेंज आहे ते अधिक वाढणार आहे भविष्यामध्ये. आता तर तुम्ही तो चॅलेंज सांगितलंच आहे, परंतु दरवर्षी हे आव्हान आपल्यासमोर वाढत जाणार आहे. मग या सर्व आव्हानाला तोंड देण्यासाठी आज आपली 5000 मेगावॉट असेल तर उद्या 15000 मेगावॉटपर्यंत आपल्याला दिवसात वीज निर्माण होईल. आणि मग ही जी तुमची सर्कस आहे बॉयलरच्या मेंटेन करायची ती अधिक वाढणार आहे आपल्यासमोर. मग हे चॅलेंज भविष्यात ज्या पद्धतीने राहणार आहे त्याच्यावर काय उपाययोजना करायला पाहिजे याचं देखील प्लॅनिंग हे आजपासून करणं आवश्यक आहे. भविष्यातील आपले चॅलेंजेस आणि त्या चॅलेंजेसवर काय उपाययोजना करणं आवश्यक आहे ते सर्व आपण करावं, त्या दृष्टीने नियोजन करावं. आणि राजगोपालनजी आणि त्यांचे सर्व सहकारी यांना मी मनापासून पुन्हा एकदा धन्यवाद देतो. आणि मला विश्वास आहे की एक बॉयलर सेक्टर नाहीत, अशा पद्धतीच्या सर्व सेक्टरमध्ये जेही आपल्याला आवश्यक वाटत असेल की हा निर्णय आपल्या दृष्टीने करणं आवश्यक आहे, अशा पद्धतीचं धोरण करणं आवश्यक आहे, हा निर्णय सरकारकडून आवश्यक आहे, या मनुष्यबळाची गरज आहे, या संदर्भामध्ये आपल्याला कारवाई करणं आवश्यक आहे. इथे आमची अडचण, ही अडचण आमची दूर करून द्या. आम्ही आपल्यासाठी सदैव उपलब्ध. आपण सांगा काय करायचं आहे. सरकार तुमच्या मागणीनुसार तुमच्या सूचनेची निश्चितच दखल घेऊन लवकरात लवकर त्या संदर्भामध्ये निर्णय होईल, हे सरकारचा एक मंत्री म्हणून या ठिकाणी आपल्याला आश्वस्त करतो. आणि विदर्भाच्या विकासाच्या दृष्टीने, विदर्भाच्या गरजाच्या दृष्टीने, विदर्भाच्या भविष्याच्या दृष्टीने, विदर्भाची पुढची गरज लक्षात घेता काय आपल्या मौलिक आणि महत्त्वाच्या सूचना त्या आपण निश्चितपणे आम्हाला सांगावा, एवढीच आपल्याला विनंती करतो. आपल्या प्रत्येक सूचनेचा आदर करून त्या दृष्टीने योग्य ती कृती सरकार करेल एवढी ग्वाही देतो. धन्यवाद. जय हिंद, जय महाराष्ट्र.
मनापासून धन्यवाद साहेब. आपल्या महत्त्वपूर्ण अशा विचारांसाठी आपले मनापासून आभार. यानंतर आपल्या वडिलांच्या परंपरेचा समृद्ध वारसा पुढे चालवत तळागाळातील लोकांसाठी प्रचंड काम करणारे आणि आपल्या कार्यशैलीसाठी प्रसिद्ध असणारे आपल्या सगळ्यांचे लाडके मंत्री माननीय नामदार श्री आकाश कुंडकर साहेबांना आम्ही इथे सन्मानपूर्वक आमंत्रित करते. विनंती करते त्यांनी आजच्या या कॉन्फरन्सच्या निमित्तानं आपल्याशी संवाद साधावा.
BWU कनेक्ट आजचा हा एक दिवसीय कार्यशाळा हा जो कार्यक्रम आहे या निमित्तानं मंचावर उपस्थित आपल्या राज्याचे 5 खाते आहेत भाऊ तुमच्याकडे, 6 खात्यांचे राज्यमंत्री, आमचे सहकारी, आमचे बंधू आणि विशेष म्हणजे खूप अभ्यासू आणि खूप स्पीडनी काम करणारे आमचे आशिषजी जयस्वाल, मंचावर उपस्थित अंतापूरकर साहेब, मारोळकर साहेब, ज्यांनी हा कार्यक्रम घडवून आणण्यात विशेष भूमिका राबवली असे राजगोपालनजी, माझ्यासमोर बसलेले सर्व मान्यवर, सर्व इंजिनियर्स, सर्व मोठ्या मोठ्या कंपनीजचे सर्व की पोस्टचे सर्व मेन अधिकारी, पदाधिकारी आणि माझ्या बंधूंनो, सर्वप्रथम आजच्या या कार्यक्रमाचं उद्घाटन झालं असं मी जाहीर करतो. बॉयलर वर्ल्ड अपडेट वेल्ड कनेक्ट. खरं तर शेवटी बोलणं म्हणजे फार कठीण असतं साहेब. तुम्ही सगळ्यांनी सगळं मांडलेलं आहे, आता मी काय मांडलं आहे. पण आपण आज आम्हाला बोलवलं. आजचा हा दिवस आणि आजचाच दिवस हा राष्ट्रीय तंत्रज्ञान दिवससुद्धा आहे. याच दिवशी पोखरणच्या अणुचाचण्या झाल्या होत्या आणि त्याचीच आठवण म्हणून आजचा हा योग आपण घडवून आणला. त्याबद्दल सर्वप्रथम आपलं अभिनंदन करतो. आणि खरोखर आजचा हा कार्यक्रम म्हणजे आपल्या सगळ्यांना एकमेकांमध्ये संवाद घडवण्याचा हा कार्यक्रम आहे. आज रविवारचा दिवस आहे. तुम्ही सगळेजण फार चांगल्या चांगल्या वक्त्यांना ऐकायला इथं आलेले आहे आणि तुम्ही म्हणत असाल की सकाळची सुरुवात राजकारण्यांच्या भाषणांनी होते आहे, त्यामुळे कुठेतरी थांबलं पाहिजे. पण मी जास्त वेळ घेणार नाही आहे. आजचा हा कार्यक्रम एवढ्या मोठ्या संख्येनं आपण इथे आले हे आपल्या आयडियाज एक्सचेंज करायसाठी आले आहे आणि समोरचे जे चॅलेंजेस आहेत ते काय असतील, यावर काय सोल्युशन असतील, यावर चर्चा करण्यासाठी आपण इथे आले आहे. आयोजकांनी खूप चांगल्या चांगल्या वक्त्यांना आज इथे बोलवलेलं आहे. खूप चांगले चांगले विषय आहेत आणि माझी आपल्याला विनंती असणार आहे की आपण शेवटच्या वक्त्याला ऐकून जावं. बरेचसे सेमिनार आम्ही अटेंड करतो, पहिला दुसरा झाला की मग हळूहळू संख्या कमी व्हायला लागते. पण मी आपल्याला विनंती करणार आहे की शेवटच्या वक्त्यापर्यंत आपण सगळ्यांनी या सेमिनारचा फायदा घेतला पाहिजे. कारण आज बॉयलर हा विषय इतका क्लिष्ट आहे की बॉयलरशिवाय इंडस्ट्री चालू शकत नाही आणि बॉयलर जोपर्यंत आपण व्यवस्थित मेंटेन करणार नाही, बॉयलरवर आपल्या इंडस्ट्रीचं प्रोग्रेस म्हणजे डिपेंडंट असते. आपली जेवढी प्रोडक्शन आहे, आपलं जेवढं काही काम आहे हे बॉयलरवर डिपेंडंट आहे आणि बॉयलर जर आपण वेल मेंटेन ठेवला नाही तर त्याचे आपल्या ग्रोथवर इफेक्ट होत असतात. त्यामुळे हा जो बॉयलर हा विषय घेऊन आजचे हा सेमिनार आयोजित केलेला आहे, निश्चित या दृष्टीने आज आपण सगळेजण एकमेकांशी आपल्या आयडियाज शेअर करणार आहे. शेवटी आपण म्हणतो की नॉलेज इज पॉवर आणि शेअरिंग इज की टू ओपन द पॉवर. त्यामुळे जोपर्यंत आपण एकमेकाशी शेअर करणार नाही, आपले आयडियाज शेअर होणार नाही, तोपर्यंत आपल्याला आपले प्रॉब्लेम्स सॉल्व्ह होणार नाही. आणि आजचे जे वक्ते आलेले आहेत, विशेषतेने ते ज्या ज्या गोष्टी आपल्यासमोर मांडणार आहे, आज आपण पाहतो आहे AI तंत्रज्ञानाचा मोठ्या प्रमाणात वापर आता सुरू झाला आहे. AIच्या माध्यमातून, रोबोटिक्सच्या माध्यमातून बॉयलर्समध्ये काही सुधारणा आणू शकतो का? रोबोटिक्सच्या माध्यमातून नवीन नवीन काही कन्सेप्ट येऊ शकतात का? त्यामध्ये बऱ्याच गोष्टी आपल्याला नवीन आणता येतील का? जसं आज मारोळकर साहेबांनी सांगितलं, 30-30 वर्ष जुने बॉयलर्स आज आपल्या भागामध्ये आहेत. त्या बॉयलर्सवर आपण काम करतो आहे आणि रेग्युलरली त्यामध्ये फॉल्ट येतात, तुम्हाला ते रिपेअर करावं लागतात. आज मॅनपॉवरची कमी आहे, मग रोबोटिक्सच्या माध्यमातून ही कमी दूर होऊ शकते का? त्यामुळे अशा अनेक विषयांवर आज इथे चर्चा घडू शकते आणि खऱ्या अर्थानं आपण सगळेजण जेव्हा एकत्र येता तेव्हाच या आयडिया शेअरिंग होतात. आपण प्रॅक्टिकली त्या फील्डमध्ये काम करत असता आपल्याला डे टू डे वर्किंगमध्ये माहिती आहे की कधी कोणता प्रॉब्लेम येऊ शकतो, कोणत्या गोष्टीमुळे कोणता प्रॉब्लेम येऊ शकतो आणि त्या दृष्टीनं आजची ही सेमिनार आपण सगळ्यांनी सक्सेसफुल करावी. आज बॉयलर डिपार्टमेंटचे जे आमचे डायरेक्टर आहेत अंतापूरकर साहेब, मी यांचं विशेष करून अभिनंदन करणार आहे. खूप डेडिकेटेडली काम करतात, खूप त्यांचं म्हणजे जीव तोडून प्रत्येक विषयाशी त्यांचं काम असते. आणि आत्ताच आम्ही BMMS नावाचं पोर्टल सुरू केलं आहे, ज्यामुळे इंडस्ट्रीजला, मॅन्युफॅक्चरर्सला सुलभता यावी. सगळं गव्हर्नन्स करून तुम्हाला आम्ही एका पोर्टलवर देतो आहे, जेणेकरून तुम्हाला ज्या परमिशन्स लागतात, ज्या काही हे आहेत, इन्स्पेक्शन्स आहेत, हे सगळं त्या पोर्टलच्या माध्यमातून सुलभ व्हावं आणि अनेकानेक सुधारणा आम्ही भविष्यात आणतो आहे. कारण शेवटी आपल्या सगळ्यांचं मत घेतल्याशिवाय या सुधारणा करणे चुकीचं असते. प्रॅक्टिकल नॉलेज तुमच्याजवळ आहे, तुम्हाला ज्या ज्या अडचणी येणाऱ्या आहेत त्या आपण आम्हाला सुचवल्या पाहिजे आणि त्या माध्यमातूनच आपला आणि सरकारचा समन्वय जेव्हा असेल तेव्हा अधिक सुलभता येणाऱ्या काळामध्ये करता येईल. आणि हे पोर्टल आपण सगळ्यांनी म्हणजे या पोर्टलच्या बाबतीतही आपण आपल्या व्हॅल्युएबल सूचना आम्हाला द्याव्या. कारण मला वाटते देशातलं हे पहिलं पोर्टल आपण सुरू केलेलं आहे, ज्यामध्ये अंतापूरकर साहेबांचं आपण सगळ्यांनी विशेष अभिनंदन केलं पाहिजे की त्यांची मेहनत यामध्ये खूप आहे. सोबतच आपल्याला माहिती आहे की बॉयलर मॅन्युफॅक्चरिंगमध्ये आपण महाराष्ट्र विशेषतः हा इंडियात नाही तर एशियामध्ये आपण लीड करतो आणि बरेच फेक सर्टिफिकेशन असतात. त्या फेक सर्टिफिकेशनलाही हे करण्यासाठी डिजिलॉकरची सुविधा उपलब्ध करणे असेल, अशा अनेक गोष्टी आम्ही करतो आहे. पण या बाबतीमध्ये आपल्या सगळ्यांचा सहयोग नेहमी पाहिजे असते. आत्ताच चर्चेमध्ये बोलण्यात आलं की मॅनपॉवर फार कमी आहे, विशेष करून वेल्डर्स मिळत नाहीत. तर मी एवढं आपल्याला सांगणार आहे की साहेब, आपण जी जागा उपलब्ध करून दिली आहे, आपण तिथे आपलं इन्स्टिट्यूट बांधणार आहे आणि आपण चिंता करण्याची काही गरज नाही. आपलेच कामगार मंत्री जे आहेत त्यांच्याकडे फायनान्स डिपार्टमेंटची चाबीसुद्धा आहे, त्यामुळे निधी काही आपल्याला कमी पडणार नाही. आपले आशिष भाऊ आपल्याला निधी निश्चित आणून देतील आणि या 150 डेजमध्ये निश्चित आपण त्याचं भूमिपूजन करू आणि एक चांगलं इन्स्टिट्यूट, वर्ल्ड क्लास इन्स्टिट्यूट आपण इथे उभं करू. कारण मलाही माहिती आहे, आम्ही जेव्हा ग्राउंड लेवलवर काम करतो, आम्ही मुलांना सांगत असतो की तुम्ही ॲडमिशन घ्या. पण आजकालचा ट्रेंड असा झाला आहे की एक मित्र समजा एखाद्यानी इलेक्ट्रिकल ट्रेड घेतला तर बाकीचे त्याच्या मागे ते करायला जातात. पण आज जसं सेमिनार तुम्ही इथे घेतला, बेसिकली बॉयलर्स आणि बॉयलर्सला लागणारे वेल्डर्स, आणि मारोळकर साहेब तुम्ही सांगितलं की वेल्डर्सला पगार चांगला असतो, पर त्याला पगार मिळतो. पण हा अवेअरनेस मुलांमध्ये नाही आहे, हा जनरल लोकांमध्ये हा अवेअरनेस नाही आहे. हा अवेअरनेस करण्यासाठी सुद्धा सर्व उद्योगांना मी विनंती करणार आहे की आपण आता बरेच सोशल कामं करत असतात, सोशल वर्क आपल्या असतात, तर यामध्ये सुद्धा आपण थोडंसं अवेअरनेस जे नवीन मुलं आहे यांच्यामध्ये आणलं पाहिजे की वेल्डर्सला सुद्धा खूप मोठा स्कोप येणाऱ्या काळामध्ये इंडस्ट्रीमध्ये आहे, जेणेकरून मुलं त्याकडे वळतील. नाहीतर आजकाल काय झालं आहे की आम्हाला तुमच्या ऑफिसमध्ये नोकरी लावून द्या, शाळेत नोकरी लावून द्या, कॉलेजवर नोकरी लावून द्या, याच्या व्यतिरिक्त ते काहीच मागत नाही. आणि नोकरी लावत असताना काय तर क्वालिफिकेशन मग BA, BCom, DEd, B.Ed. पण जर वेल्डर आपण त्याला बनवलं तर निश्चित आपल्या इंडस्ट्रीला त्याचा फायदा होईल. तर या अवेअरनेससाठी सुद्धा आपल्या सगळ्यांची मदत आम्हाला भविष्यात लागणार आहे. आणि आज आपण सगळेजण इथे आले, आपल्या सगळ्यांचं मी अभिनंदन करतो, आपल्या सगळ्यांचं मी स्वागत करतो. आणि हा जो कार्यक्रम आज आयोजित झाला आहे, निश्चित या कार्यक्रमातून खूप चांगले आउटपुट्स येतील, खूप चांगले सोल्युशन्स बाहेर पडतील. आणि या सोल्युशन्समुळे निश्चित फ्युचरमध्ये जे आपल्याला चॅलेंजेस आहेत त्या चॅलेंजेसवर आपल्याला मात करता येईल. आणि आज जसं आशिष भाऊंनी सांगितलं, शेवटी नागपूर हे पॉवर सेंटर आहे. देवेंद्र भाऊ इथे बसलेले आहेत, गडकरी साहेब इथे बसलेले आहेत, आशिषजी आहेत, सर्व आम्ही आपल्यासाठी इथं उपलब्ध आहोत. ज्या ज्या काही गोष्टींमध्ये आपल्याला असं वाटते की सरकारने यामध्ये सुधारणा केल्या पाहिजे, सरकारने यामध्ये चेंजेस केले पाहिजे, तर निश्चित आपण आपले व्हॅल्युएबल सजेशन्स आम्हाला द्यावे, जेणेकरून आम्हाला आपल्यासाठी सुद्धा, या इंडस्ट्रीसाठी सुद्धा काम करता येईल. आणि आजच्या या सेमिनारच्या निमित्तानं मी आपल्याला एवढी एक विनंती करणार आहे की यामध्ये कामगारांची सेफ्टीसुद्धा तेवढीच महत्त्वाची असते. प्रेशर वेसल्स त्याची आपण निर्मिती पाहतो, पण सेफ्टीच्या दृष्टीनं सुद्धा आजच्या सेमिनारमध्ये आपण साधक बाधक चर्चा करावी की जेणेकरून भविष्यात येणाऱ्या काळात शेवटी कामगार असला तर आपण आहो, आणि आपण असलो तर म्हणजे इंडस्ट्री आहे तर कामगार आहे, कामगार आहे तर इंडस्ट्री आहे. त्यामुळे कामगारांच्या सेफ्टीबद्दल सुद्धा आपण व्यापक चर्चा केली पाहिजे. त्याबद्दल आपण इथून बरेच चांगले सजेशन आम्हाला कामगार विभागाला सुद्धा द्याल, एवढीच आपल्याला विनंती करतो. आपण सगळेजण एवढ्या मोठ्या संख्येनं रविवार असून सुद्धा आज आपला सुट्टीचा दिवस इथे दिला, या सेमिनार अटेंड करायला आले, त्याबद्दल आपल्या सगळ्यांचं अभिनंदन करतो, स्वागत करतो आणि थांबतो. धन्यवाद.
मनापासून धन्यवाद साहेब. आपण अतिशय महत्त्वपूर्ण आणि मौलिक विचार आमच्यापर्यंत मांडलेत, त्याबद्दल मनापासून आभार. माननीय आशिष जयस्वाल साहेबांचे सुद्धा मी मनापासून आभार मानतो. अतिशय मौलिक असे विचार त्यांनी सुद्धा आपल्यापर्यंत मांडले, त्यांचे मनापासून आभार. यानंतर एक छोटासा कार्यक्रम, योजकच तत्र दुर्लभ हा असं म्हणतात, तसं ही कॉन्फरन्स आणि हा संपूर्ण कार्यक्रम ज्यांनी घडवून आणला ते सहसंचालक अर्थात जॉईंट डायरेक्टर बॉयलर नागपूर रिजन श्री सचिन चौधरी यांच्यासाठी आपण विशेष टाळ्या वाजवल्या पाहिजेत, कारण प्रचंड मेहनत हा कार्यक्रम घडवून आणण्यासाठी त्यांनी घेतलेली आहे. आणि आपल्या सगळ्यांच्या वतीनं त्यांचा सत्कार करावा अशी विनंती मी श्री भानू राजगोपालन साहेबांना करते. आपल्या सगळ्यांच्या वतीनं मी सचिन सरांना वरती आमंत्रित करते. या संपूर्ण कॉन्फरन्सच्या मागे अतिशय खंबीरपणे उभे असणारं हे व्यक्तिमत्व आहे, यांचा विशेष सत्कार आज आपण करतोय. कुणीतरी एक उभा राहावा लागतो आणि अशा प्रकारच्या आगळ्या वेगळ्या कॉन्फरन्सला मूर्त रूप मिळतं. मनापासून आभार, धन्यवाद. यानंतर या उद्घाटन सोहळ्याचं आभार प्रदर्शन होईल आणि त्यानंतर खऱ्या अर्थाने कॉन्फरन्सला सुरुवात होईल. आपण विचार ऐकणार आहोत. मी या कार्यक्रमाचं उद्घाटन सोहळ्याचं आभार प्रदर्शन करण्यासाठी श्री सचिन चौधरी यांना आमंत्रित करते.
नमस्कार. BWU WeldConnect या बॉयलर व वेल्डिंग क्षेत्रातील आधुनिक तंत्रज्ञान या विषयावर केंद्रित एक दिवसीय परिषदेकरता व्यासपीठावर उपस्थित माननीय मंत्री महोदय श्री आकाश फुंडकर सर, श्री आशिष जयस्वाल सर, श्री धवल अंतापूरकर संचालक बाष्पके मुंबई, श्री मारुडकर सर, भानू सर, आजच्या या ऐतिहासिक BWU वेल्ड कनेक्ट परिषदेत सर्व मान्यवरांचे आभार मानताना मला खरंच आनंद होत आहे. ही परिषद केवळ वेल्डिंग, टेस्टिंग व मेंटेनन्स या क्षेत्रात संवादाचे माध्यम तर ठरणार नाही, तर या क्षेत्रातील कौशल्यवृद्धी व सुरक्षितता या एक महत्त्वाचा दुवा बनणार आहे. प्रथम मी माननीय आकाश फुंडकर साहेबांचं विशेष आभार मानतो की त्यांनी आज वेळात वेळ काढून या कार्यक्रमाला उपस्थित राहिले व आज आमची ताकद सर एवढी वाढवली, आज एक हत्तीचं बळ आलं म्हणायला हरकत नाही सर. आज जे तुम्ही सांगितलं आज वेल्डिंग इन्स्टिट्यूट वगैरे करणार, निश्चित सर पुढच्या 150 दिवसात मी आपल्याला सहसंचालक नागपूर म्हणून आपल्याला हे करतो, आश्वासित करतो की तेवढ्याच जोराने मी ते हे करून देईन. आणि आपण जो विश्वास दाखवला आणि मार्गदर्शन केलं त्याबद्दल खरंच खूप खूप आभार. श्री आशिष जयस्वाल सरांचे पण मनपूर्वक आभार मानतो की ज्यांनी आमच्या या दृष्टिकोनावर विश्वास ठेवला व पाठिंबा दिला. आमच्या प्रधान सचिव मॅडम कुंदन मॅडम, महाराष्ट्र शासन प्रधान सचिव यांचे पण विशेष आभार मानतो. श्री धवल अंतापूरकर संचालक बॉयलर यांचेसुद्धा मी मनपूर्वक आभार मानतो. त्यांच्या प्रेरणेने व पाठिंब्यामुळेच आजची ही परिषद यशस्वीपणे पार पडणार आहे. त्याचप्रमाणे श्री संजय मारुडकर सर, संचालक महाराष्ट्र राज्य वीज निर्मिती यांचे तर विशेष आभार मानतो की त्यांनी असा क्लिष्ट विषय जो होता तो हिच्यावर आणला. त्याची जी रिक्वायरमेंट शासनाकडनं होती या व्यासपीठावर त्यांनी मांडली आणि त्यांनी ती कबुली करून घेतली म्हणायला काय हरकत नाही. तर त्यांचेही विशेष आभार, त्यांनी मार्गदर्शन केले. BWU WeldConnect ही परिषद ऑरेंज बिग टेक्नॉलॉजी यांच्या पुढाकाराने आयोजित करण्यात आली. त्यासाठी श्री भानू राजगोपालन सर, व्यवस्थापकीय संचालक यांचे मी विशेष आभार मानतो, ज्यांच्या दूरदृष्टीमुळे आपण सर्व आज एवढ्या मोठ्या संख्येने इथं एकत्रित झालो. त्यांच्यासाठी एकदा जोरदार टाळ्या वाजून जायला पाहिजेत. आजच्या या परिषदेतील मान्यवर वक्त्यांचे मी आभार मानतो की ज्यांनी वेळेत वेळ काढून या परिषदेला उपस्थित राहिले व आज आपणाला मार्गदर्शन करणार आहेत. त्यामध्ये सर मी विशेषतः नाव घेतो आहे अंजन कुमार सिन्हा, टेक्निकल डायरेक्टर इंटरटेक USA वरनं आलेले आहेत ते. यस. श्री प्रदीप जोशी, संस्थापक व CEO इनमीना अँड कन्सल्टंट, हे वेल्डिंग या याच्यावर आपल्याशी संवाद साधणार आहेत. श्री गजानन वानखेडे, सहसंचालक स्टीम बॉयलर संचालनालय महाराष्ट्र राज्य, या RLA या विषयावर आपल्याशी संवाद साधणार आहेत. श्री श्यामल चॅटर्जी, व्यवस्थापकीय संचालक गॅलेक्सी सोलर एनर्जी प्रायव्हेट लिमिटेड, यांचे मी आभार मानतो. श्री आभास विजय चनेकर, AGM ऑपरेशन GMR, यांचेही मी आभार मानतो. श्री प्रमोद काटे, आपण सगळे यांना परिचितच असाल, असे व्यंकटेश इंजिनियर्स कन्सल्टंटचे सल्लागार, यांचेही आपल्याला मार्गदर्शन लाभणार आहे. तसेच सर या परिषदेमध्ये विशेष करून सर्वांनी मला ती रिक्वेस्ट केली की सरांनी जो विषय म्हणला होता फ्लेक्झिबिलिटीचा, त्या याच्यावर सर शेवटी आपलं एक पॅनल डिस्कशन होणार आहे. तर त्या पॅनल डिस्कशनमध्ये जे पॅनलिस्ट आहेत, प्रदीप मोहपात्रा, ONM प्रमुख अदानी पॉवर, ते पण आलेले आहेत. इब्राहिम शेख, ऑपरेशन प्रमुख GMR, अमित बनकर, डेप्युटी CE चंद्रपूर, प्रमोद काटे सर आणि अंजन कुमार सर, यांचे खूप खूप आभार मानतो की त्यांनी ह्याच्यामध्ये हो या परिसंवादाला जसं जे म्हणतात ना की मणी विखुरलेले असतात आणि त्यांना एका माळेत बांधायचं काम आणि तुटलेली हे एकाच्यात बांधायसाठी आपले हे सूत्रसंचालन जे करणार आहेत ते श्री संजय जोशी, माजी वरिष्ठ उपाध्यक्ष ILFS यांचे मी विशेष आभार मानतो की हा कार्यक्रम खरंच निश्चित खूप सुरेख होणार आहे. यानंतर या परिषदेला सर्व जे सपोर्टर्स आहेत त्यांचे मी विशेष आभार मानतो. या परिषदेत सहभागी झालेले सर्व प्रतिनिधी, तांत्रिक अधिकारी, अभियंते, पत्रकार बंधू व प्रसार माध्यम यांचे देखील मी धन्यवाद देतो. तसेच सेंटर पॉईंट हॉटेल नागपूर यांची उत्कृष्ट व्यवस्था जी त्यांनी केलेली आहे त्यांचे मनपूर्वक आभार मानतो. ही परिषद आपल्यासाठी एक फक्त शैक्षणिक व्यासपीठ नव्हे तर औद्योगिक सुरक्षिततेच्या क्षेत्रात नव्या सहकार्याची पायाभरणी करणारी निश्चितच ठरणार आहे. आपल्या सर्वांच्या सहभागामुळेच आजचा दिवस हा एक प्रेरणादायी सर्वांना ठरणार आहे. हे बोलून मी माझ्या आभार प्रदर्शनाचे 2 शब्द संपवतो. जय हिंद, जय महाराष्ट्र. धन्यवाद सर. धन्यवाद.
मनापासून धन्यवाद. हा उद्घाटन सोहळा आता या ठिकाणी समाप्त होतोय, पण तत्पूर्वी एक छोटेसं निवेदन आहे. या उद्घाटन सोहळ्याला एक भावनेची झालर देत शेखर भागवत यांच्या स्मृतीला अभिवादन करून बॉयलर वर्ल्ड कनेक्ट गेल्या वर्षीपासून एक ब्लड डोनेशन कॅम्प आयोजित करत आला आहे. आजसुद्धा हा ब्लड डोनेशन कॅम्प आयोजित करण्यात आला आहे. जे कोणी इच्छुक रक्तदाते असतील त्यांनी रक्तदान करावं अशी विनंती आपल्याला करते. पुन्हा एकदा मंचावरील मान्यवरांचे मनापासून आभार मानते आणि हा उद्घाटन सोहळा संपला असं जाहीर करते. पण उद्घाटन सोहळ्यानंतर लगेच आजच्या कॉन्फरन्सला सुरुवात होणार आहे. त्यासाठी आपण सगळ्यांनी इथेच बसावं अशी विनंती करते आणि मान्यवरांना विनंती करते आपण समोर स्थानापन्न व्हावं. आणि यानंतरची सूत्र मिलिंद रहाटगावकर आणि उल्हास चांदेकर सरांना देते. पुन्हा एकदा आपल्या सगळ्यांना नम्र विनंती आहे, कृपया आपण इथेच स्थानापन्न व्हावं. ताबडतोब आपण कॉन्फरन्सला सुरुवात करतोय. मान्यवर वक्त्यांना आपण आज आमंत्रित केलेलं आहे, त्यांचे विचार आपण सगळे ऐकणार आहोत. त्यामुळे या कॉन्फरन्सला सुरुवात करावी अशी विनंती मिलिंद रहाटगावकर आणि उल्हास चांदेकर सरांना करते. सगळ्यांनी स्थानापन्न व्हावं अशी विनंती आहे. काही क्षणातच आजच्या वक्त्यांच्या भाषणांकडे आणि प्रेझेंटेशन्सकडे आपण जाणार आहोत. विविध ठिकाणून विविध विषयांवर मान्यवरांचे विचार आपण सगळे ऐकणार आहोत. एक वैशिष्ट्यपूर्ण अशी कॉन्फरन्स आयोजित करण्यात आली आहे. आपल्या सगळ्यांना पुन्हा एकदा विनंती आहे, कृपया आपण स्थानापन्न व्हावं. काही क्षणांचा वेळ आम्ही घेतोय आपला स्टेज तयार करण्यासाठी. आणि मिलिंद रहाटगावकर आणि उल्हास चांदेकर सरांना मी आमंत्रित करते, त्यांनी ही कॉन्फरन्स पुढे न्यावी.
Very good morning to all of you and hearty welcome to this inaugural edition of Boiler World Update Connect. It is really a matter of pride and pleasure for me to be standing here right at this stage in front of you. As Mr. Bhanu Rajgopalan had said, it is the first very edition of a very first new program, that is BWU Connect. So it is really indeed a moment of pleasure and pride for me to be standing here. I have been assigned a very tough job, which I will tell you about it later. I am Dr. Ullas Sandekar. I am from the team Boiler World Update. And my job is to introduce the speakers. Why I said it is a tough job? Because, the person has years of experience. He has so many achievements to his credit. And, really to sum it up in less than a couple of minutes, it is indeed a tough job. I will do that all the same. Thank you.
I am here to detail about the salient features of important sessions of this relevant conference. On behalf of Boiler World and WeldConnect, I will detail you about the salient features. Myself, Milind Rajgaonkar.
It is my privilege to introduce our distinguished speaker, the very first speaker of the very first session of the very first edition, none other than Mr. Anjan Kumar Sinha, who is a renowned power plant specialist with over 33 years of experience in the thermal power sector. Mr. Sinha's extensive expertise spans operations, maintenance, commissioning and renovation and modernization of large thermal plants. Over the years, he has guided utilities across the globe, asset integrity management and flexibilization. Actually, one thing worthy of mention, one of his most widely recognized contribution is the publication of the recipe book on flexible operation. All those, here from the industry, they are extremely well aware of this. It is like a Bible, it is like a cornerstone and a very important reference document. Mr. Sinha has served as senior advisor to GTG RISC, which is Greening the Grid, Renewable Integration and Sustainable Energy. He has also collaborated with esteemed organizations like EPR, that is Electrical Power Research Institute, global consultancy firms and leading OEMs. Currently, he continues to provide technical and commercial support to government bodies, regulators and multilateral agencies, contributing to electricity sector expansion and the integration of renewable energy. As you all are aware, renewable energy is a hot topic. It is a very relevant topic, and I'm sure we'll be getting extremely impressive and noteworthy inputs from Mr. Sinha. Mr. Sinha is also a member of Special Task Force on Flexibilization under the Indo-German Energy Forum. We are really honored to have you here, sir. And I would like to add one thing over here. As Mr. Sachin Chaudhary has also said, Mr. Anjan Kumar Sinha is here from the US. So big hand for Mr. Anjan Kumar Sinha. Like we are talking about BWU Connect. Connect can be local, it can be regional, it can be pan-India, but it is really a global. Your presence to the conference has really given a global flavor to this program, Boiler World Connect. And today's topic that Mr. Anjan Kumar Sinha will be sharing insights on is boiler process optimization for flexibility to ensure safety, reliability, sustainability, and technological upgrades.
Dear friends, need for flexibilization lies in rapid expansion of intermittent renewable energy sources, in continually improving grid strength from current 120 gigawatts to expected enhanced grid capacity of 400 gigawatts by 2030, that is 2030. In this changed and supercharged scenario, almost all the thermal power stations will be forced inevitably to operate on flexible loads than that of base load operation for which they are designed. In this view of drastic change in the mode of operation of power industry, the power industry has to adapt to new best practices which are going to be detailed in this upcoming learned discourse by Engineer Anjan Kumar Sinha. It is requested to note a suggestion from the organizers that this is the most vibrant, awaited and hot topic, but questions will not be entertained immediately after the session. All the questions, you will have to jot down all the questions which will be definitely addressed by a panel of experts at the end of the session, that is panel discussion, which will be organized to solve all the questions, all the queries raised by the audience.
Ladies and gentlemen, please welcome Mr. Anjan Kumar Sinha with a round of applause for the very first session.
I request the audience to welcome him with a grand applause.
All yours, sir.
Slide changer. Respected dignitaries, participants, experts, power plant operators, good morning to all of you. So it's a privilege to be talking on this very important topic. And WeldConnect, it's all interconnected when you talk about boiler. So it's connected with weld. So I'll talk basically on flexibilization and boiler process optimization, other things, but everywhere you'll see that it's connected. And I'd like to congratulate the director of boiler, and especially yesterday I was talking to Mr. Sachin Chaudhary. I was very pleased to know that the way he was involved so passionately in setting up this institute. You know, it's much required here. And there is no better way to give back to the society in such a great thing for skilling India and other things. You know, I was just seeing the boards and some information. 1.2 million shortage of welders here, indeed. And imagine the economic cost that you are bearing because of the shortage of this welding, good welders. And in fact, our company also stands for quality assurance and testing. Globally, it's known. And I'll just introduce you. My introduction has already been given. I'll introduce my company. This is not changing. Okay. So brief about my company. It's spread across the globe, 109 countries operation. And we are into different areas. We have a number of labs. We are into R&D. We do a lot of research. We are also important partners of all these research organizations, universities, ASME, senior fellows, then EPRI. In fact, I am also working very closely with EPRI on flexible operation, and I'm the lead there. Another thing, even for India, they declared me as their lead and resource person. So these are some of the things that we do. We provide these services, BTL reduction. So that is another great thing, and the biggest loss that you get is from boiler tube leakages. And it's connected, you know, I'll tell you what are the reasons. And before I discuss this, I'd like to also, I was very happy when I was listening to the dignitaries. You know, Marutkar Sahab was mentioning about flexibilization and all. So such understanding at that level, you know, it's a very great thing. Understanding what are the life consumption, what are the like damages. We're also talking about the stresses in the system. So that sort of understanding at that level. So definitely things are going to move very fast in a positive direction. So we do all those things like even damage modeling, then cost of cycling. You know, that was, we are the pioneers, Intertech. We can tell you very precisely what is the cost of your cycling. Cycling means flexibilization. So for every cycle, what is the cost? In fact, we had worked with CRC. We have given them the numbers on how to compensate the power plants. You know, there is a huge cost which needs to be compensated. I'll explain all those in details. And this is one of the founders of the company. I know when I connect, just look at the statement made long back. Today we are still talking about that, renewables and all. So this sort of foresight he had. And you know, this company was set up by Sir Thomas Edison when he started the manufacturing of the bulb, electric bulb. So he thought of quality and certification. So ETL, that mark, certification mark, it was started by Sir Thomas Edison. Electrical testing lab, that time it was made, and today it's the most prestigious certificate that you can get. You know, it's marked on many of the equipments, many of the products. And this connects very well with the institute. We are talking about in the morning, discussing, because welders, then certifications. You know, today you have many, you know, there are some places, in every lane you find an engineering college. Some IT, computer engineers, all are becoming computer engineers. But you hardly find any institute on welding, which is much needed. And apart from that, you need a knowledge, then the skill. So it's a great initiative, I'll tell you. And let me admit, any support you need from me, I'm always there. Whether it is technical, if you need, I can even come across whenever I have time to address, even share my knowledge, whatever I have, even for learning. It's always, when you share, you also learn a lot. So I'll just skip this, you know, reasons are well known, what is happening. This slide I'll show you. See, today, this is the form in which the plants are operating. This is a single day, 24 hours, 96 blocks. In Indian means scheduling. So see how the plants are operating here. Means ramping down, again ramped up. This is the schedule given to a plant. This is the NTPC plant, I won't name that plant. And today it may be a short, means for short duration it is not there because the demand has increased. But it is going to come back in a much heavier way. So every time you are doing, there is a damage and there is a cost. And you need to understand this. And I've been telling to the schedulers, to the grid operators, do you understand what you are doing while scheduling the plants in this way? You just schedule it, and the poor plant operators, they incur a loss, and certain losses you won't be able to account for immediately. Today your BTLs are happening, or your forced outage have increased. It's the reason of your past operations. These damages can be felt after 7 years. That I'll also explain. Just move the slide. There's some issue here. Yeah. Okay. Can you move the slide forward? Yes. Yeah, from there. So in between, actually, this is the copy of my recipe book, which was being discussed. You can find it online. And by the end of this year, I'm going to bring a later version, means updated version of this. Because this is 4 years back, but this is the most cited work on this topic today, globally. Last time I was in EPRI, there were people from 6 countries citing this book. It has all the practical knowledge, no theory and all the practical knowledge. So one thing, like we are talking about flexibilization, you still need to understand what is flexible operation. Or it's not only when you are changing the load or you are just swinging the load, all sort of operations. When you run at a minimum load, even when you shut down the unit on a RSD, reserve shutdown, for 2 days, when you are not preserving it, it's a flexible operation. There are some damages, and there is a long-term effect. Then again, if you are running it even at 105% or more, you are just stressing your machines. So all these things you need to understand, and even like sometimes your mill trips, there is automatic load swing. Like in the rainy season, your bunker gets choked, and then you have to reduce the load suddenly. It's all flexible operation. It's only the rate at which you need to move. Yeah, next slide, please. And that has effects. Yeah, see, one thing is, what is the effect of flexible operation? There is a concept of damage, accumulation of damage. In fact, any unit can be flexibilized. People say that, no, my plant cannot operate on flexible operation. It's not true. It's just the interventions needed may be very different. There is no one plug-and-play solutions. Every unit is unique, and they need unique solution. And cost can vary. Just to enable them to do a flexible operation, there can be different costs. But you need to understand that what happens every time you do a flexible operation, there are some damages. Even if you do it in the best way, and if you don't do with the proper awareness, then it can even be disastrous. Safety is one aspect. Safety must be looked at before you start anything. For any operation, what you are doing, see what is the effect on safety. Then you start with economic cost and other things, and then the performance. So, one example which I very often give to explain concept of damages, like a paper clip. You take it once, fold it, unfold it. You can do it 50 times. You won't see the damage. Maybe on the 60th time, you find some mark, and then one more time, and it's broken. Similar thing is machine. Every time you are doing, there is damage, and that damage gets accumulated. It's delta X, delta X1, X2, and like this, till there is a breaking point. So, bad part is today operators, they are not aware of what damages they are doing to the machine. And how can they recover the cost? Especially the IPPs. After 7 years, they may need a capital replacement. That time, some of them, this is the way how like many plants in Europe long back, some 20 years back, they went out of business. Because they did it and it was broken, and they couldn't recover the money from the market. So if you are not recovering it for every such operation, at the end when there will be like a catastrophic failure, then nobody will give you the money also. So every time you are doing a business loss, economic loss, those things you need to understand. And there are solutions today. If you do it with proper awareness, there are solutions. Even there are solutions, you need solutions like, see, these people on the board, they don't know what is going to come. See the picture carefully. They are there, they told, okay, my analysis tells me everything is okay. But you need, even the analysis, you need much more than that. You must be enabled to see what is going beyond that place, which is not visible right at the moment. This should be your approach. Yeah, next slide, please. Okay. So what are the interventions? I can talk on this topic. You know, certain interventions, people say that, you know, there's a lot of discussions on the plant, and there's resistance also. This flexible operation, it's also going to be, see, it's a reality. You want it or not, it's going to happen. It's not that I won't run it. The grid won't give you a schedule. You'll have to go. If your reliability is not good, then you'll go into flexible operation. Even if you're not aware of it, every time your equipment trips something, there is a load throw-off, that is flexible operation. So there's no one plug-and-play solution. You go to certain OEMs, they told, okay, I'll make you flexible operation, this solution. This is not the way. Best thing is improve your O&M practices. And if you see the cost, if you are like business as usual here, then just by operational alternations, you can improve a lot. Just by changing your O&M practices, by awareness. See, base load operation and flexible operation, they are two different things. All your BTLs are happening, you are not even aware of like what is to be done. You still continue to operate as if you're operating on a base load, which is wrong. And then people just jump into that digitalization and other things. But you may not be required to do anything beyond these first two. Changing this operational plus C&I means controls. Just take care of your controls, and other things, they won't give that much benefit. But first two, they give you the maximum benefit. And then certain old machines, you may have to go for R&M. You know, R&M strategy is also needed. So first of all, you need to decide how long I'm going to run this unit. What should be the R&M strategy? Yeah, next. So I'll tell you about the damages and the cost. So this we had worked and we had shared with CRC also long back, and for a compensation mechanism. So every operation, if you see LL1 and LL2, they are load following. So unless there is a significant load following, there won't be damages. So we take it as LL3 means significant load following. So there is a cost for that. And we had estimated something like 1.95 to 2.7 lakhs for one load following in a 500 megawatt. And recently we have also done studies for supercritical units. Then for hot start, the cost is around 20 to 30 lakhs for 200, and 500, it's 78 to say 1 crore for every hot start. Cold, then warm start, it is a bit more, and cold start, it is way higher, 2.62 crore, every cold start. And like there's one misconception that flexible operation means minimum load operation. Means we are not capable of going to say 50% or 40%. You need to understand that if you develop that capability, you'll save on all these costs. See, every machine is designed for a particular number of starts. And every time you start, do a cold start for a machine. So typically in a KW, every time you do a cold start, you lose 60 hours of your life. If you are doing this start as per the manufacturer's curve, but it doesn't happen in the real life. We are just studying in one of the plants and comparing the two operators. So one operator had done 16 times more damage than the other operator. It can also vary between operator to operator. So this is the importance of even skilling. And minimum load, if you are able to operate, you won't even get the cost of this load following, if you are able to maintain your parameters. Next slide, please. So, see, I'm coming to the O&M practices. Look at this picture very carefully. What is wrong with this? It tells a lot of stories. No, this is a plant, and see all this buckstay was, it was locked. I found it at several locations, And I was just carrying a walk down on this unit. And they had a lot of BTLs, boiler tube leakages. And they had made some analysis, root cause, whatever they say. And none of them had pointed out to this. And this was the root cause. They had restricted the expansion even of the tubes and other things, and they were having leakages. They had kept it locked, and this is after 1.5 months of overhauling. Then there is another picture I'll tell you. Yeah, that side also. Sorry. Back. Right-hand side, they had locked the pipe. And piping failures, it's huge. And see what happens, it's all connected. It's not one area you take care of and you talk of. Even the hangers, I found some of the hangers, they had just sagged. And it's since long. And then actually every time there used to be condensate in that pipe. Because there's a slope as per design. And then the drains are designed accordingly. And if there's a sag this side, it won't drain. Some water will always be remaining here, condensate. Every time there will be a hammering. And that does a lot of damage to your boiler tubes and other things. So that I had shown also. Next. All those things you need to take care of. That is why I was telling you the first slide, with O&M practices, you can benefit a lot. It's not that straight away you go to the OEM, change this thing, they'll tell you, okay, change your burners and other things. Similarly, see, expansion and all. Even that pipe. This pipe also. Okay, next, please. Next slide. This is some of the common, I think people know that. And flexible operation, these are some of the common problems. Efficiency, it's all interconnected. So burners and all, I'll discuss these things in details in the subsequent slides. Next, please. So damage mechanisms. You need to understand what are the mechanisms and which mechanism is active at your plant. It's not same, there are many. So you need to go into details in your plant, analyze it with data, long-term data. You collect, typically when we go and conduct study, we ask for 10 years data, which many plants are not able to give, whatever it is there. Even 3 years data can give you a lot of information. And then you can even analyze the pattern. What are the damage mechanism and what is the pattern in particular area. This sort of analysis, I think many plants are not doing. Even we have a solution called AWARE, Asset Integrity Management. And everything, even the drawings in AutoCAD, they are loaded, and damages, they're just pinpointed. And if you have this for 10 years, and even what are the works, even thickness measurements, then your hardness, all those things are recorded, and there's a change of color in the tubes. So you get that information, and then you can, any shutdown or any inspection, you can check and you can tailor your activities to that area. It saves a lot of outages, lot of your efforts, lot of your money. So next. I'll just show you some of the failures, pictures. Some real which I had taken. This one, boiler means cracking. And this is another failure, then blade. Next. Okay. Okay, this is better. So I'll stop on some topic where I'll discuss in details. I think this is fairly known, so I won't spend time on these things. These are some of the damage mechanisms which is understood. Okay. Again, temperature transients. This is very common, and I think it is understood, but how to control it, that is a challenge. So all these damages we had analyzed, and with long-term data, we pinpointed it that, okay, this is the reason. There was a very good correlation with that data. ESP collapse. They were not maintaining the acid dew point, means flue gas outlet temperature, they were maintaining below the acid dew point, long term, and all those data was correlating. and then the ESP had collapsed. What are all failures? Means short-term overheating and even long-term overheating. Damage in the turbine seals. You are not maintaining your steam quality. Scale deposits. They are all connected. Now, tell me how this is related with flexible operation. Because even in normal, how we segregate it, with the cycles, all those things get changed. Even water chemistry, you need to take care of your oxygen ingress into the system in water. Every time you are taking makeup and other things. For base load operation, okay, you fixed everything, fixed your chemistry, it's running. But with flexible operation, you need another approach. And chemistry also, a lot of failure happens in the cycling plants. PA fan stalling. This is one blade which had broken. It's a challenge when you reduce the load at 40% and you try to keep both your PA fans in service. This is what is going to happen maybe in some of the plants. See, another problem is, I'll tell you the biggest problem when somebody asks me, is the mindset, operator's mindset, or conservative mindset, because you don't want to do new things and like whatever is your experience, like I have 35 years of experience. I told you, okay, I've learned all those things, is it gone? Don't want to listen to new things. So I had struggled initially. I know people from even NTPC were there. We had done initial test runs and the pilot, keeping more number of mills in service. And we were able to test it, even we did it at Mauda. And one key point that was there, we reduced the number of mills in service, 3 mills. There was a lot of resistance. Okay, what if some mill trips? Boiler will trip. I told, if you keep more number of mills, boiler will surely trip because you are going into a lean zone. And even you are in an unsafe zone. You are compromising on the safety of the plant. So with 3 mills, and then after that, we did it first at Dadri, then at NTPC Dadri, and then I conducted on 17 test runs. Recent ones also we did 2 months back in one of the plants in Chhattisgarh. And supercritical unit, and we were able to achieve 41%. First trial, we'll do another trial again. So first of all, you need to ensure the reliability of your equipment. Just because your equipment is reliable, it doesn't mean that there's a problem with low load operation or flexible operation. This is one place where the entire bottom ash hopper, they had collapsed, exploded. Not once, 17 times. 2 units. This is a plant in South India. I won't mention the name of that plant. They had exploded 17 times, and then a lot of even OEMs, they had conducted the study. The supplier was BHEL, can name that. Then somehow I was there, we conducted the study, and we identified the root cause. And it was very simple. They just changed the operational procedure. After 1 year, I got the call, sir, thank you. I told, what for? I told, this didn't explode anymore. I told, it shouldn't explode. So they just changed that operational procedure. Now, where to intervene and when and how? This is very important. You cannot intervene in every area. Means take a book or catalog and start doing everything. You need to be specific. So first thing is coal. It's challenging. People complain because of the coal quality, and in India it's typical, there's a lot of variation in the coal quality. See, this is the data of the plants where we conducted test runs. And if you see this 5003 marked coal variation in one test run, we do typically for 3 days or 2 days. During the test runs, same unit, the variation was from 5003 to 2683 GCV. Other parameters also there. See the ash content. This is really challenging. Then what to do with this? So there are solutions. So today there are solutions, even AI solutions, which will tell you, not precisely I should say, but within a margin of error of 5%, they'll tell you what is the coal quality. And then you can give inputs even to your plant to change your controls and other things. So this is the only way you can deal with it. Operators must be aware of what is going to come in. So you need to put more effort, and then blending, of course, it's a big challenge. I don't think that anybody has been able to successfully do blending in India. Tried, there are a lot of trials, and putting different coal in different bunker, that is also not correct. Then blending on the belts, that also didn't work out, and then blending that much huge quantity of coal in the yard stacker, that is also challenging. Then there are issues of supply. Sometimes you get that coal and then other quality is not available. So there are challenges, but for this, the solution is you must have an online analyzer. It's AI generated, not the measurement type. That also has not been successful. Because see, all boilers are designed for this. Even the furnace height and all. And if you understand those things, what needs to be changed when your boiler is designed for any of these and you get other coal quality? You need to change the operating regime. Sometimes, like your combustion must be completed at a certain level, below the pendant tubes, below the platen. If it continues to burn above that combustion, then you will have issues of overheating, maybe it will continue up till second pass, and a lot of other issues will come. So if you lower that flame, control your air-fuel mixture and other things. This is what I was talking about. You need to ensure that, see, in combustion it's simple, but fundamentals is the same, whether you are operating on flexible mode or on a base load. But flexible mode, even the control needs to change very quickly, and you must be aware of that. Certain things, what happens, see, this coal must be delivered well distributed with proper velocity, proper air-fuel mixture. That is it. And then the combustion will be there. But that doesn't happen. I'll tell you why. Number of mills you need to optimize. If you are at 40%, 3 mills, typically in the Indian coal of 4,000 GCV coal, 3 mills is good enough. And then if there are other liabilities, then it's difficult. Secondary air flow. Many plants, BHE supplied plants, means wind box pressure collapses. So even the primary to secondary, ideally 30-70 or 40-60 if you are not able to make. But that ratio doesn't happen. You put in more primary air and then you blow away, means all the coal, even the heavier particles. Coal fineness is a very important part. But the measurement that is done in plants, many times I see it's not correct. Because you need to do it at different loads. If you are operating at a lower load or lower mill loading, put in more air, even the coarser particles will get carried away. So you need to perform that at every load. Even the coal flow, means by balancing across the pipes, that I'll talk to you. Again, this is also stuck. Next slide. Okay, now it's working. Press hard. So these are the things. It's just fundamentals. I think all the operators know it. But how to control it in during a flexible operation, that is a challenge. And it can be done. There are certain things you just keep in mind, it can be done. I'll show you some practical examples. One place we changed this at low load, if you see the primary air curve, it was straight, so it used to come in the stalling zone. Then we changed the curve, you see the blue one. So it will stay there for some time, so you just escape that stalling zone. But ideally, you need to stop. At 3 mills, you need to keep only 1 PFN. But if you are having any liability, passing of your damper or other things, then you cannot do that. And if you try to maintain 2 PFN, it will be very difficult. So first of all, if you are having liability, that is not a problem of flexible operation. That is your liability. You know, one plant I had been just practical side. They had given, even the OEM had written in their favor. They told that, okay, these plants are not designed to operate below 70%. Then I challenged the OEM also. I told, I'll take out the specs and I'll take care of that. And it will be a very hard thing for you. I visited that plant. I know in one elevation, one of the burner tip was missing. Another burner was choked. Now I told, what are you talking about, 70%? You cannot even operate at full load also. This is liability, not a problem of flexible operation or any design problem. Again, coal flow. See, another thing, what happens, you know, typically if you talk about a corner fire, even that holds for front and rear fire, you have 4 coal pipes. And then you have fixed orifices there. You balance it, you do dirty air flow test, whatever it is at a particular mill loading. And whereas dirty air flow test is never accurate. Skill of the person who is doing it, how much he is inserting and how much timing, and then there are a lot of other factors. And then where you are putting, you know, inside this circumference, where you put it, if there is a roping inside, then it won't get captured. Lot of things that also I'll explain. So today we have online dynamic measurements, microwave based. And in the same pipe, when you reduce the mill loading, you know, the same balancing is no more there. It gets unbalanced. So like 80%, 90% mill loading, it's balanced with fixed orifices. When you reduce it, say 50% of mill loading, or sometimes people operate even lower than that, which you should never do. Then we have seen that it gets unbalanced. I have data also of different plants. Velocity in one pipe is 50, in another pipe is 45. And I'd seen in one plant, there was, like when I went inside the boiler for inspection, there were marks as if some sandblasting has been done on the boiler tubes, lower portion. And then I could make out what has happened. Then I saw the burners. I'll show you the picture of the burners also, what happened. Actually, coarse particles were coming at high velocity, and it was just acting as if it was doing sandblasting. Those things are there, and which they were not aware of, and they were doing all sort of root cause analysis and other things. Again, what are your temperatures? It's very, very critical. People operate by thumb rule. But there is a curve. Even there is a curve by EPRI, but this is the best curve that I found in international literature. So as per, there are different factors you should take into account: moisture, coal quality, and then you should decide on your temperature. We have seen mills, one function of mill is also to dry the coal properly so that it can be grinded, dry, grind, and send it equally amongst the 4 coal pipe with proper air fuel distribution. You put in more air, things get distorted. So, like what we do in a combustion, you know, combustion, Intertech does it, dynamic combustion tuning. You put typically 24 different sensors, and you measure the O2, CO2, CO, then your temperatures of flue gas. We put it in the second pass, and then it is there. It's a long time process. There is a grid. And then you observe, and then you make changes in individual burners, and then see. It's a dynamic combustion tuning. Nobody does it, and it has yielded very good results. But India, actually, we still need to be quality conscious. We are operating it, and many of the plants, they have huge scope for efficiency improvement. Huge scope, I'll tell you. Any plant, even many of the state IPP, I tell them just by seeing and other things, like with little effort, you can improve by 1%. And 1%, if you calculate in terms of money, it's huge, huge, huge money. That can be done. So dynamic combustion, nobody is doing, and today I think nobody in India even has the skill You won't find people. I was trying to find people locally. I couldn't find. So I have to bring people from US. Any plant first time, and then I'm also thinking of developing capability in India, at least for the benefit of the Indian power sector. Okay, sorry. See, another thing is your measurements. So, are your measurements correct? Just see, I won't tell anything, like even where you have put your measurements. When we go study the plant, we conduct detailed studies and then we give a list of instrumentation. Where to put it? Where to measure it? Are your existing instrumentation correct, giving you good, accurate results or a true result? See, this is a thick walled component below. There are two, means thermocouples or temperature measurements, or three installed. Lower there is nothing. Every time, even there is a small condensate, it will never get captured. Below, if there is a condensate, so ideally you should also put a temperature measurement there. So, on many places, this is just one example that I picked up and I gave you. We find these places and we tell, you know, people talk a lot about AI. Just put in some data and they'll give you. They have also started using ChatGPT. You know, one of the conferences I was there in February, and then they were doing a lot of things they were showing. They were simply putting data and ChatGPT, and they had claimed, means a lot of things. First of all, don't use any of these online ChatGPT other things. They steal your data. They'll give you some output. But first of all, what you are putting in, and a lot of things you can do yourself. Very small tools. It's not rocket science. But always your domain knowledge and fundamentals, they are going to stay. You use anything. See, another example, see, this equation is equation of fly ash erosion. An example, you know the importance of soot blowing. It can lead to accelerated BTLs, not because of steam erosion and other things. See the picture there. If there is a deposit fouling there in the gooseneck area, the entire course is changed and the velocity is going to increase. And where is the velocity in that function? Exponent. So some areas, that is why to analyze the pattern in your drawing and other things, and then if you correlate the data, a lot of interventions you can do in your machine. So BTL problems, they are not analyzed properly, they are not understood. Root cause is never actually understood, because you need to analyze your data first of all those data. If every time if you shut down a boiler and do an inspection, typically second pass you shouldn't wash. First entry should be without washing and observe where are the patterns, and you record it. So you'll understand every unit is different. So you understand the characteristic of that boiler. Record that data, and long term, it'll do a lot of good for that boiler. There, I've seen that many times when you go there, you see some black spots, oxygen-starved areas, and your O2 is flowing very high. So even the oxygen measurement is not correct. Ideally, you should also install one in the high temperature zone. There are very good probes available in the market today, high temperature O2 probes also. And we are measuring at the APH inlet and where all the ingress happens. So, so air fuel optimization is very far off that way. And temperature also. Ideal way of measuring the temperature is your furnace exit. Some stations, they have measurement systems like acoustic and high temperature sensors. So you'll be able to control your combustion, what temperature you are maintaining there, fouling and other things. So it's never known what is the temperature you are maintaining. This is a solution of coal quality that I was talking about. Online, it's inexpensive solution. AI just with the data will analyze and tell you within a margin of error of 5%. So some of the things that we did, okay. Some solutions that we have, intelligent suit blowing, real-time modeling. I'll skip and go to, yeah. I think I have some more time, yeah. Okay, okay. No, time never gets finished. Okay. But anyway, I don't want to cut into the other speakers' time. So I'll try to get over this quickly. So see, these two burners means in fact three from the same elevation, same mill. What do you understand in this? Unequal coal flow. One is choked, one is overheated, and then you can see some erosion there. High velocity. Overheating means flame impingement from the boiler. Means velocity must be low. One burner was like damaged like this. Then we have a very good solution, and we have here the provider, Mr. Archit Lohia. Can you raise your hand? So anybody wants to talk, he can talk to him. He's our partner. We are doing this at one of the plants in Chhattisgarh and at many other places. Very good results we have got. So this is the solution. One is variable orifice. Variable orifice, see, if you put fixed orifice, you can do nothing. Even at low load operation, it's just fixed. Coal flow unbalance will be there. And then forget about combustion optimization. Without balancing the coal, fuel, air, so what sort of optimization we are talking? So that should be the starting point, I'll tell you. And then measurements. Okay, once you put that, without measurements, what we'll do? So that also I'll tell you. These solutions are available. We have microwave sensors and then velocity sensors. If you want, we can also talk on that details. You know, in every pipe, typically you have 3 microwave sensors for coal mass flow, and then velocity sensor, 1. Temperature measurement is also there. And then we trend it. And even we match with the total coal flow. It matches, means all the readings, the readings put together, it should match with the total coal flow. And then you see what is happening. And here it gets balanced. Here it's balanced. Some of the mills you can even find if there is some, like 3 sensors and one is showing and third one is not showing proper coal flow. That means there is some roping going on. Because from the pipe, if there is a bend, some will go like this and hit. Means it won't go uniformly. So all those things are captured. And then we got a lot of benefit. You can see the settings. Initially what was there and after balancing, what is there. See, roping we had identified from the trend, and when this was opened, this was from other plant. Means there was erosion in one part. That means a lot of coal was going through that path. Some roping was happening. And this was captured even in the trend. So I was talking about the cost. Where to put your investment, where to intervene, where to put your efforts. So ideally for a plant, you should know like what are your damages, what are the costs. So this we have put for one of the plants here in India. So your cost, this is the cost distribution. 46% goes to the boiler, pressure parts, and then there are other areas. This affected by cycling of flexible operation. So there are a lot of solutions available for life management. We can tell you the damages on real time. Any operation that you are doing and what is the damage in real time. These solutions, it's a very old solution. You can find that mentioned in 2006 in ASME documents. Those are available. Mills. Yeah, another thing when you are comparing about mills, wear hour, even for procurement, other things. Running hours, most of the plants do it. But ours, it's not like that. You know, one very common example yesterday also I had giving to someone. Whether your mill is a 60 saal ka jawan or 30 saal ka buddha, it's not the years, but the equivalent years. Means at what loading you have run it, with what cold quality, what was the means abrasive index and other parameters of that. Different coal qualities, not simply so many hours you replace the grinding roll. This is our practice. All sort of data analysis you should be doing it. So this one I was talking about. This solutions gives you real-time damage. Means some intertech, I'll just end with these two slides. One very good solution that we have is tube mod. So here what happens, you know, during low load operation, one big problem is your change of your heat transfer and an entire steam flow path. Even if you control your combustion, your steam flow changes. And some of the tubes, they are not getting enough steam. So what to do that? Even for different loads. So Intertech, we study every tube, and then we can even extend some high life consumption path. Then we just interchange the tubes and the flow in that tubes. There is a solution we call tube mod. There is a typical small short pipe constricted. You see in the right, there is a drawing. You put it in the penthouse here, cut it, and then you change the flow across the different tubes. It's complete thermodynamic model that gets changed. We have done it at many plants in US. It's a patented solution with Intertech. India, actually I'm showing it, but these things can be done, but it will be very difficult to get the approval of IBR. And IBR people also there, but it will be next to impossible in getting this sort of approval here. It's a very advanced thing, but this is how they have operated. You know, one plant last to last year, Jacksonville, they have run this unit to close to 100 years. And they had reached out to us, they told we want to run for 7 more years before we retire it. What needs to be done? So we analyzed everything, I told, okay, only one portion they needed to change. Other things, okay, this can run. So we gave them this fitness of service. So aware, for piping also you have. Just a minute. Questions, I think we'll take it now or? Okay. So, okay, note down your question and you can reach out to me. Just a minute. A lot of other things. I think I have my, yeah. You can note down my number and contact anytime if you feel like. You can reach out to me. Thank you.
Be there for felicitation. Yes. For a few seconds. On behalf of organizers and attentive audience, it is my duty to express thanks towards resourceful engineer Sinha sir for his very illustrative discourse. He has focused on wonderful explanation on every complex issue and the need for the future with different types of supporting solutions so as to enhance the system features with adjustments and improvements of the procedures to increase system reliability in the scenario of flexibilization of different thermal power stations. I herewith request Sandekar to take over the proceedings.
Thank you very much. It was indeed an enlightening session, and I'm sure all of us will benefit. As a token of our gratitude, we'd like you to be felicitated with a memento and a sapling. I now request Mrs. Bharti Rajgopalan to come forward and do the honors.
I herewith request Anjali Patwardhan to take over the proceedings.
Good morning, ladies and gentlemen. It gives me immense pleasure to introduce our next distinguished speaker, Mr. Pradeep Joshi, a stalwart in the field of welding technology and metallurgy. Mr. Joshi is an accomplished professional whose academic journey includes a bachelor's degree in metallurgy from VNIT Nagpur, a master's degree in technology from IIT Bombay, and a postgraduate diploma in management from Jamnalal Bajaj Institute of Management Studies, Mumbai.
Dear friends, second session of Boiler World Update WeldConnect deals with an important topic as well. Superior stress-bearing material is no doubt the soul of all boilers from subcritical to advanced supercritical boilers. But the quality of welding and skills of welders will garner highest priority in flexible load operation of boilers. The current shortage of 12 lakh skilled welding professionals is expected to derail the infrastructure and growth story in the coming few years. This is a drastic reality of the situation. This acute shortage of skilled welders and adoption of up-to-date welding processes will surely hamper the 90,000 megawatt power generation capacity and new construction assets of rupees 52 lakh crores. This is the realistic prediction of none other than the spokesperson and past president of Indian Institute of Welding. With this eye-opening background, eminent engineer Shri Pradeep Joshi, sir, is here to enlighten us for enlighten this audacious gathering regarding the welding scenario that will emerge very soon.
Mr. Pradeep Joshi's professional career spans over 4 decades with leading multinational companies, welding giants like Philips, Isab, Bowler, Kobelco, advancing welding technologies across Asia and the Middle East. He currently serves as the section chairman of the American Welding Society in the UAE and is a life member of the Indian Institute of Welding. As the founder and CEO of InMena Consultants, Mr. Joshi is deeply involved in consultancy and training for welding professionals working on core sector projects across India, the Middle East, and Africa. Today, Mr. Joshi will be sharing his valuable insights on welding scenario, challenges, and mitigation in the boiler industry.
I request Joshi sir to be on the dais to deliver his lecture.
Good day, everybody. I hope all of us are awake and active because the next 45 minutes will be metallurgy, material sciences, chemistry. But each word, believe me, if that is not followed, there's a time bomb ticking in the boiler and a futuristic explosion is sure to happen. So let's be alert and respected organizers, honorable delegates, industry captains in the coal-fired power plant industry, and the other gentlemen from the infrastructure, cement industry, steel plants, chemical and petrochemical, and even sugar mills. Now, all we're talking about since morning is basically nothing but heat and mass transfer. Where you have heat, you have pressure, you have problems. And then my earlier speaker also talked about the OEMs. It's a different ballgame there, and what is happening in the power plants is a different ballgame. The subject of that, I will be a little bit fast today than the normal, so please bear with me because I need to cover a few slides in 45 minutes. The topic of the day today is the welding challenges in the boiler industry and its mitigation. Let me check if it works. Yeah, it works. The challenges, whether it's in our life or in a coal-fired boiler in a power plant, are primarily these three. Safety first, safety second, safety last actually. The second one comes the skill sets which we have, skill sets of the engineers, skill sets of the boiler operators, and most importantly, the skill sets of the welders per se. And then finally, the productivity, whether it is plant load factors, the quality of the coal, raw materials, energy, system losses, and the final electricity unit generation of a megawatt in a power plant. The discussion today, I will restrict myself to a coal-powered power plant just because of the paucity of time, but otherwise it's the same heat, same pressure in a pressure vessel or a heat exchanger as well. So these three things, if we can take care in a power plant boiler, automatically money will follow, growth will follow, GDP will follow for the state of Maharashtra as well as for India. Again, I'll restrict myself to examples in our state of Maharashtra. As earlier in the inaugural letter it was said, Maharashtra has been leading in many other areas which we'll see in subsequent slides to follow. This is a typical flow diagram of a power plant, coal-fired. The coal gets into the boiler, gets heated up, and the water in the tubes gets converted into wet steam and then dry steam, and at the end, the steam goes into the turbines, converting it into electrical energy. Okay, now the power scene, as I understand, of course, you are the industry captains, you would know better, but I will only talk of installed capacities, which is, so in India, the power megawatt generation installed capacity is about 400,000 plus, and of which more than half of it is coming from the thermal route, and then of course you have the hydro, and of course the renewable energy, wind and solar, as you can see, is almost very huge there at the bottom of the chart. And then we have hydropower. In Maharashtra, it would be mostly restricted to Koyna areas, and the thermal plant, half of the energy, installed capacity, as we know, is here in this area, Nagpur and its adjoining Vidarbha areas. Almost 10,000 megawatts, I understand, is the installed capacity here, and it's growing every month, every year. And of course, the last one, nuclear plants, 8 plants, generate about less than 7,000, installed capacity less than 7,000 megawatts. In Maharashtra, we have one near Tarapur, which is about 1,400, I guess. Here, the focus is Maharashtra, of course, and what needs to be done, what are the challenges we have in the power plant, and how to mitigate them. Mitigation means how to reduce the problems existing. We have a total of about 35,000 megawatts, out of that 425 in India, 425,000. So almost about, let's say, 7 to 10% of the power is led by the state of Maharashtra. Again, majority of it comes, 22,000 megawatt installed comes from the thermal route. Then, of course, we have about 10,000 installed capacity of the renewables, which is kept picking up very fast. And, of course, the hydro from the Koyna areas, and nuclear, just one plant in Tarapur. I'm going a little bit fast because I want to come into the actual problems of welding and then its mitigation. Now, we have industry boiler manufacturers also in our audience today. And as we know, in all India, this is what the record. Of course, it's much, much higher, the smaller boiler. But assuming it's more than 1,100 all India, in big industry boilers, which include BHL, Thermax, maybe pressure vessel heat exchangers like Larsen Tubro and many, many others. In Maharashtra, again, it is a leader in India, leading from the front for industrial boiler manufacturing. So the boiler manufacturers share the majority responsibility of producing good quality boilers for use into the power plant sector. The first weld challenge which we can talk of today is just the difference. What happens in a nice workshop in BHL or a nice workshop in Pune, in Thermax, or many other places, or in Kolhapur. I have some friends here. It's totally controlled. It's a controlled, as you can see, it's a OEM, it's a fabricator. Good structural fabrication is ensured. The quality of metals, plates, tubes, pipes are all new, well tested. And then they have full-fledged QA, QC, quality assurance and quality control departments, good engineers, and of course, I have not mentioned here, but very well qualified welders, inspecting agencies like Lloyd's, Bureau Veritas, DNV, they come into their plants, check, and we get is a very good boiler manufactured. But the moment it comes into a power plant, hell breaks loose because there suddenly you have a temperature of 200 degrees centigrade to 400 to 1600 degrees centigrade. Then you have pressures. Then you have coal coming in with high ash contents, probably, as I saw earlier in the morning, 40, 50%, I don't know, different quality. And then everything, the whole dynamics changes. So the same good boiler, immediately after commissioning, you can get problems. And what to say, there is nothing mentioned here. The quality of welders, the training and the background is far, far fresh from what actually it should be in today's time. The second big challenge is, on the left, you see, these are just not some codes in some book written somewhere. They are live realities, which all the actual industry boiler manufacturers follow day in and day out. Are these really being followed to the hilt? Does the welder at the bottom line know these standards? What are the codes? Does he at least have an early? He did not know it by heart, but is he going to practice it? Does he know his seniors? What is the intention of these codes? And what, if not followed, can lead to catastrophic disasters? If that awareness is there, leading to safety of boilers, that is good enough for a welder. But I'm afraid the question marks on the right are too many question marks to be answered, and there's a big gap between the boiler manufacturer and the actual boiler ticking live in a power plant today. Like ASTM, if somebody in the audience, if half of us know, because most of us are engineers here, it's American Society for Testing Metals. What is it? So at least we are aware of it. Does the welder is aware? Is there a welding supervisor? Is there a welding engineer in the plant? It's a must in a boiler manufacturing production. But do we have a welding engineer who understands the whole gamut of this, and can he translate it down to the welder? I'm afraid it probably does not exist. Then ask me codes. You're the industry captains. I'm not a boiler specialist, but American Society for Mechanical Engineers, and then the boiler codes there. AWS, a big chapter. It's American Welding Society. We all follow that, and there are many other subsections. It's a very big manual there you have to follow, including the heating, preheating and post-welding. Those are the standards which have to be followed. How much are we following? Yes, no. Then IBR, of course, you are the captain there. Then post-weld heat treatment resources, do we have on site? Then the European standard in WPS, which is Welding Procedure Specification. And then a PQR, which is made subsequent to that Procedure Qualification Record. The rule is, when the welder starts to weld, anywhere welder in the world or in India and in Maharashtra, welder cannot start welding without a welding procedure in front of his eyes. If there's no welding procedure, the welder can say, "मैं welder नहीं करूँगा." क्यों? Welding procedure सामने नहीं है. He can just stop. That is his right. Right? So I pause sometimes just for reflection and thoughts. So all these things come, NBIC inspection code for repair. In the end, running of a boiler is the whole activity is repair and maintenance of a boiler. We are not manufacturing a boiler. We are not manufacturing the coal. We are manufacturing steam, yes, through the process. But in the end, in the whole longevity of the boiler, which can be several decades, it's all an activity of repair and maintenance of boilers, tubes, superheater tubes, preheater tubes, and the nozzle areas, the high temperature, high corrosion, high erosion. All these deadly things are there, which are absolutely time bombs on our daily lives. And then qualified welders, yes, we don't have all of them. They need to be certified. We'll take it more as we move forward, sir. This is a typical construction basis. What you have at the bottom is you have headers and tubes where the water walls are there, and then the water gets converted into steam, and the superheater and reheater, and then the main steam from the top, I guess it goes into the turbine, the dry steam. High pressure, high calorific value, it goes into the turbines, which converts into the megawatt unit of electricity. Now, diving straight into the welding applications in a boiler, as you see on the left-hand side, there are some 10 or 12 different types of welding applications. Critical, almost all of that is critical, right from your nozzle area, it's very high temperature. Then you have the tube-to-tube welding, tube-to-tube sheet welding, tube-to-drum welding, header weldings, circumferential seam weldings, dish end welding, and also reheater, superheater coils, which are high alloy steels actually, nickel-based, and high chromium, high nickel alloys to withstand temperature, corrosion, etc. So these are the typical welding applications there. Then what are these? The same applications, what you saw, the red points, as you see there, they are actually the welding points, critical welding points, and they have to be 100% radiographic quality, all must pass. Are they really passing out? Passing all this tests? I'm not very sure. So you have in the stream drum where the welding points are there, you have water wall, welding in superheater, reheater tubes, the header points, shell attachment, and circumferential welds as well. So we need to take care of these welds like we deliver a healthy baby. A mother delivers a healthy baby. If not, it's a problem. Now, seeing the welding defects, we come across this, hear them, अरे porosity है इसमें, undercut है, penetration low है, ये है. But what is this? Does the welder really understand? One guy understands, but he's a shift engineer. He probably worked earlier in Thermax and now he's in a power plant. All that is okay, but can he translate it to the welder? So these are very typical, simple things. If you control this, it looks theoretical, but if you don't handle this here, you have problems all through. An undercut, the black portion as you see there is actually the weld joint, and the adjoining gray area is the base metal. And then between the base metal and the weld joint, there's this area called a heat affected zone on both the sides, and you have to control that as well. It's all a game. The chemistry and mechanical properties of the base metal should be exactly same as that of the weld metal in the center. Same chemistry, giving you same mechanical properties. And then also there's a third area called heat affected zone between the base metal and the weld pool. That also has to, if there is a gradient of difference in chemistry, in metallurgical properties, in phase properties, or in mechanical properties, the weld will fail, and then the tubes will fail, and we are not far away from a disaster or an explosion. So spatter, as we say, spatter, all this is also productivity. You'll have to re-weld, remove, re-gouge, and do it again. It's also a cost factor, which can also be, which is also a part of the cost increase in productivity repairment, as my earlier gentleman speaker spoke about, Synergy spoke. So these are basically 10 or 12, there can be many more, but we'll take it as we go forward. Now this whole thing, if you have to summarize, welding applications in a coal-fired power plant boiler, on the left-hand side are some of the components like drum, water walls, superheater, reheater, headers, furnace, firebox, dish ends, boiler mountings, economizer, air preheater. And the second column is actually the welding application, be it seam welding, tube-to-tube welds, alloy tube welding, header-to-tube welding, nozzles, manholes, end cap shell joints, safety valves, gauges, fin tube welds, thin tube, etc. Those are the applications. Each one is a distinct application, has a distinct welding procedure, has to be welded totally different than the other. And if you are just going to have one inexperienced, untrained welder doing the same thing in one position, not changing, not knowing any idea, we are in for big trouble, sir. Then the common problems, as we saw earlier, it can be a cracking due to porosity, lack of fusion. How you change it in a drum, for example, if you have a problem, all you do is you have to preheat before the welding, keep a standard thermal gradient, thermal level, and then you do the welding, as you say, with a qualified procedure, welding procedure. And after that, you do PWHT, which means post-weld heat treatment. And after that, like a doctor checks the health, you have to use NDT techniques, non-destructive testing methods, which we'll see some slides later. And only then, when you are assured, then you go on to the next weld. So this is what it means. It's very, very important. And almost always a subject like welding, metallurgy, material science is totally ignored. My little bit small experience where I go there, it's all on production, productivity, plant load factor, this, that. Abhi shutdown hai, shutdown ye karo, and there's no time left for even QA/QC or inspection of all the weld joints 100%. And This is an area which we would like to highlight today, the subject being welding defects and mitigation. Now, another challenge what you find here, again and again, I try to compare between a good workshop in Trichy or in Pune or somewhere, a boiler manufacturer. What you have there, that is ambient controlled. You have no acids in the workshop manufacturing the boiler. You have no salinity, you have no oxidation. The plates are absolutely clean. The welding equipment is of the highest quality, including automation, etc. And then the heat input is controlled. There are good welding engineers, good QA/QC, knowing what exactly they are doing. They give you a fantastic product. If Thermax doesn't give you a good product, you will go to BHL or you go to 1100 other boiler manufacturers, industrial boiler manufacturers. So that quality is absolutely assured, and the way it has to be done, they do it. And on the right-hand side, suddenly the same boiler comes into, it gets commissioned. From day one, you have temperatures of 200 to 1600, which was not there in the manufacturer's yard. There are process acids, process oxides all over, salinity, greasy surfaces, and then the welders are struggling to control the variables, whether it's a voltage, ampere, or the wire speed rate, or the shielding gas in a MIG welding or a TIG welding. I mean, it's all, you need to know how much flow, etc. These are all parameters are compromised. Wrong parameters, wrong parameter box results in a bad weld. Sorry, gentlemen, I'm going a little fast, little louder, because this is a very boring subject, metallurgy. So I don't want you to just sleep off. If you're feeling sleepy, there could be a cup of coffee or a tea at the backyard. Root causes. Ghisapita, root cause is a word terminology used every day in all aspects of engineering components, etc., etc. The root cause in welding, if I have to just summarize, are primarily fivefold. There could be more. One is the material issues. The second is the process, the welding process variable. As we just discussed, the processes could be 4 or 5 types. It is SMAW, manual welding, or MMA welding as it's called. Second one is the MIG welding. It's also called GMAW welding. Third one is TIG welding. It's also called GTAW, gas tungsten arc welding. And then you have these days, plasma welding, and then also submerged arc welding in the workshops if you are doing repeated welds and big thick plates, etc. So what is the process and the variables therein? And then finally, environmental factors. Environmental, our enemy in welding is moisture. Our enemy in welding is hydrogen. Carbon in welding is an enemy for us. So we'll see that a little later. So environmental factors and the quality of gas, the shielding. If you're shielding with 100% argon, is it there inside the tube? Are your clampings correct? Well, all that factors into whole welding. It's a welding engineering. It's a welding technology. Is it being followed in the power plants or any heat and mass transfer equipment like pressure vessels, heat exchangers? Because I understand people are from the infrastructure, there are people from the cement plant, steel industry as well, integrated as well as direct reduction processes, as well as sugar mills. We are all leading there. Maharashtra leads in all this. We have the highest amount of chemical industries in Maharashtra, more than 3,000 chemical and petrochemical, so to speak. Then the design fault, the design geometry of the weld, very tricky. You just cannot make any V joint and do that. You are in for problems. We'll see this a little later. And finally, the most important thing is operator skill. We've been discussing since morning from the inaugural letters of the honorable people on the dais, even till the last. Operator skill, welding skill is a challenge, will continue to be a challenge. Okay. When we are in the ambit of materials, which is an important root cause, basically what it is on the left-hand side, you have the components in the boiler, the materials there. And on the right-hand side, don't really focus what is mentioned detail in the grade. Basically what we are saying here is, in the coal-fired, boilers, what we have is, most of these materials are called chrome, moly, vanadium, low alloy, creep-resistant steels. I repeat, it is not just a mild steel. A mild steel outside what you find on a railing or a compound wall is just some iron, added to it some carbon and silicon. That is mild steel. You cannot use that in our zone in boiler because it's a high temperature, high pressure phenomena. What happens, we'll see later, but what the steels are made of ideally is chrome moly steels. It is also called creep resistant steels. It is also called fatigue resistant steels, or it is just called the chrome moly vanadium series steel. I'm repeating it again and again. Does the welder know something like this exists? Even if he hears, it's good enough. What it does, what it does not do, we'll see a little bit later. And then, as you move towards the right-hand side, you have the high alloyed. As you see in these two rows, especially that is the superheater and reheater, it goes here, because then in the end you have high nickel-based alloys towards the end. And then you have stainless steel like 310, 347. Stainless is something like 188, is a high alloyed steel. And these chrome moly steels are low alloyed. Why? Because you have very low percentage of chromium. Let's say 2/4 chrome, 1 moly. 1.5 chrome, half moly. Or maximum you have 9 chrome, 1 moly. This is the material. 9 chrome, 1 moly, you'll understand better when I say it's T91. T91 is T means tube, 9 ones mean 9% chromium, 1% moly. And when I say P91, it's the same as T91 grade. P means a pipe. And 91 means 9% chrome and 1% moly. These carbides form chromium carbides and vanadium carbides, and also your molybdenum carbides are very important to retain hardness and properties of creep and fatigue at elevated temperatures, as we see when the water transforms to other state of steam, say 200, 300, 400, 500. A lot of things are happening in the steel in the zone of 400 to 600 degrees centigrade. And then sometimes you can have in the nozzles till there up to 1600. Melting point of steel is 1600 degrees centigrade. So these are the temperatures these alloys are therefore used. They help to mitigate and maintain rather these two properties of the steel. And then when you have this base material as these steels, naturally the joining material in between, as we said, must be exactly the same of that. For that, for guidance, we have the AWS code, American Welding Society. You have the component on the left-hand side, as you see, the chrome moly, the grades. And then in the center, you have the welding processes, like SMAW, GTAW, and corresponding. It's very well structured, and you should be able to, even the welder has to be aware what consumable to choose from simple charts like this. Of course, the suppliers will tell you, the consumable suppliers will tell you what to use where. Your seniors also will tell you. And just because somebody has been using this consumable for last 10 years or 15 years, a welder has to still, why the hell you're using this consumable? Just don't copy and paste, because the materials are also being upgraded yearly, every time. More and more modern materials are coming, processes are changing. So we have to be aware of these things. Now, another welding challenge, as we discussed before, is the welding chemistry and metallurgy. What it does is carbon, more the carbon in the weld, what happens is the weld becomes hard. The more it becomes hard, it can crack and fail in the weld. Sulfur, more sulfur means fracture toughness gets reduced. Toughness, what is toughness? Toughness is a property of that weld which can withstand the impact. Then the third one is hydrogen. More hydrogen, it can lead to cracking. It is called something like hydrogen-induced cracking, HIC for short. Then you have more moisture, you have more porosity. More porosity meaning this moisture gets into the weld metal in the molten state and stays there. And that gas is an impurity, it's an imperfection, it's a defect. And that reduces the mechanical properties of the weld, even if you're using the same good joining, chrome moly joining, but then the creep resistance of the weld is lesser and the fatigue strength is lesser. Once this zone is different than your base metal, you have a problem. There's a defect there. Even the consumable is exactly what the doctor ordered, 9 chrome, 1 moly grade joining, but you have a porosity there. You have problems. So how to mitigate that? Later on we'll see. If you have low chromium or low molybdenum, even if you use a 9 chrome 1 moly and a P91 or a T91 steel, and if that gets reduced for some reason, heat, going into grain boundaries. Now don't ask grain, then you're going into, basically the structure is, from the top of it you just see a metal. If you see on a microscope, increase the magnification, you see some phases, and then you increase the magnification further, you see further grain boundaries, and then you increase further magnification, the scientists or metallurgists in DMRL or DRDO, they will tell you they work only with microstructures, and then you go down to the atomic or molecular. So this is basically material sciences. But what you have got a chance to see up to microstructure, the grains. So these chromium and molybdenum can migrate to the grain boundaries, creating problems. So in the actual metal, in the grains, there is a depletion of chromium and molybdenum, meaning those grains have got lesser chromium and molybdenum. That means the property there is compromised, and therefore there's a weld failure. So that is what it means, reduction of important, it's low alloy, very low. You have to maintain that chemistry. Like a doctor says, आपका heart में sodium कम है, blood में ये कम है. The small little, it's very important for the health of a human being. Same for the health of a weld. These things are very, very important. Then stress concentration. High pressure, high temperature, the thickness of the sheets, tubes increases, decreases in the longevity after 100,000 hours of running, 50,000. Nobody knows what. Inspection is not proper. And then that creates stress concentrations of different thickness and all that. So that reduces the creep strength of that steel. You have to be aware of that. Then finally, after welding, there are a lot of residual stresses. How do you mitigate that? You again do a post-weld heat treatment, raise the weld metal to a high temperature, about 700-800, and then cool it slowly. Then you remove the residual stresses in the geometry of the weld. Otherwise, you will get something like stress corrosion cracking. Now, don't bother about the whole sheet. What I'm just showing you on the left-hand side, these are chrome moly steels. It's simple to understand. You have a mild steel. If you melt the mild steel outside like you have on the railing, you have just iron, carbon and silicon. In that you put a little chromium, जैसा चाय बनाते हो, और थोड़ा सा molybdenum डालो, वो बन गया 2%, 2.5%, 1% बनाया, तो वो एक ग्रेड बन गया chrome moly steel. वो बता रहा है वहाँ पर. तो 91, P91, 9% chromium डालो, 1% molybdenum डालो in the same steel. But I mean, I'm very lightly, but it's not as easy as that. But you get a P91 grade steel. And what is on the right hand? This is what this chart shows. We have to be aware of. Need not go into the detail. The welder must be aware of the most, because the buck stops at the welder and starts there as well. Now, the second part, the materials part is over. We saw about 5 areas where this root causes. The second root cause is the process variables. What you can see, process variables means the welding processes, welding machines, and the man. The man, the machine, and the consumable. This is his daily job. So the variables form very important part. Any wrongdoing there creates a disaster. For example, if you weld with very high currents, you get a burn through in the weld, cracking occurs, there's a weld failure. If the travel speed of the hand is high, what you get is there's incomplete fusion of the weld, there's an undercut, and there's a poor penetration. There's a weld failure. For example, if there's lack of fuel, and all these things, joint preparation or cleanliness is not there, what happens is the porosity increases because the hydrogen increases, water content is high, electrical angle is different. All these are variables which play a very important role, leading to weld failures. So what happens is weld failures can be caused because of methods, incorrect procedure, welding procedure, inadequate preheating or inadequate post-weld heat treatment can lead to a weld failure. Materials, contaminated base materials, incorrect filler material, joining material can lead to a fail. The man, that is the welder, his skill, lack of skill, in the end we will see why skill sets are required in Nagpur and in Maharashtra, because we have got almost 10,000 megawatt, half the power being generated here in Vidarbha. So the welder training, welding institute becomes very, 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 very paramount. We're already behind by some 30, 40 years. We have already discussed this morning, there is somewhere in down south India a welding research institute in Trichy. Now we send there, they charge you, and then they come back, and that is far away. I mean, you cannot just have one institute. And then we have some ITIs, industrial training institutes. There are some 200, 250 courses there, trade vocational courses. Just 1 or 2 welding courses are there, which is very, very primitive and very retro and unupdated, etc. We'll see that at the end of the slides, why that institute and a good welder training is required. Paramount. They are actually the doctors for the welding, and that we don't have. We lack them. And then environment we saw, and then the measurement, simple measurement, that the NDT measurements, non-destructive equipments which we have in the power plant are not that updated, they're not calibrated, unlike the equipments, NDT equipments which we have in a workshop which manufactures fresh new boilers, for example. Then the third aspect of a root cause is a design failure. I'll just run through this. Design failure, needless to say, improper joint design gives you insufficient joint access. Or it can give you high stress concentration, leading to weld failure. Sharp transitions and sudden thickness changes. Sudden thickness changes if the design is not proper, and those stress areas gives you, we call that as stress risers. Stress points are there, and then there are weld overlaps there, again leading to weld failure. Then, for example, a complex geometry of a weld, I mean, the maintenance guy or the inspection guy cannot even reach, the welder cannot reach there. It's a design problem. What you can expect a welder to do a good repair job there? And all these things, and see, yeah, these are some of the reasons, 4 or 5 reasons, which can lead to weld failure. And finally, the fourth one is distortions. Distortion means change in shape and size of the component, which should never be done. If it's a tube, simultaneously throughout the tubing, pre-heater tubing and till the tub, everything has to be of the same thickness, same quality as it has come from the manufacturer till the end of the longevity of the boiler in the power plant. Could be several decades. So why distortions occur? Because preheating was not done, or less preheating was done. Then if you have a distortion, the welder has to do sequence welding, meaning the large area you weld here, don't continue to weld in the same area because you're increasing the heat. There'll be a banana effect, distortion happens. So you weld here, you go that side, weld there, come back to this end, come back to that, you sequence it so that the overall heat is distributed along the whole matrix of the steel, whole areas of the steel. Then use of jigs and fixtures, you can hold them in positions and then weld. So you can mitigate, reduce, stop distortion. Then post-weld heat treatment. After every weld, for these kind of steels, chrome moly steels, you have to do PWHT because you will get distortion because of the reasons we discussed. So the residual stresses which are there after the weld have to be relieved. If I have a problem in the muscle, it pains, I use a spray balm or do exercise or do physical exercises suggested by the doctor, and then the leg starts moving properly. Same thing happens to the weld there. Then control of heat. Heat is the biggest enemy for welding. I mean, heat, of course, and pressure is, of course, there. The stresses are pressure in a weld, and heat is the heat input by the welder and of the boiler per se. Okay, what are the mitigation strategies? What are the strategies? Some of the strategies to mitigate all those defects and problems which we saw earlier is you preheat, meaning before welding, preheat the job, weld it, and then post-weld heat treatment. Why? To reduce thermal gradients and residual stresses in the weld. Then proper material selection, as we saw, you choosing weldable alloys and filler metals compatible with the base metal. Strict welding procedure, WPS, must be followed. There's no compromise on that. And it's tailored to each specific weld. We saw some 12, 15 applications. Each one will have a different WPS. And then enhanced welding training. Again, we come back again and again and again. Enhanced welding training is not only need of the hour, it was the need of the hour 10 years back. So we need to have special emphasis on metallurgy and specialized process in welding. High pressure welding is not a normal welder's job. Big, good welders, experienced welders fail. Very well trained welders from WRI working in BHL Trichy or Hardwar or wherever, or even in Thermax in Pune. My friend and classmate MS Unikrishnan, who retired as the CEO of Thermax, we discuss all these things, and he's an expert in his area, me not. But this enhanced welding is a challenge even for them. Definitely for us in power plants, we must need it. And nobody will take the initiative. In my personal opinion, please allow me if I'm not well informed, but I personally also feel, apart from the others, the best place to have this is here in Nagpur and in Vidarbha, because of the core sector industries prevalent here. Finally, NDT, early detection of subsurface flaws, preventive maintenance. You do a health checkup with a doctor. NDT is your door to knock all the time for a welder. You always do a preventive health checkup of your welds. Even if there's no shutdown or there's a short shutdown, few days, few weeks, ensure that your team is active and doing the preventive maintenance using all the types, 5 or 6 types of non-destructive testing. He must know how to do it. And of course, controlled environmental welding. Then of course, we all the time have QA/QC, meaning quality assurance and quality control challenges in the power plant, in a running plant. Unlike in a workshop where it's been manufactured, there you have a structured, there are different divisions, departments, quality assurance alag hai, quality control department alag hai, welding engineering department alag hai, design karne, bahut sare log hai. So very little that you can fail there. But here, these things can lead to challenges, it can be compromised. If the access in the plant is limited during operation or during shutdown, then inspection on those tight spots cannot be done or it's compromised. So inspection is material properties. If the thickness keeps varying during the longevity and the process of the boiler working, high temperature alloy especially, there again you cannot inspect or you cannot do the quality assurance on time. It is a compromise there. Then internal conditions, as we said, high pressure and temperatures, and then scaling and deposits of oxides, etc. They go and stick there, changing the composite thickness of that because of the deposits. Inspection not being able to do. Disaster is on the door knocking. You have inspection failure as well. So these are the QA/QA challenges in the boiler world. Now, it's not new. For the last 175 years, you guys are experts in your field, running the power plants, pressure vessels, heat exchanger. 1854, year 1854 in the US, some 175 years back, poor welding at boiler seams. There was an explosion, killed some 21 people and some 50 injured. After that came what? It sparked the creation of the ASME boiler and pressure vessel code. Till date, we are following it with so many amendments and amendments. So it's not for nothing. After a big casualty, it's happened. Then again, some 60 years back in the UK, hidden weld defects caused rupture, leading to massive boiler house collapse. You can take this as case studies or whatever, but this is a reality. And don't think it has happened elsewhere. It is in our workshop. If the consciousness is there, that will happen in our place, then you are good enough to prevent it, you know. But if you are not aware, the welder is not aware, I मैं तो 8 घंटे का ड्यूटी करना, मैं तो बढ़िया मैं 10-20 साल से, you hear every welder say, मैं 20 साल से welding कर रहा हूँ, क्या मैं? But the same thing, if you're doing one mistake, 1 + 1 + 1, every year if you have upgraded for 20 years, 1 + 1 + 1, 20 times is 20. Quality of the experienced welder is 20. But if he's doing the same thing, 20, 1 × 1 × 1 × 1, 20 times is just 1. So he is doing that. But if you confront him, he is a 50-60-year-old, मैं यहाँ का दादा हूँ, मैं expert welder हूँ, सभी लोग जो आए, but he is doing mistakes himself. That's the problem we have. Then of course the lesson is, bad welds is straight away equal to catastrophic failures in welds as well as boilers. Perfect welding saves life. I'll take another 5-10 minutes. I'm intentionally being fast, normally not as fast as I speak. I go very slowly, but I'm thinking of the next speaker, you know. So just one simple case. I had put actually 2, but then I saw there's a paucity of time. I'll only take one case study. This is a reheat cracking in a P91 steel piping after it was commissioned in a boiler. I missed the word commissioning. Just freshly, newly commissioned boiler. There was a reheat cracking. So plant, of course, was coal-fired power plant. The component is reheat piping, grade P91. That is 9 chrome 1 moly vanadium steel. The issue was cracking was detected during the startup operations. Then what are the observations? Cracks were located in the heat-affected zone. We talked earlier, you have the weld zone, you have the adjoining heat-affected zone of the base metal, and then the base metal. So in that area, HSZ, there were cracks located adjacent to the field weld. This is called a field weld. Beside that is the heat-affected zone, and then the base plate, which forms a big pipe, header, or a tube. Then cracks oriented along the welding fusion line and partially into the base metal was found. So there were parallel cracks. So there was no immediate leakage. It's a new boiler. So there was no immediate leakage, but risk of catastrophic failure and a high temperature service was definitely imminent. So that is a case study to be looked at. Then what happened was the material was so-and-so P91 grade, failure type is reheat cracking, and creep enhanced cracking. Primary cause, what was the main cause? Inadequate or insufficient post-weld heat treatment was deduced as a cause for this failure. What are the supporting factors for this? It was high residual stresses in the weld, microstructure instability was there in the weld, microstructure we'll see a little later, untempered martensite, Don't go into details. Untempered means the martensite is a hard phase, very hard. It's the same steel, but when you heat and then cool it slowly, the same hard, untempered martensite becomes a tempered martensite, wherein the toughness is better, the properties. That's the beauty of the heat to that same phase of untempered martensite. Then fast welding. There was fast welding done by the welder. Who sees? I mean, the welder at 8 o'clock, if he gives after breakfast a good weld, can the same welder give you the same quality of weld at 5 p.m. in the evening when the shift is over, and with an ambience of 50 degrees centigrade in Nagpur, for example, ambience of 48, 60, plus the ambience, add the ambience of the temperature of the boiler where he's there, and surely you cannot expect a welder to do as good as he was doing in the morning at 8. And moods, if he has a problem at home. So then, later on we see why semi-automation, some upgrades have to be done, to mitigate this. So, and lack of strict monitoring during the PW. While the PW, you have to monitor what is happening. ऐसे लगाओ कर दो हो गया, then it doesn't, okay, कर तो दिया, लेकिन सही किया या नहीं, you have to monitor and you have to measure that. The next one, yeah, this is what microstructure also analysis was done, meaning apart from the physical testing, everything, microstructure, they went under a microscope, saw that before the weld and after the weld. After the weld, what happened was before welding, the martensite was like that, all that grains, as you see lines, they're all separate, which means they are not connected. The grains are not connected, which means it is hard. That's because of which the cracks were there. And when you do the post-welding, the same lines got united and formed a set of grains. And this is what you should have on the right-hand side. So then you don't get the cracks. What are the corrective actions taken? What was done was localized post-weld heat treatment done was 760 to 780 degrees. There is a reason why you do it at 750 plus, because there's something in the steel carbon equivalent diagram you would have studied in colleges. After 723 AC line, where the solid phases change. So you go above that line of 723 Celsius, you cool it slowly or fast. If you cool very fast, you get hard martensite. Cool it close, you get austenite, which is a softer and a better ductile and a better. So these are the same steel is behaving differently, and all the deadly enemy here is the heat, is the temperature. So for 2-3 hours, PWHT was done, and slow cooling was done. That was one other thing. Then mobile resistance heating units were done. Mobile heating units you must have fully calibrated with the thermocouples also calibrated and spread out in the right place. Not if it is missing in some areas, as my earlier speaker said, you have problems in measurement. So you have to design that as well, of the thermocouples where you place in this superheater tubing, etc. Is it been done today? Correctly done? Is a big question mark. You know better. Welder still does not know, sir. You know it, but you have other things to do, so you neglect it. Then what was done was welding was repaired, of course. Defective welds were removed, and then re-welding was done under a revised welding procedure with strict control on preheat temperature more than 200 degrees centigrade. There's a big difference. If you preheat at 100, मैं तो heat कर रहा हूँ, थोड़ा सा gas burner लगा दिया 100 degrees centigrade, it doesn't work. Only after 200 degrees centigrade, things change there. It is actually called preheating. ये सब बारीकियाँ हैं. तो ये सब करना बहुत जरूरी है. And interpass temperature, if it's 2 layers, 3 layers you're welding, there has to be an interpass temperature. So all along the heat should be around 200 plus. Otherwise, when it's cold and hot, it's a problem. There's a thermal gradient there, prone to crack. So yes, all these things were done, and immediately after welding, post-weld heat treatment was done. Not after 1 day or 2 days or 3 days. Things change a lot. Then enhanced non-destructive testing was done, meaning 100% UT, ultrasonic testing was done, and also again after welding, replication of the same metallography was done. Metallurgy, under the microscope. Then you find, okay, there's good, now grains are all covered with martensite, everything. You assure that, then your job is over, that the weld is good. This is the complete cycle. What are the lessons learned? Strict compliance with the PWHT requirements is a non-negotiable term for P91. Stress relaxation cracking can occur even within a few operating cycles if residual stresses remain, like in this case, a newly commissioned boiler. And field welds, the field welds which are done in creep-resistant enhanced ferritic steels, chrome moly steels, require special care compared to conventional low alloy steels. Then importance of welder training, again, we come there. Welder training and strict WPS adherence for creep resistance material is absolutely mandatory. Then microstructure before and microstructure checking after the PWHT is absolutely a must. Who is the best doctor of the welder? NDT. NDT means non-destructive testing, like a doctor does. Non-invasive surgery. Then there's the invasive surgery. So many things in life. It's all connected to human life. The same, the best. If he's the best doctor of the welder, does he go to the doctor to NDT to check the health of his welds? Or when the weld is really bad, even there, does he use the correct NDT process? I'm afraid these things are not happening. Then why is it done? Okay, to assess. There's also, somebody is going to present later on, I think Mr. Wankhede, on the remaining service life, longevity. To assess that, preventive NDT in boilers has to be done. Then you have metal fatigue due to continuous temperature cycles. There's a thing called fatigue strength is lowered. Like creep strength, you have a problem, and that's where NDT is required. Pressure fluctuations happen all the time because of raw material impingement, as Mr. Sinha said, in the nozzle heating area or anywhere in the steam, speeds of steam, dry, wet steam, anything can happen. It's a big, it's a big laboratory. It's a big laboratory, I would say, of heat and mass transfer. And you cannot really have probes inside to check what is happening in real life. There's also coming monitoring as we move forward. Then chemical deposits, metal oxides, all this are a problem which increases the total thick sections of the wall thicknesses of the pipes and tubes. And the 5-6 methods are like this. Most important is the visual testing. You have to train somebody very well in the QA/QC team who has a special eye just with the visual testing to find. So that's the first thing. Just run through, just not see dur se dekha, torch mara, that's not enough. People who have, the mind is important. So visual testing, you have the dye penetrant test, you use different dyes, it's a very simple test. You use the dye in color, and then the cracks, it absorbs the white, and you find red colored cracks. Very hairline cracks also are detected. Then the most two important ones are ultrasonic testing, the sound, the goes and hits, and when there's a deformity or a defect, it hits there, comes back, and then if there's no defect, it goes straight through with that. Can the welder, has he ever seen what a report of ultrasonic test is? And of course, the most important is radiography. Can he read an X-ray? It is nothing but an X-ray. It's an X-ray impinging. The best one is, of course, are we doing 100% radiography? Are we doing 5% radiography? Or is in a whole pipeline only one we are doing it and then concluding that everything is okay? Or do we have to do 2 or 3? I was discussing yesterday, Mr. Chaudhary, he said, "Do karna hai, 3 karna hai." And then, if we are not doing, third parties are doing this, and there is a lot of malpractices also. Let us accept openly there are malpractices even in this, all the time. I'm taking a pause now after the word malpractice. So let us be aware. We are playing with absolute, of course, life and property. Life more important. We are straight away playing with life. And if the doctor himself is going to ill-treat you, what else can you do? That's NDT. So this is what we're talking of. So that's why we take a little bit, minute or two more to get this absorbed. And if there are lack of equipment, latest equipment, please invest, take up capital expenditure. Let's go to the boss, GM, and get it approved because it's mandatory. नहीं वो रुकेगा ठीक है पहला वो pipes मंगाना है यार ये करना है उसका पैसा बढ़ गया. There'll always be this haggling around. But please insist that we need to change. It's a change. Okay. Now today we may not have enough time on this. This would probably take a whole day. As we said, the whole boiler, what we're doing is a repair and maintenance of a boiler made in a very nice workshop in Trichy or Pune or somewhere, or East Jack or whatever. But there are all the time what is happening is because of heat, pressure, temperature and all that, there is a wear and tear happening of the steel all the time. Now we don't have time. It's happening in coal mill crushers, for example, whether it's a cement plant or a power plant, all the time, because you have coal mill rollers there. There is materials, not even this, where even unweldable materials like Nyhard 4 grades, cast irons, and that's crushing the coal, and it's wearing out. You have to do overlays. R&M means repair and maintenance. M&R means maintenance and repair. It's the same thing. there we don't even have time to go to a coal mill crusher there. Or in a cement plant, you have a fifer mill or, MPI mills and stuff. The same Nihad rollers, it crushes limestone, it's wear, tear. And coal, as we talk, very high ash content, very high hard, low ash content is low wear. Very high ash content is very high wear. And then you have what in coal mill, you have those castings, and I think, if I remember, bull ring segments below and all, that used to be the old one. I don't know if the plant and machinery have changed. So erosion, corrosion, friction, abrasion, impact, and heat. This is happening all the time. So we need to be watchful of this and take corrective steps. And when you do this R&M, most of the time when you're rebuilding, it is not joining of metals, actually. The worn out component is actually resurfaced, weld overlay. You put metal deposit, you use the same machine, welding machines, to do weld overlay, weld deposit, and in such a way, and then you grind it and finish it, bring the component back to its original shape and size. This is what we are doing all the time, but the correct consumables. There's a malpractice, I remember, a 3010 grade alloy, which is called, I should not take brand names, but okay. 3010 alloy is an austenitic, it's a dissimilar alloy. You can join anything. Kuch nahi hai to, but it's the most expensive, probably 15,000-20,000 rupees a kg. But we use the correct place, it's okay. But if you use on a staircase of maintenance, there people are making the cross and all that, just because of the malpractice. And of course, the supplier, I can see some smiles there. Yeah, it has happened to all of us in the past. The supplier is very happy. If he has to sell 100 kgs, he ends up selling 1 ton, 2 ton, 3 ton. It's a problem. That's very expensive to be used very critically for joining. Then there is manganese, Hatfield manganese steel for your hammers, etc. It's a 14% manganese steel, totally different than chrome molybdenum steels, totally different from mild steel, totally different from stainless steel, which is 18 chrome, 9 nickel, high alloy stainless steel. Functions are different. So what happens here in the wear and tear industry, well, you follow not AWS, this thing, you normally follow a DIN standard, a German standard called DIN 8555. There you select the consumables, don't try to read the details. This standard says, based on the wear phenomena, or which type of wear, whether it's wear due to abrasion, wear due to erosion, wear due to temperature, or due to impact, you select a corresponding consumable for that and do the overlay. Because we are in the zone of boiler tube, we are not going to other auxiliary equipment where the wear and tear is happening in a power plant. Like, for example, in a boiler tube coating, what happens here is you have cracks and wear out because of abrasion and heat. So what you do is another process called arc spray. It's again like a welding process, plasma spray or arc spray with the metal powders. Whatever is worn out, you just arc spray, you remelt the metal powder, remake the shape of the job, grind it a little bit if it's grindable, and there you are, it's back into shape. Another example is coal burner nozzle, for example, very high temperatures, is made of stainless steels, but then it's worn out. What you do is there is crack and worn out. What you do so when you do an overlay, you have to use either the same material or a material, an alloy higher to that grade. This is stainless steel. Let's say normally it's 316, 18 chrome, 9 nickel. You go up and go to a 90% or 80% nickel alloy. Nickel alloy is much more nobler, much more expensive, but it can withstand hardness at elevated temperatures in this area. Retaining red hardness, we call it, at elevated temperatures is what nickel alloys do. It's very expensive, but you have no choice. It's better to repair and wait for the replacement of nozzle through a supplier, which may take 4 months. So these are the things, repair and we just stop it at it because the subject is too long of where repair and maintenance, as I said, we shift more. So what are the future trends? I'm really very sorry that I don't speak so fast, Chaudhary Saab, but I have to do that because I have to go to the end and want to see a visual of how our welding institute in Nagpur is going to look. That Mr. Chaudhary will help me show by the end of the day, I guess. So the future trends, it is not far away. It's happening elsewhere in the world. It is automation and robotics. It increases the mechanics, because these are our best bets to mitigate, to depend 100%. Okay, now I'm closing it. The skills and trainings, the last one. We have, let's say about 1.2 million welders all over India. Most of it is in the unorganized sector. If you see what's actually registered, you see only 16,000 welders. The grill, the garage welders, etc. But in Maharashtra, again, leads from the front. We have about 150,000 to 180,000 welders, all in the unorganized sectors. And what is being catered to this, from where they're coming, ITIs, very unprofessional area from where we have to get welders for the boilers. So this is not done. Only hardly 1 or 2 courses out of the 200 trade courses is for welding, and that it's very outdated and they need to be upgraded. So that's not the area. That's the reason we need a brand new, bespoke, state-of-the-art welding institute in this very place in Nagpur for the welders in power plant industry. Okay, we have about total 6,000 plants. I mean, I'm including most of them, which are in heat, whether it's pressure vessel, heat exchangers, and boilers, from the sugar, cement, iron and steel, paper, all in Maharashtra. And also the chemical and petrochemical. Total, we have about 6,000 plants. And all welders are here. Are they welding correctly? Probably not. Are they fully trained? Probably not. Are they fully certified? No. So this is where, so what skills require? The welder requires a little bit of maths, a 10th standard math skill to leverage, a little bit of science application and understanding, a little bit of blueprint reading. If he sees a sign, it's a vertical up welding. If he cannot read that, he's not a welder, but he's welding all the time. Then apprenticeship programs continuously have to be done. Then welding certifications have to be done. I quickly go on. Okay, aging workforce, there's a skills gap and all that, lack of training programs, low recruitment efforts by employers. Most of them I can see we are not making enough efforts to employ. And finally, as we say, we have a current shortage of 1.2 million welders or welding professionals in India. It is going to zoom up to 1.35. I see a board there somewhere, the same slide, from the same source. So we need a dedicated welding institute, not just for the power plant, but for the similar power plant or the boilers which are existing in the cement, steel, sugar and chemical industries as well. And in Nagpur, Maharashtra, we need it all the more urgently. 150 days is the target. We all be very happy when Mr. Chaudhary gives us that institute. And all of us, let's delegate, let's send our welders to train and make it, again, lead from the front in India, in Maharashtra. In short, high-pressure welding courses are more specialized and advanced, focusing on specific techniques and safety procedures to avoid boiler accidents. The risk involved in high-pressure system is very high, so we need, needless to say, I'm just summing up, because of extreme stress, material required, we need real strong courses running into days and weeks and months to to produce good, trained welders. The welders must also meet standards like ASPE boiler and pressure code, and failing to meet that, it's just not the huge fines imposed, but shutdown, but it's catastrophic, and it can lead to death due to explosion. Okay, specialized techniques in high pressure welding courses will be there. We will have the institute material expertise on all. We will have rigorous inspection and testing courses in NDT, and also to create a safety mindset all the time. And I think, of course, Maharashtra is the only state which can give this institute, and Nagpur is the best place. Why Nagpur? Not because Nagpur is an orange city, not because Nagpur has a 0-mile geographical center in India, not because Nagpur is the winter capital of, let's say, Maharashtra. No, no, no. It's only because, as we discussed before, almost half of the megawatts generated by the coal route is in this area. And why? Because Vidarbha is the highest region in Maharashtra, is very, very rich in minerals and ores, whether it's coal ore or iron ore or limestone or manganese ore. And finally, boiler welds. You may repeat this in your mind, so it stays with you after me. I'll read it slowly. In high pressure welding, perfection is not a goal. It is the standard. Boilers don't forgive mistakes, neither should we. Every flawless weld is a silent guardian against a disaster. Strong welds means strong lives. And in conclusion, quality means doing it right when no one is looking. Finally, safety means welding right when no one is watching. Thank you, ladies and gentlemen. Sorry it was a little more.
Thank you, Pradeep Joshi, sir.
Thank you. थोड़ा long झालं.
For his excellent lecture with the beautiful note that strong welds, strong lives. I will add it to that strong nation as well. On behalf of Boiler World Update and appreciative listeners in this August hall, I express my in-depth gratitude towards Engineer Pradeep Joshi sir for his well-presented lecture. Dashing and confidence is Joshi sir has explained in very simple words the complex and manageable challenges of the welding scenario by his expertise in technological upgradation and adherence to best welding practices. I am confident that the boiler industry can achieve safer, efficient, and long-lasting systems for the future if his suggestions are implemented in the industry. I will request Anjali Patwardhan madam to proceed with the felicitation of the speaker. I will request Joshi sir to be on the dais for fun.
Thank you, Mr. Joshi, for
Thank
that
you, thank you.
session. As a token of our appreciation, we would now like to present you with a memento
Thank you.
and a sapling, a gesture of gratitude and a symbol of lasting impact and sustainability. I now invite Sri Sachin Chaudhary to kindly do the honors. Sachin sir.
Sorry, खूप म्हणजे फास्ट बोलायला लागला. कंटेंट जास्त होतं. हां. Yeah. Yeah, thank you. Thank you. Thank you. Thank you. Thank you very much.
Thank you, sir.
Sorry.
I will request Sandekar sir to take over the proceedings.
हे काढायला लागेल.
Good afternoon. I am here once again for the introduction of the speaker. I learned about Mr. Pradeep Joshi that he is from VNIT and JBIMS. I am very happy to share that I too am a student of VNIT and also Gujarati Institute of Management Studies. It is always a pleasure to welcome somebody from the institute. It is a strange coincidence that again I am going to introduce a speaker who is also from VNIT, none other than Mr. Gajanan Wankhede. And it is an absolute privilege for me to welcome him. Mr. Wankhede is a seasoned professional holding a bachelor degree in mechanical from VNIT Nagpur and also the MBA in operations from Mumbai University. He also holds a diploma in information technology from CEDIT Delhi. He has got over 3 decades of professional experience and he has made significant contribution to the power and steam boiler sector. Initial 12 years he has spent at CSTP, that is Chandrapur Supal Thermal Power Station, and actually gaining hands-on experience because that is very important, you know, the actually hands-on experience is extremely important. Later on, he is now with the Director of Steam Boilers, Maharashtra, and he is the Joint Director and is actively involved in shaping regulatory practices and safety standards across Maharashtra. These two things are extremely important, regulatory practices and safety. It is a matter of concern for everybody from the rank up to the topmost level. Notably, he has served the Society Board of Examiners for Maharashtra State from 2016 to 2022, and he currently represents a very important position. He is a member of the Gasket and Packing Sectional Committee of the Bureau of Indian Standards, that is BIS. I think it is an extremely commendable achievement that Mr. Gajanan is having. And today he will be talking about the residual life assessment, that is RLA, of boilers and certification of boilers under Regulation 376FF.
Dear learned friends, being the eminent persons from power industry, all of you know that we need to equip ourselves with expertise to handle flexible load operation scenario. During flexibilization, drastic load variation will invariably lead to creep, rupture and fatigue of various materials, which will invariably reduce the useful life of various pressure part components. A wise and experienced engineer and learned managers need to assess the residual life of various vital components of pressure parts before adopting flexible load operation mode. Perfect evaluation of residual life by condition monitoring and non-destructive testing becomes the order of the day in this perspective. I request the honor of presence of Shri Gajanan Wankhede sir on the dais to deliver his August lecture.
Please, the stage is all yours.
हे कुठे ये नेक्स्ट के लिए ये है ना Good afternoon, everybody. I know I am standing between you and lunch, but this is very important as far as the power station and process boiler people are concerned. But I will try to make it short because the organizers ने भी मुझे बताया कि जरा short कीजिए. Already we are running late. First thing, I want to know how many of you are from power industry. Please raise your hands. Okay. Most of the people are from power industry. And how many are from process industry? Process. Continuous process plant? Petroleum? Okay. Okay. So, most of the people are from power sector. My presentation is in two parts. Two parts means it is one part only, but halfly dedicated to power sector and other half to process industries. मुझे एक चीज आपको पूछना है, बॉयलर की लाइफ कितनी होती है? What is the life of boiler? Anybody? 25 years. Anybody? As a regulatory body, मैं बोलता हूं और हम बोलते हैं कि बॉयलर अमर है. There is no life as such for boilers. बॉयलर अमर है, मैं बोलता हूं. Because we have seen many boilers, those are running very well even after 100 years of service. And we have seen many boilers which are scrapped after 10 years also. So that depends on how you maintain the boiler, water quality, its environment, flue gas properties, all such things matters. So there is not anything that the boiler's life is 25 years or 30 years. You take in mind, boiler अमर है. अभी उसको अमर कैसे करने का, that is up to us. All these things are mentioned in Indian boiler regulations. That regulation is 391A. It is in two parts. One is for shell type boilers and other is for water tube boiler. In shell type boilers, we do not carry out RLA and all such things. After 25 years, we straightway reduce its working pressure by 5%. After then 35 years, we reduce it to 90%. Means we reduce by 10%. So another category in shell type boilers, earlier there were no such advanced techniques like ultrasonic thickness measurement and all these things. So what we used to do to know the life of boiler, we used to cut the plates of boiler. We test it in laboratory, and then based on the results of lab test, we fix the pressure of boiler. Those boilers, such type of boilers, after cutting the plates, those are allowed to run for more or other 50 years. And after 10 years, the pressure is reduced by 10%. After 20 years, it is reduced by 20% and so on. Now, shell type boilers, third category is shell type boilers, but those are wasted boilers. What happens? if we apply that formula, straightaway formula, that reduction by 5% or 10%, the pressure of boiler that is reduced. But many companies, many industries, they are running the boiler, so they are maintaining the boiler so well that their parts, their pressure parts are so maintained that they are at very good condition. So unnecessarily reducing the pressure of these type of boilers straightaway by 5% or 10%, it is reduced by 5% or 10%. But what happens in many industries, in petroleum industries and these petrochemical industries, if we reduce the pressure even by 0.5 or 1%, the complete process is disturbed. So there was a demand from these industries. Our boilers are good, so there should not be straightaway reduction in working pressure. Instead of that, RLA should be carried out. So in 2020, one new regulation for such type of boilers is introduced. That is shell type wasted boilers. Here, earlier there was no RLA residual life assessment of such type of boilers. But now, after 2020, it was introduced for such type of boilers. So it is to be carried out by the RLA carrying agency, which are approved by Central Boiler Board. And if according to recommendations of these RLA carrying agencies, we reduce the pressure if they recommend or continue to operate it for another 12 years. After 12 years, again, RLA is to be carried out. But for such type of boilers, there is an option to owner. They can opt for RLA or they can opt for direct pressure reduction. So the problem of straightaway reducing the working pressure of that boiler is reduced and minimized by this introduction of this new regulation. Now, another is water tube boiler. Here we carry out residual life assessment of boilers. Now, these boilers are categorized in 3 parts. First, the boilers which are working above 400 degrees centigrade and up to 1 lakh running hours. Those boilers are to be assessed by residual life assessment after completion of 1 lakh hours. And this is to be carried out by RLA carrying agency, which is approved by Central Boiler Board. And this RLA report, this RLA is valid up to 6 years. After 6 years, again you will have to carry out RLA of that boiler. And what is to be done in the RLA study? RLA study is to be carried out as per table 1 of IBR. What table 1 shows? It is all given in your literature. So we are running late, so I will not go into details, but this is table 1. In steam drum, what tests are to be done, in other superheater coils, what tests are to be done. All this complete is in table. So I will not go into detail because we are running by. Now the second category is the boilers which are operating below 400 degrees centigrade. For this category of boilers, that criteria of 1 lakh running hours is not applicable. For these type of boilers, the criteria is age of boilers. If the age of boilers is 25 years, then for such boilers which are operating below 400 degrees centigrade, the RLA is to be carried out. And again, that RLA is to be carried out by RLA carrying agency approved by Central Boiler Board. And for this type of boilers, the validity of this RLA report is up to 12 years. After 12 years, again you will have to carry out RLA of boilers. And here you will have to carry out the RLA as per table 2 of IBR. That table 2 is here. It is in your book, so I will not go into details. Third is those boilers which are operating below 400 degrees centigrade and those are having pressure less than 50 kg centigrade. So in such type of boilers, there is no need of such elaborative RLA. Only headers and drums are to be inspected by non-destructive test, only 3 tests: UT, MPT and LPT. So the boilers which are working below 50 kg per centimeter square and below 400 degrees centigrade, there is no need of RLA study. Only NDT is to be carried out. Now third is the boilers which are heat recovery steam generator. Those are not directly fired boilers. And here also, those working above 400 degrees centigrade and up to 1 lakh running hours, the only difference is that it is to be carried out as per table 3 of IBR. That is table 3. Here you will see an earlier table differences. There are many very small number of tests in table 3 because those are boilers, they are clean air is clean flue gas is there because it is a waste heat. So there is hardly chance of corrosion. So very few tests are in this type of boilers. Now this is a summary of all these things what I have told you. Now second part of my presentation. What is the certification period of a boiler? And that is, I think, more you are interested, particularly power people, because they always come to us for extension of certification. Sir, 1 साल का चाहिए, 2 साल का चाहिए, 2 साल हुए तो भी चाहिए. So, ये जरा ध्यान से सुनिए. Generally, the certification of boiler is for 1 year. But for power boilers and the wasted boilers which are operating in continuous process plant, there is a special provision in regulation. That is, those 2 regulations are there. 376 FF, that is for power boilers, and 376 FFF, that is for wasted boilers. Now, I will explain about 376 FF, that is for power boilers, because most of you people are from power sector. The boilers which are operating above 100 kg per centimeter square and up to 1 lakh running hours. Firstly, they are to be inspected in detail as per regulation 390. Then, for these boilers, there is a provision that after 12 months of certification, that certification can be extended by 1 year. But in this case, we check the operation data of superheater, water quality, history of shutdowns, records of any non-destructive test, boiler tube failure records. After evaluating all these things, and the one form is there, form 19, that is called form 19. That is to be submitted for applying for recertification after 12 months. So the officers of our department, they check, verify all these parameters, and if found satisfactory, that boiler is allowed to run for another 12 months. So total certification period is 24 months. But after 24 months, you will have to stop the boiler. मैं भी MSCB में था, महाजन को में था, हमारे बहुत सारे दोस्त इधर है, वो क्या करते, वो कोई एग्जीक्यूटिव इंजीनियर गए उनके पास, तो हमारे दोस्त है वो टॉप पोजीशन पे है वहाँ पे, तो वो बोलते अरे नहीं नहीं नहीं, वो मैं वानखेड़े से बात कर लूँगा, वो अंतापुरकर साहब से बात कर लूँगा. तो बट आप नोटिस कीजिए कि ये किसी से भी बात करने से होने वाला नहीं है.
you will have to stop the boiler after 24 months. वो अंतापुरकर साहब दोस्त रहेंगे, कुछ भी रहेंगे, कुछ नहीं होने वाला है. So you tell your superiors, your bosses that you will have to stop the boiler after 24 months. You take the shutdown and you plan accordingly. Otherwise, वो last minute rush और वो हमको भी अच्छा नहीं लगता. We are there. We are government bodies. We are there to help you. हम एक चौकट है हमारी, ये गवर्नमेंट. हम आपको हेल्प कर सकते हैं. ज़्यादा ज़्यादा कॉर्नर पे आके हेल्प कर सकते, लेकिन एक कॉर्नर के ये चौकट के बाहर हम जा नहीं सकते. सो प्लीज वो आप ध्यान में रखिए कि यू विल हैव टू स्टॉप द बॉयलर आफ्टर 24 months. नाउ second category is the boilers which are having working pressure up to 100 kg per centimeter square and up to 1 lakh running hours for the boilers operating above 400 degrees centigrade or 25 years of age which are operating below 400 degrees centigrade. एक बात ध्यान में रखिए कि 1 lakh hours and 25 years ये क्या है? For boilers which are operating above 400 degrees centigrade, 1 lakh running hours, that criteria is there. And for boilers below 400 degrees centigrade, that criteria 25 years is there. So for such boilers, again, the certification can be done or can be extended by another 12 months after checking all those parameters which I mentioned in para A. Now, but उसमें एक खामी है, ये जरा कभी कभी क्या होता है, अपना बॉयलर तो बंद हो जाता है, 1 महीने के लिए भी बंद रहता है, लेकिन वो ना हमको बताते ना ऑफिस को बताते, और बस देखेंगे जब आएगा तब, जब खत्म होगा तब. लेकिन in this regulation there is a clear cut provision that if you have a shutdown of 15 or more days, then you will have to carry out the inspection. Then in such case, if there is a shutdown of 15 or more days and you do not get it inspected, then you will not be allowed to get it extended by 1 year. So in such cases, you take opportunity to inspect the boiler, otherwise you will not get that extension of certificate. Third category is boilers working above 100 kg per centimeter square and more than 1 lakh running hours. Such type of boilers are to be inspected every year. Every year, those boilers are to be inspected. That certification will be for 1 year. But if the RLA of such boilers is carried out, then those can be extended by another 12 months. So the total validity of certificate will be 24 months. So again, 24 months is the maximum limit. Then fourth category, the boilers working at pressure up to 100 kg per centimeter square and more than 1 lakh running hours or below 400 degrees centigrade and more than 25 years. So these boilers are also to be inspected every year, but if the RLA is carried out, then those are allowed to be operated for another 12 months. So the maximum period you can see is 24 months. So any power boiler will get maximum certification period, that is 24 months. After 24 months, you will have to stop the boiler and offer for inspection. So मुझे आपसे विनंती है, पूरा मैं रिक्वेस्ट करता हूँ कि आप अपने बॉसेस को बोलिए और ये समझाइए, ताकि वो ऐन वक्त का जो ये रहता है वो हमको भी अच्छा नहीं लगता, पावर प्लांट बन रहे हैं. सो यू प्लान अकॉर्डिंगली. दिस इज summary of what I told. Now, my last topic is wasted boilers, certification of wasted boilers. Some people are from process industry, so I am taking the, otherwise I was going to skip these wasted boilers. Here there is no criteria of pressure, only age. And two categories are there. One is fired boiler and another is wasted fired boilers and wasted unfired boilers. First category is wasted fired boilers. If up to 20 years of age, first we certify these type of boilers for 2 years, that is 24 months. After 24 months, again, they can apply for recertification for another 24 months. They have to apply and submit Form 19. Then the officer of our department verifies it and check all this data, operation data of superheater, records of any NDT, water quality, any shutdowns, and so on. So total certification period of such type of boilers is 48 months. So these type, sorry, I am wrong, sorry. This is fired boilers. Those are to be inspected after 12 months and 24 months. So same procedure as was there for power boilers. After 12 months, we will verify the parameters, we will scrutinize the Form 19, then we will allow those types of boilers for another 12 months. Then after 24 months, again same procedure is repeated. You have to submit Form 19 and we will check all these parameters and again allow it to operate for further 12 months. So the total certification period, maximum certification period for such type of boilers, wasted boilers, is 36 months. Now next category is wasted boilers fired and up to 20 years of age. Here, the first certification is not for 12 months, it is for 24 months. Then after 24 months, you will have to submit Form 19. The officer of our department will scrutinize it, then verify the parameters as stated in para A, that is temperature from DAS, water quality, tube failure records, and so on. If found satisfactory, it is allowed for another 24 months. So the total certification period is 48 months. Now, third category, wasted boilers fired but having age more than 20 years. Such type of boilers are to be inspected every year as per routine procedure, every year. But again here, if the RLE is carried out, then those can be certified up to 36 months, means maximum period of this type of boilers, even though the age is more than 20 years. But if the RLE is carried out, then certification maximum validity is 36 months. And fourth is unfired boilers having more than 20 years of age. Here also, these type of boilers will be inspected every year. You will have to stop the boiler every year. But here also, if the RLA is carried out, then these types of boilers, same applies to these type of boilers, that wasted boilers unfired and having age 20 years. So these boilers are also allowed to operate for 48 months, maximum 48 months. But what happens, many times the technology changes, the requirement changes. So how these regulations are made? Those are based on, those are made on the requirement of the users. They represent to central boiler board that we are facing such and such problem. Now recently, the many petroleum industries, particularly refineries, they represented to central boiler board that due to advanced technology, their catalyst life is up to 5 years or 6 years. So for these type of boilers, maximum is 48 months, but their catalyst life is 5 to 6 years. So they represented to central boiler board to extend this validity to 6 years. And in central boiler board, the procedure is that many members are there. They discuss the matter and all thorough technical discussion is there. Now it is proposed to extend life up to the certification period up to 5 years. It is under consideration. So these regulations are changed time to time depending on the requirement of industry, technical advancements, and all these things. So this is summary of what I told about wasted boilers. That's all for. Any question? I think within time?
Yes, yes, well
Okay.
within time. Thank you for
Thank you.
abiding the time schedule of the conference.
Any question?
Questions will be taken during.
Questions
Okay,
will
okay,
be taken
okay.
in panel discussion, please.
Okay, okay. Thank you.
Shri Gajanan Wankhede sir has expressed a very beautiful lecture. It is my pleasure to express my wholehearted thanks towards Engineer Wankhede sir for his well-studied interaction with the curious audience. Creative and collaborative engineer Shri Wankhede sir has focused on regulation number 391A, regulation number 376FF and FFF, and has given a clear-cut explanation regarding the confusion of conducting RLA study. Thank you very much. I herewith request Shri Chandekar sir to arrange a befitting warm felicitation for expressing the thanks of the organizers towards Gajanan Wankhede sir.
Thank you, Mr. Gajanan. It was extremely informative, interesting, relevant and practical kind of a presentation. We are happy, extremely happy about that. As a token of our appreciation and gratitude for your presence and presentation here, I now request Mr. Bhanu Rajagopalan to kindly do the honors. Mr. Wankhede had mentioned that he was standing between you and lunch. Now there are many people on the stage. Anyway, we'll be breaking for lunch now. And I request, we should try to come back within 30 minutes because we have got 3 more sessions after this and a panel discussion which will last for about 1.5 hours. So now we'll break for lunch with a request that we reassemble, say about 30 minutes from now. Thank you so much. Thank you.
Hello. Hello, everyone. We'll be resuming the seminar sessions by 2:15. So request you to be seated by then. Thank you. Hello. Another 5 minutes, we will be starting the next seminar session. So request all of you to be seated. Thank you. करू चालू?
हो तुमचंच रेडी.
Good afternoon, ladies and gentlemen. Post-lunch, now we're ready to resume the seminar session. It is my honor to introduce to you a visionary leader in India's renewable energy space, Mr. Shyamal Chatterjee. Mr. Chatterjee founded Galaxy Solar Energy Private Limited in 2017. In just 5 years, his deep industry knowledge, innovative mindset, and cost-effective solar solutions helped position Galaxy Solar as one of the fastest growing companies in the solar segment. Today, Mr. Chatterjee will be presenting on integration of solar with thermal plants along with energy storage solutions for a reliable and sustainable energy future.
Dear learned friends, it must be mentioned here in crystal clear terms that solar energy will be the major contributor among intermittent renewable sources of energy. I hereby honorably invite Shri Shyamal Chatterjee sir to share his studied thoughts on integration of solar with thermal power plants and share his open-minded experiences with this rich August gathering. Shri Shyamal Chatterjee sir.
Good afternoon all. Actually, we are gathered here for today's meeting regarding all the boiler solutions, and I think today the boiler is needed with solar as well, because the cost effectiveness of the industry is more relevant regarding this solar installations. Whenever you do solar with thermal or boilers, it will be a very cost-effective thing for all of you. So I will describe few things how we can install solar in your plants. Like for boiler, we require regular heating. That we can do with planting new solar plants with your existing systems. It will we can maintain the boiler temperature with solar plants. They can the panels can be installed with that, and we can collect on thermal storage plants, and this will all introduce to a new technology with you, and it will be saving a lot. Like key benefits of solar thermal integration, first of all, you will be saving a lot of fossil fuels, and it will be under ESG also, environmental saving also, environmental betterment also. The second is operational, increase efficiency and reduces strain of your plants. The plants' lives also, the boilers' lives also got increases because of the hassle-free boiling tendency due to solar power plants. So it will be a lot of beneficiary for the boiler plants also to restrict to normal strategies of heating by using coal and biomasses and this thing. So through solar it will be saving a lot. Then storage specific, we can thermal energy storage is cost effective, long duration, and it could be put in an insulated solution to keep it for a long time, preserve it for a long time, and whenever needed it can be injected. Now key statistics, Indian solar capacity in 2025 has gradually gone to 105 gigawatt. So since 2024 it was only 84, so we added 20 gigawatt in more than 20 gigawatt in a single year, and now we are targeting for more than 40 gigawatt in single year. By doing this, we will be adding almost the total capacity of 500 gigawatt, which is a dream of Prime Minister Modi ji also to go to 500 gigawatt. So all the industries today are going on solar. Boiler should always be benefited, also can be benefited through this market, and thermal energy storage systems are there where we are hybriding boilers with solar. There are a lot of things which you could also expertise on. because being an industry player, you should know that how to save money by using renewable sources. So Indian solar capacity, you seeing that it is a old data. It is 105.4 gigawatt. It has been already installed, and India has jumped from country number 5 to country number 3 in the world this year. Thermal energy market, you know, this is a very big market, and BESS, battery energy storage system, thermal energy storage system, along with solar, it is a hybrid policy is now being supported by the Indian government also. They are giving some incentives also for this thermal energy storage systems. Now, key takeaways, you see, it is a reliable and sustainable energy. It can be reciprocated with your old tools and machineries. There is no need to install some more other type prototypes in this boiler. The same industrial boilers can be reciprocated with this solar energy. Leveraging existing infrastructure, that's why I explained that the retrofitting thermal power plants and all these old machineries only can be used to install and to get it done with this solar new power plants. So thermal can be very well now, it has been already very much experimented and proven technology that it can be very much hybrided with solar. Improved operational efficiency, it has already proven that it reduces a lot of biomass fuels, lot of energy conservation is there, and lot of environment saving is there through this. Policy support and incentive is already given by the Indian government. They are changing some more policies also. Like there was earlier a bottleneck that in power plants or in boiler plants, there was a problem of installation space. Now with the green net metering open access policy, you can install at one place in an open access plant, and you can use it virtually through in your plant. So there are a lot of things. The electric boilers, they are consuming more than 10 lakhs unit also per month, or in fewer months. So you can install solar and you can get that benefit also. Now, boiler industry and solar energy in India, the boiler market is now getting bigger, as well the solar energy market is also growing bigger. So we should shake hands together to get this done with a initiative of going green. Boiler efficiency improvement is also been proven through solar installations, and your boiler's life is also been getting increased through this, because the unless and until we get cuts down the carbon emissions and carbon fuels, we can get the benefit of solar. Indian solar energy landscape is that the role of boilers in a solar thermal hybrid system. So primarily what is done in a solar energy uses in boiler, the solar rays heat the components of PVs. The PV panels are there, photovoltaic panels. They then convert this electricity into heat, and this heat is transferred through fuels, fluids, which are then with some freezing elements, they are been kept into the tank reservoirs, and through insulation we can use it whenever needed. Storage is there, and in the evening then when the solar is not there, by preserving we can use it at night also. So that's the synergies between Indian boiler policies and the solar policies, which we can very well get forward and shake hands together with solar and save more and be more efficient and be more green. Thank you.
Yes. Shri Shamal Chatterjee sir has explained realistic, reliable and sustainable transition strategy towards clean energy. On behalf of this gathering and the learned audience in this decorated hall, I request him to accept our felicitation. Anjali Madam will arrange for his felicitation.
Thank you, Chatterjee sir. We would like to present you a small memento and a sapling. Please accept this a little token of gratitude from us. Sandekar sir, please come on stage. Thank you.
Next, fine. Sandekar sir. Sandekar sir will illustrate about the next speaker. I invite him to be on the dais.
Good afternoon, ladies and gentlemen. Please give me a welcoming out today's speaker for the next session. He is Mr. Abbas Chanekar, Assistant General Manager at Operations at GMR Varora Energy Limited. Mr. Chanekar is a seasoned professional with over 15 years of experience in the energy sector, specializing in operation management, digital transformation, and energy optimization. He holds a bachelor degree in mechanical engineering and postgraduate certificate in data science for business excellence and innovation from the prestigious IIM Nagpur. He is a certified energy auditor, 6 Sigma Black Belt, and lead auditor for ISO 50001. He has been instrumental in implementing several high-impact initiatives, right from AI-based predictive maintenance to digitized operational logbooks and energy management systems. Nowadays, people are talking about AI. All the people are talking about AI. It is the in thing, but he has already done the implementation using the AI technique. That is really creditable. Number 2, under his leadership, GMR Varora has achieved the BSc, that is British Safety Council's 5-star safety rating, and is recognized as a model for energy efficiency. Further, he has represented GMR at platforms like CII Energy Efficiency Awards and has been acknowledged as an energy leader for not 1, not 2, not 3, but for last 5 consecutive years. That is something, a big comment and achievement for him. He needs a round of applause for that. Today he will be sharing his insights on a very relevant and forward-looking topic. It is forward-looking to the extent, lot of things can be implemented using the AI technology, as we are all aware, which he has already done, and I'm sure there are so many things in his mind which, when he shares with all of us, that will really encourage us to implement at our respective setups. The topic is of Mr. Abbas is use of digitalization for various processes in TPP, that is thermal power plants.
Dear learned friends in the audience, all of us are well accustomed with regular mapping and recovery of various vital parameters of running boilers like pressure, temperature, fuel rate, maintenance logs, and maintenance history regularly at intervals of every microsecond. Digitalization and further processing of this collected voluminous vital information in organized and easily retrievable format allows us to go in for instant analysis and informed decision making and simplified compliance reporting as well. In short, it must be put forth herewith in clear-cut terms that well-organized data effectively and efficiently delivers real operational value and will be useful for perfect root cause analysis and effective corrective preventive action. During these changed times of flexible mode operation, it is totally unavoidable to use this very vital data. Sudden ramp in and sudden ramp out of load in this flexible mode operation will inevitably lead directly to failure of pressure part components earlier than expected, much earlier than expected. To avoid sudden unexpected failure, it is necessary to master root cause analysis techniques and to scrupulously adopt preventive and corrective action plans. It is here that the role of Sri Abbas Chanekar, the knowledgeable and experienced engineer, comes up. I invite the dynamic AGM of GMR Varora, Sri Abbas Chanekar sir, to interact with this enthusiastic audience in this decorated hall. Thank you.
Thank you for such a lovely introduction. So, this is the topic of my presentation, that is use of digitalization in various processes in thermal power plant. So, basically we will be discussing the initiatives which are taken in GWL itself. So, these are our plant details. GWL operates 2 into 300 megawatt coal-based thermal power plant. That is located in Warora MIDC, 90 kilometers from Nagpur, and the electricity generated is transmitted to PGCL Bhadravati, that is 35 kilometers from our plant location. Then our both units are supplied by Shanghai Electric Corporation, ACC, and our first unit got COD on 19th March 2013. And second on 1st September 2013. Then in our journey of digitalization initiatives at GWL plant, our focus was on 4 areas, that is process excellence, energy and environment, health and safety, governance and innovation. So there are many initiatives which we have taken. Few prominent initiatives we will discuss here. So first is the digitalization of logbooks. We have digitalized all our process logbooks for main plant operation, CHP, AHP, ash handling, and balance of plant also. So we have done this in 2 phases. First, we have digitalized the logbook for main plant control room, then replicated that to other areas. Then in the second phase, we have digitalized the field logbooks also. So through digitalization, this has reduced the time for data entry and data retrieval. Also, the hierarchy is maintained as review facility is available in this software. Plus, we can search for the data anytime from the search tab. So this is the process flow for the logbook. First, we have to open the software. Then the user will log in using his credential. Then select the logbook. And then data entry is to be done by the operator. And if any deviation in parameter is there, then it will be highlighted. And once the review of logbook is complete, then it will be mailed to the concerned person and all the HODs. So this is the comparison after the project implementation. In the right side, we can see the logbook in the digital format. Then for digitalization of field logbook, we have selected this QR-based solution. So what we have done that we have pasted this QR code at each equipment. So whenever our field engineer is taking the field round, he will just go at the equipment, scan the QR code, and the data entry can be done. So for that, we have selected this handheld mobile device. So in that handheld mobile device itself, he can do the data entry. This is the process flow. This kind of QR code we have pasted at site. Then the field engineer will scan that QR code. While during his field round, he will scan that QR code and do the data entry. Once the data entry is completed, then he will sync the device using our local GMR Wi-Fi network. So once the data is uploaded, then this logbook can be viewed in control room itself on our unit controller shift in charge computer. So then the reviewer will do the review, and once the review is completed, then this logbook will be circulated to the all HODs and concerned person. This is the handheld device which we are using for filling all our logbooks. Sample QR code and the sample logbook in digital format. Then coming to next initiative, we have digitalized all our operational and maintenance checklist. As we know that to streamline the different process of the power plant, so we all are using different checklists like startup checklist, then shutdown checklist, interlock protection protocols, then equipment isolation and normalization checklist. Then while doing the PM of the equipment, maintenance person also uses PM checklist. So all these checklist we have digitalized into a single portal where all the departments can refer historic data also. This is the dashboard of the portal which we have created. Then for data entry at site, we have given tablets to our field engineer. So while doing the PM itself, the engineer can refer the tablet checklist on the tablet itself and fill that. Then also we have integrated this software with SAP. So due to SAP integration, whenever some PM is scheduled in SAP, so the checklist related to that PM will also get triggered to the maintenance engineer, and he will be filling this checklist on the tab while doing the PM itself. Then after submission of the checklist will be circulated to all HODs for review. This is the sample of the portal, and this is the sample checklist received on the mail. Then coming to next initiative, that is employee tracking system. So the workman working at lone or isolated areas like CHP, AHP, so it was very difficult to monitor or supervise them. So to cater that challenge, we have implemented this RFID based employee tracking systems. So due to this, we can see that how many employees are working at a site. So this is the system which we have implemented. In the first picture, we can see that in CHP area, how many employees are working. Then in the second picture, we can see the details that Mr. Ajay, he is working right now at JNT2. Then in the third picture, we can see that near CHP control room, how many employees are working right now. And in the fourth picture here, we can see timestamp for the Mr. Hanuman, that at what time he was available at which location. Can you play the video? This is the portal which I was talking about. So here we can see that how many employees are working at a single location. This is the details of employee. Then this is the time stamping for the employee. So due to this increase in surveillance, it has enhanced security. Then next initiative is CCTV analytics. So at GWL, we have installed CCTV at all locations, and its display is available at main plant. The strategic locations, important locations like fuel oil pump house, GT yard, switch yard, all can be monitored from control room itself. And same type of system we have installed in all AHP, CHP, and for security also. So complete plant is covered with CCTV. Now we have installed this AI-based software. So through this AI-based software, different kind of violations like safety PPE violation can be detected. Then vehicle speed limit violation, intrusion detection, environmental violation, crowd detection, all these can be detected by this AI software, and also one alert will be generated whenever any deviation is detected by the software. So here we can see that in first, the person working in the mill area is not wearing the reflecting jacket. Then in the second, the person working in warehouse is not wearing the helmet. In the third, the pillion driver has not wear the helmet. Then vehicle speed limit violation. Then intrusion detection. Not following the safety rules. This is environmental violation, that the coal trucks entering the plant should have tarpaulin covering on it. Then crowd detection. So all these alerts are generated on real-time basis, and according to violation, corrective actions had been taken by the user. Now coming to next initiative, Sarthi portal. So this is one of the most prominent portal nurtured by GWL to achieve its motto of zero harm. So GWL's motto is zero harm to equipment, zero harm to people working, and zero harm to our environment. So this is the one portal which is taking care of all operational efficiency, then all field performance improvement, then maintaining regulatory compliance and reporting. So there are total 26 modules and further sub-modules available in this Sarthi portal. And this one portal ensures the compliance of all the things. So from the Sarthi portal, we can directly schedule the different meeting, then 5S walkthroughs, then action tracking items can be scheduled through Sarthi portal itself. Then to maintain the regulatory compliance, our internal audit are been conducting through this portal only. External audit we are also conducting through this portal only. So this is the dashboard for the Sarthi portal. Here we can see that how many action items are in open condition. Then action item statistics are also available there. Function-wise items which has to be addressed by which function, that also we can see from this module itself. Then module-wise pending action item also we can see. So this portal takes care of all our EHS requirement. So this is very consolidated portal. It will take more time to explain this. Then also document management facilities available in this Sarthi portal. So all our operational manual, maintenance manual, checklist have been loaded in this portal itself. Here we can see in document repository, the boiler welding schedule document is available. So while doing work on the boiler itself, the engineer can refer this welding schedule from a click of a button itself. So in this we can see that for which type of tube, which type of welding electrode has to be used, what is the welding procedure, how to, what kind of testing methodology is to be used after the welding. So all these detail can be seen from mobile itself. This is another, these are the snapshot to give the gist of the portal which we have developed. 5S assessment also can be done from this portal itself. Then complete statistic of all the action item which has to be taken can be seen from one place itself. Now next initiative is DSM monitoring system. So this portal we have developed in-house. So to take the advantage of this deviation settlement mechanism, we have created this portal in-house. In that we can see that what is the schedule in real-time basis and what is the amount of power which we are generating right now. Then different calculations which are required to take advantage from DSM mechanism that we have integrated in this software itself. So here we can see that the generation schedule is 549.72 and the export right now is 555.86. And the amount of coal cost saving, then DSM earning, and all the things can be seen in real time from this portal itself. Then shift-wise and day-wise report is also auto-generated through mail. Then digitalization of our water consumption. So all our means water being a critical resource, so is monitoring and optimization is one of our key KPI. So for monitoring consumption of water, we have installed flow meters at all the locations. And this flow meter signal we have integrated in this portal. So from one place we can see that which area is consuming more amount of water and what is the problem. And if any deviation is there in any area for water consumption, then that auto alert is generated, and against that alert action has to be taken by user department. So this we are monitoring from control room itself. Then we have digitalized our energy management system also. So all our auxiliaries who are consuming more than 75 kilowatt of power, we have installed energy meter in it. Then we have identified significant energy consuming equipments and derived energy performance indicators, then identified variables for that. This all which we were doing manually, now we have digitalized that energy management system. So on real-time basis, we can see that which auxiliary is consuming what power, and we can optimize that in real time. So this is the snapshot of the ENPS consuming by CHP department in the real time. Then in the bottom picture, we can see that the ash handling plant, which auxiliary is consuming how much power. So if any deviation is there in the ENPI for more than 72 hours, then the auto alert will be generated and the user has to submit the CAPA to close that alert. So this ensures that our APC is running at optimum level. Then for digitalization, for equipment reliability improvement, we have implemented this AI-based monitoring system with machine learning algorithms. So as we all know that in DCS is basically alarm-based system. So if any equipment parameter is deviating, so if it is above at alarm value, so an alarm will be generated in the control room. But this system which we have implemented is an alert-based system. So it will monitor the nature of equipment. And if there is change in parameter of the equipment, so then alert will be generated. And also since the machine learning algorithms are in this software, so it will suggest us that what actions need to be taken against the alert generated. So here is the example of forced draft fan. So we can see that the FD fan 2B non-drive temperature was running in the range of 40 to 45 degrees Celsius. Now the alarm value for this bearing temperature is 85 degrees Celsius and trip value is 95 degrees Celsius. But here we can see that the behavior of equipment is changed. Now the temperature has changed to 60 degrees Celsius. So this AI system will generate alert at this place only. So at 60 degrees Celsius, the alert was generated, and then we have checked the fan by ultrasonic meter, and done the greasing in the fan bearing, and then this temperature normalized. So this system gives you the extra edge, and it avoids the surprises which we see at site itself. So in the dashboard, we can see the alerts which are generated. So it predicts potential equipment failure, then reduce equipment downtime, increase plant availability, and improve overall performance of the plant. Then advanced analysis system is available in this software itself. Here we can see the signal versus signal comparison scatter plot. Then here is signal versus time. Then all equipment performance dashboard is also available in this system itself. So if there is any problem in the equipment, the maintenance engineer can directly log in into this portal, and he can do the analysis and see that what kind of corrective action need to be taken to address that defect. So this kind of analysis we can do from our home itself also, because all this data is available on portal. This is the snapshot of the type of alerts which are generated, and in the side we can see that the action is recommended by the these are the action recommended by the software. Then since this is a machine learning software, so the engineer can update whatever action he is taking, he can update the in this software itself. So next time if similar kind of situation comes, so same kind of action will be suggested by the software itself. Such kind of machine learning algorithms are integrated in this software. Then coming to next initiative, that is digital portal for calibration and tagging. So as we know that there are more than 10,000 instruments in a thermal power plant, and maintaining their record, calibration records, is a cumbersome process. So earlier, this kind of sticker were pasted at the instruments, which were having date of calibration and details of the equipment. So what we have done, that we have pasted this kind of QR codes on the instruments and created one online portal. So whenever a site engineer is at site itself, he can scan the QR code and sorry, and refer the calibration certificate itself. Then this portal was developed in-house. So auto reminder will be triggered for the instruments which are pending for calibration. Then all information regarding the calibration of the instruments are available at one place itself. Then GMR's vision of institution building. So various training programs are arranged for employees. So this has resulted in reliable talent pool within our group. So we have created this knowledge management portal named as Jigyasa. So in this portal, all the presentation which are presented in the our GMR group, then has been put in this portal itself. Then master class can be arranged from this portal itself. Then there are pool of mentors on this portal who can answer your queries on real-time basis. So this is the example snapshot of the portal. all presentations can be within the group can be seen from the one platform itself. Then we give recognition for most active members. Also, this portal is AI based, so it will answer all your queries on the portal itself. Once the question is put on this portal, so the system will auto-generate the answer, or some pool member can give the answer also. Then we have installed this phase touchless entry system for our associate employees. So here we can see that the associate details has to be loaded on this portal, and once it is approved by the HOD, so next time whenever the associate will come at site, so he had to just scan his face in the this face recognition system, and if its details are matched with the database, then the gate will open and the associate can enter in the plant. And this in and out record is kept in the database, which can be referred anytime. Then coming to last initiative, that is GWL is having a separate employee well-being committee. So under this committee, different initiatives are taken for well-being of employees. One of initiative is monthly health checkup, where employees' health parameters like blood pressure, BMI, weight are measured. So all this information is saved in one portal, that is employee health card, and from this portal we can monitor the health of employees, and if there is improvement in health of employee, then we give recognition for them. Then awards which are received by GWL. So GWL has received this Pradarshak rating from National Productive Council, that is above 99% score. So I can proudly say that we are the first power plant to receive this Pradarshak rating for 5S from NPC. Then we have received this National Energy Conservation Award from the hands of President 3 times. Then we are BSE 5-star rated company. Then we have received this National Energy Leader Award for Excellence in Energy Management for 9 consecutive years. Then first power plant to receive gold rating in CII Blue rating system. Then last year we have received this Best Boiler Award 2024 from Director of Boilers. This is the present area view of our plant. Thank you.
On behalf of the organizers and the learned audience, I herewith express my in-depth gratitude towards Abhas Chanekar sir. He has recently told us that his plant has received National Productivity Council Award, that is the highest award. We will like to congratulate him for this achievement. Shri Abhas Chanekar sir has clearly outlined key digital initiatives implemented in 300 megawatt TP thermal power plant to enhance operational efficiency, safer maintenance and environmental compliances. BWU WeldConnect feels delighted to thank him for his expressive, detail-oriented presentation. I herewith request Sri Chandekar sir to arrange a nice warm felicitation for his lecture.
Thank you very much, Mr. Abbas. It was a really nice presentation. It has thrown open a lot of avenues. I mean, you have shown how digitalization can be effectively used at every stage almost of the whole TPP. And so many awards to your credit. I am sure you are the one who are responsible for all these awards. As a token of our appreciation, I would like Bhavana Rajgopalan to come and felicitate you with a memento and a sapling.
I herewith request Anjali Patwardhan Madam to introduce the next speaker.
Good afternoon, everyone. It is with great pleasure to introduce our next esteemed speaker, who frankly doesn't need an introduction, Mr. Pramod Kate, a highly respected boiler technical consultant with over 45 years of experience in the field of thermal power and boiler systems. Mr. Kate is the technical consultant at Venkatesha Engineers and Consultants, Nagpur, and a proud alumnus of Visvesvaraya National Institute of Technology, that is VNIT, where he earned his degree in mechanical engineering.
It is my duty to detail you about the subject that Pramod Kate will deliver here. From subcritical to advanced ultra-supercritical technology advancement, newer and newer material having enhanced stability at higher and higher temperatures and having resistance to creep, fatigue, oxidation and corrosion are required. Therefore, material characterization is very, very important. Boiler World Update WeldConnect conference invites the most experienced and knowledge-rich person to illustrate about the advanced ultra-critical boilers and state-of-the-art welding procedure specifications. I am sure the eager audience in this audacious gathering will enrich themselves with this lecture.
His consultancy expertise includes root cause failure analysis, performance optimization, condition assessment, and preventive maintenance planning for thermal power plant systems. Mr. Kate is also widely recognized for his engaging and insightful lectures covering crucial topics such as boiler failure analysis and accident case studies, combustion and efficiency optimization, best maintenance practices, and HP welding techniques, supercritical boiler systems, and advancement in boiler pressure methodology. We are privileged to have him here with us today to share his knowledge and deep insights into the ever-evolving world of material characterization of supercritical, ultra-supercritical, advanced ultra-supercritical boilers and welding procedure specification for the same. Please welcome on stage Mr. Pramod Kate.
Yeah. Hello, very, very good afternoon to all of you. Honorable dignitaries, respectable higher managerial officers, my plant heads, station heads, power engineers, and the knowledge-enriched audience. So here, we will be discussing the material characterization of the subcritical, supercritical, ultra-supercritical, and advanced supercritical boilers. So as it is related with the material and material properties, and as this is the last lecture, so the two words, that fatigue and endurance limit, I think audience has reached to that. But still, we will come up with some little bit more energy, and we will start this lecture. Here, when we go for the subcritical to the ultra-supercritical to the supercritical and advanced ultra-supercritical boiler, what it exactly happens? When we consider subcritical boiler, it is operating at 167 kg pressure, 540 degree centigrade temperature, and it is having a gross plant efficiency of 38%. Come to the supercritical, pressure is 247 kg per centimeter square. The temperature, it is 563. And the gross plant efficiency is 40%. When we come to the ultra supercritical boiler, its pressure is 287 kg and the temperature is 600 with the gross plant efficiency 42%. And when we go to the advanced ultra supercritical boilers, its pressure is 350 kg per centimeter square and the temperature is 700 degrees centigrade, having the gross plant efficiency 49%. Means you just see, from the improvement from 38% to 49%, that is 11%, we are having a transition from subcritical to advanced ultra supercritical. That means the increase in the efficiency, improvement in the efficiency is possible only when the steam temperature and the steam pressures, they are high. That means improvement is possible only, and that how that can be achieved? With the affordable upgradation of the metallurgy of the materials. Means what is to be done? We have to go for stability of this material, newer and newer material at higher and higher temperatures. So here we are only discussing how the metallurgy has changed and how it has come from 1/4 chrome half moly to 50% nickel and high chromium nickel alloys. So that is what the main discussion. So here whatever some difficult terms are coming, we will make it to very simplify it so that we should understand. Here, this is about the 11% improvement, and this is there only when we should have, it is governed by the metallurgy of the material. That is what we have discussed. So this material which we are searching on, we are developing, that should have higher resistance to the creep, higher resistance to the fatigue, higher resistance to the oxidation, higher resistance to the scaling, and higher resistance to the microstructural degradation. Microstructure should not be degraded. This is what the particular specific qualities of the material whenever we are going for development of this material from subcritical to the advanced ultra supercritical. So again it should have low coefficient of thermal expansion and it should have high thermal conductivity. So these are only the properties which will be required. So this is, and there should be ease of fabrication, that is at affordable cost. That means our journey is from carbon steel, low alloy steel, high alloy steel, stainless steels, and the new things are super alloys and the dispersion strengthening. Now I will tell you what is that super alloy in very short sentence. This is nickel and chrome alloy. Nickel and chrome alloy means the nickel is of 50%, chrome is of 25%. That means our journey, which has started from 1.25% chrome, has ended with 25% chrome and 50% nickel. Now what is this dispersion? So let us make this is also clear. So this is oxide dispersion strengthening. Strengthening is to be achieved, but oxide dispersion, which is that oxide? What is that dispersion? So I have told you, it is 50% nickel. And in this case, nickel matrix whatever nickel is there, that nickel matrix, it is surrounded by fine and uniform submicron and the nanoparticles of vanadium trioxide. So whatever, if you are going for the advanced supercritical boiler, the material is ODS. That is oxide dispersion strengthening. Oxide is what? Vanadium trioxide oxide. And dispersion, that means nickel matrix, is surrounded by the fine and uniform particle of this. And hot sintering, hot pressing is applied on the mechanically alloyed powders. That we call it as powder metallurgy. That means this type of the new material, it is being fabricated by, manufactured by this powder metallurgy technique. After that, what is the characterization of the boiler tube? Characterization of the boiler tube, that means we have to understand the chemical composition. We have to understand its microstructure. We have to understand the phases present. We have to understand the effects of heat. That is much more important. Only when temperature is increased, effect of heat on the microstructure, and we have to relate this, we have to overcome this, we have to resolve the problems, and these problems, they will come as soon as the chromium percentage will increase. And these problems are sensitization, chromium depletion, then sensitization, chromium depletion, sigma phase, and carbide precipitates. Now these words are little bit difficult, or we are not actually coming across these words in our regular day practice. Now, in very short 1 to 2 sentences, I will explain what is this. As the phases present means, I will tell you, austenite, ferrite, martensite, and bainite are the phases. Now what is that? If austenite is suddenly cooled, then it becomes martensite. If austenite is slowly cooled, then it becomes pearlite. And if austenite is moderately cooled, it becomes bainite. Now these phases has got its own shape and size. Like pearlite is a combination of ferrite and cementite. Cementite is nothing but Fe3C, that is carbide. Now carbide is playing very important role. So okay, and here what is the effect of temperature? If this is overheated, then this cementite spheroidizes. Means that rectangular shape is being converted into spherical shape, and that we can understand from the microstructure. So this is what effect of the heat on that microstructure. So now we will be going across one by one. Now you just see 18.8, that chromium nickel steel, if it is heated, then the chromium carbide is formed. Chromium, it reacts with carbon, chromium carbide is formed, and the process of formation of this chromium carbide, it is known as sensitization. Okay? The process of chromium carbide, it is sensitization. Now, chromium carbide is formed. That means chromium is mixing with carbon. That means no chromium is available at the grain boundaries. It is mixed with carbon. Are you getting it? So no chromium is available at the grain boundaries. So we call it as a chromium depletion. Sensitization okay, chromium depletion okay. Whenever there is no chromium at the adjacent of the grain boundaries, then that becomes cathodic. And when it is cathodic, it is preferentially attacked by the corrosive media. And this type of corrosion is called intragranular corrosion. Okay, so these are the terms. Now, how to avoid this chromium carbide? Simple. You reduce down the percentage of carbon so that no carbon is available to combine with chromium, and this sensitization will not occur. So, reduction, you just reduce down the carbon content, and your 304, 316, these are designed with this idea that carbon percentage is reduced out so that there is no sensitization, no chromium carbide is present. And another way is what? You add some elements so that their carbides are formed and chromium is free. You got it? So these are the two methods. One is to use the low carbon material, or other some alloying elements, so as the carbide of those elements are formed, and therefore here chromium will not be depleted. So this is the basic theory. Now, okay. So these are the strong carbide formers. Therefore, they preferably react with the carbon to form the carbides, leaving no carbon to react. So what is to be done now? These alloying elements added means what? Which element to be added? Now all this you know that this chromium, molybdenum, nickel, they are present. Here the elements added are tungsten, titanium, tantalum, vanadium, boron, tungsten, vanadium. This has got its own peculiar properties, because at the same time we have to see that there should not be the morphology of the defects. So these defects should be removed out. Then second is now we have talked about that chromium and carbon. Now what is about Fe and Cr? Chromium carbide is okay. But there is some iron is also present. So that Fe and Cr, this is known as sigma phase. This is the intermittent phase. Carbon we have utilized with chromium, one phase. Fe now we have to utilize FeCr. This is intermediate phase. So if Fe and Cr percentage is not balanced out, this intermittent phase is formed. This is the sigma phase, which is very dangerous. Once the sigma phase is formed, then the material is imbrittle. So we have to take that the sigma phase should not form while developing up of the material. Then so again these words are coming, ferritic and austenitic and distic. So let me make it very clear. These words will be always confusing, and so that the remaining discussions will be boring. So that what is that? 18 chromium, 8 nickel is your austenitic steel. Okay? If your chromium percentage is less, from 9 chromium to 18, chromium percentage is less, then it becomes ferritic steel. And if your chromium percentage is still lesser, and carbon percentage is increased, this is your martensitic steel. So now this ferritic, martensitic, austenitic, so these difficulties should be removed. It is only dependent upon the chromium percentage. And I will tell you the austenitic steel, how to remember in one line, that AISI, 2XX, 3XX, these series are austenitic steel. That means so many materials we are using in the power industries, 213TP, 347H, 213T22, 213T11, 304, 347H, these are our austenitic steel. And whenever AIXI 4X series is there, those are ferritic steels. Whenever it comes to 5, those are martensitic steel. With this idea, now we'll provide, whenever that ferritic steel, means the chromium percentage less than 80, when they are heated up to 540 to 750, when they are being overheated, at that time, this sigma phase is formed. And for austenitic steel, where the chromium percent is more than 18, and if they are heated up to 750 to 900, then that sigma phase will form. So we will have to take that presence of the sigma phase while carrying out development of the material. Then these are, in short, what is to be added and what is the effect. Carbon is non-alloying element, but if its percentage is increases, then ductility, toughness, this all will be decreased. Manganese, machinability improves. Silicon, resistance to scaling, then silicon, and increases machinability, that is sulfur. Phosphorus, its machinability increases. Chromium, why chromium? Because it is improves the hardness, improves the yield strength, improves the tensile strength, improves the resistance to the corrosion, oxidation, and improves the resistance to the creep and fatigue. So that's why chromium is preferred. And then nickel is to improve oxidation and corrosion. Molybdenum, it increases the strength of the material. Tungsten, it is actually enhancing the creep resistance. Tungsten, titanium, niobium, and tantalum, they are very crucial elements. They are for these purposes. Vanadium, it increases resistance to creep. And titanium, it resolves the problem of chromium depletion and carbon precipitation. Chromium depletion and carbon precipitation. Because morphology means these are the defects they will come, and we should manufacture so that these defects should not come in the material. Copper increases the strength. Aluminium, it is the grain refiner. Very uniform, even grain structures will be achieved with the aluminium. And boron, that improves the hardenability. Now, how this material, the chromium carbide is very dangerous, but chromium oxide, chromium forms in front with the oxygen and moisture in the environment, chromium forms a thin, transparent, adherent, and passive film. So that film is there, and it is a protecting layer. That means oxidation is totally prevented. So this is called a preventive, this type of film. But what is this happen? This corrosion rate, if you plot corrosion rate on y-axis and the chromium percentage on x-axis, then the curve is exponential. That means as the chromium percentage increases, the rate, corrosion rate will decrease. So now this will give good result only when the chromium is 11% and for 18%. So this is what the in proportion in which this chromium is added. For a continuous passive film to form, 11% chromium content is required. Now, whenever new materials are coming, how we have moved, how we have transited from supercritical, from this subcritical to the advanced supercritical. The carbon steels, they are having low oxidation resistance, low resistance to the fatigue creep, so that we have come across the low alloy steels by adding molybdenum so as to increase the hardness. And then the layers which I am talking about is the chromium oxide layer. In case of the ferritic steel, martensitic steel, where chromium is present, this layer is called iron chromium spines. The iron chromium spines are there. That is FeCr2O4. And whenever this, in case of austenitic steel, when the chromium percentage is more, this layer is called chromia. That is Cr2O3. This layer is very protective, and we have to take into consideration that how this layer should come with proper percentage of chromium and nickel. So now, here that we have come across T1, T11, T22, we have come across. With this T23 and T4, what they have added? They have added tungsten and boron. And another they have added the vanadium, niobium and titanium. This is to resolve the problem of intragranular corrosion. So then we go to the T23 and then we have come across T24. Then here more recently 3 chrome, that means 3% chrome, 3 tungsten, this is and vanadium, it is more strengther than T23 and T24. So now if we go across, you know that the Pradeep Joshi sir has explained PT91, that is 9 chrome, 1% moly. So 1% moly, and if you add some percentage of vanadium, so it can take the maximum temperature of 650 degrees centigrade. That means the stability at higher and higher temperatures and of newer and newer materials are to be discovered. Now, what is that? Why it is getting strengthened? Why the material is getting strengthened? In simple, there is solution mode, participation mode, and oxide strengthening mode. What is that solution mode? That is, chromium will form a solid solution with Fe, and therefore the material will be strengthened. That we call it as a solution mode. Now chromium carbide is formed, so that carbides, metal carbides are formed. Carbides precipitate out. So whenever they are precipitating out, they are occupying the interstitial spaces between the molecules, and therefore the dislocations, those are getting pinned. So here, so here you come across. So this is and in case of oxide strengthening, that I have told you, the vanadium trioxide with the powder metallurgy technique, the dispersion of nickel matrix is getting dispersed with the fine particles of V2O5, and this is by powder metallurgy. So in short, we have to make the material strengthen by either solid solution, by precipitation strengthening, and by oxide dispersion strengthening. And with this, we have to go for nickel and chromium percentage are to be increased. Just now, we have started with 1 quarter chrome, 2 quarter chrome, then 9 quarter, 15 quarter chrome, 18 quarter chrome, and then it has reached to 25% chrome and 50% nickel. And this ODS material. So what are these materials? So I will tell you, Inconel 617, Inconel 671, then Inconel 718, Inconel 740, Incolloy 800H, CR30, HR6W, hence hence 230, and this mnemonic 25, mnemonic 267, these are the materials. So ASME SA 633 in our ASME code, that is called ISET 1250 and Tempoloi 80. After this, the material comes, that is what it is pinned. I have seen you, these dislocations are pinned, and therefore the dislocation movements are restricted and the material is getting strengthened. So here, the Sanicro 25, so these are the material. Inconel 617, 671, 740, 718, CR30, HR6W, hence 230, Sanicro 25, and Mnemonic 263. Now what are these materials? So just have a look of this material. These are the high chromium, high nickel, super base alloy used in ultra supercritical and advanced ultra supercritical unit. So this is your Inconel 617. You just point out the nickel is 51% and chromium is 22%. So that is Ni, Cr23, CO12 and cobalt is 12.5. So this is the DIN standard. Whenever we are referring DIN standard, this will definitely give you the alloys and the main constituents of the materials present over there. And this is ASME code is SB666. Now up to this ASME code SA206, that is what we have referred. Here this code becomes SB666 and the welding electrode for this rod is ER NI CR CO MO1. This is the welding electrode and the welding specification, that is AWS A5.14 and ASMT section number 9. It is to be referred for all welding procedure specification. So this is one material. You just see the nickel and chromium percent. Then this is 671. Nickel is 51.5% and the chromium is 48%. So this is the material. Then Inconel 740. Here you just see the balanced material is nickel, chromium is 25 and all others you take it as suppose 10%, then this percentage will be more than 50. So this is nickel based, having oxide dispersion strengthening, it is there whenever nickel is there. And this is again, this is the welding electrode and this is the specification AWS this thing. Then Inconel 718, here chromium 18, molybdenum 3, niobium 5%, carbon is 0.04 and balance is nickel. You just see how the stress is given on the nickel. Then the next material is HR6W. Here nickel percentage is 43 and chromium percentage is 23. Its DIN standard is 12 Cr MO5. MO5 means that molybdenum level comes to 5. Then hence 230, here is ASME, equivalent name is not SA, SB536 and the nickel percentage is balance percentage, chromium is 22% over there. Again AWS, American Welding Society, a 5.14 procedure is to be adopted for how much current is to be kept, how much should be the travel speed, what should be the voltage and everything for utilization of this rod. Then पुढे होत नाही. क्या हो गया विधि? उधर से अभी हो गया. Some last 4 to 5 slides. This is Inconel 800H, nickel is 32%, chromium is 21% and niobium 0.3. Again aluminium is there because that grain, it is a grain refiner, grain shape and size is required to be maintained. The welding electrode, that also I have specified. Here Cr30A, chromium 30 and nickel 50. So these are the super alloys having higher nickel and higher chromium, but the micro addition, these micro alloys are to be added so as to take care of precipitation, sigma phase and chromium depletion and all that. So that is what the metallurgy, advanced metallurgy is required to be maintained. Then CCA 617, here nickel is 55 and chromium is 22. This type of specification, it is already written in AWS A5.14, and these are the welding electrodes for this. ASME standard is not SA, it is SB366. So this is another the new material. And this, now I have told you, the oxide dispersion strengthening, whenever ODS that will come, definitely it should have vanadium trioxide. I have told you here vanadium trioxide is 0.24 to 0.25. That means this vanadium trioxide, dispersion of this in the sub-microns or the nanomicron size of the size 20 to 30 angstrom. That means 0.000003 mm. So such a thing, dispersion method by powder technology, this is ODS material. It is used in the advanced ultra supercritical boiler, and this material is ASME standard is SA213 grade T122. 213 T122 is the grade, where nickel percentage, you just see the nickel balance percentage is nickel, because nickel matrix, it is governed by this type of small particles of vanadium trioxide. And the second ODS, this one, this is one, second I have shown you. So in this case, a vast majority of alloys are available for boiler applications, and more specific for tubes, pipes and headers, and therefore the metallurgy and intended service condition of an application must be considered before any specific use. So here the idea, objective of this lecture is to tell you about the characterization of the material. Now this is very vast subject. How you can measure the microstructure? What are the methods available? So here we should go for advanced NDT techniques. Those techniques are the microscopy. We should go for scanned electron microscopy, transition electron microscopy, focused ion microscopy, optical microscopy. That means that stream is to be passed so as to study the microstructure. Then we will come across the spectroscopy. Here this material, whenever the research is going on, we have to go for spectroscopy. Here the energy dispersive spectroscopy, it is to be used. Wavelength dispersive spectroscopy, it is to be used. Then X-ray fluorescence spectroscopy is to be used, and X-ray photoelectron spectroscopy is to be used. This is the second one. And the third one is the diffraction method. That is X-ray diffraction, neuron diffraction, and the electron diffraction. That means beam is passed. What is the best advantage? I think the people from NDT, they know. Here we can, if a piece is given and X-ray diffraction is carried out, then we can measure at what extent the temperature of this tube has gone during its useful life. Whatever the maximum temperature it has reached, and depending upon that, the microstructural degradation, microstructural changes, they are to be counter-checked and confirmed. Okay? So, thank you. Okay.
Dear friends, professional, distinguished and resilient engineer Pramod Kate sir has articulated how the metallurgy and invented service conditions must be considered in appropriate selection of specific grade and development of material from carbon steel to higher alloy steel to overcome problems like creep, fatigue and oxidation, as good as swelling and microstructural degradation. On behalf of enthusiastic technocrats in this well-decorated hall and the organizers, I request Anjali Madam to arrange a candid felicitation for this high-grade technocrat Sri Pramod Kate sir.
Thank you so much, Mr. Kate, for your enlightening and thought-provoking session. Your decades of hands-on experience, coupled with your clarity of explanation, have truly added immense value to today's gathering. As a token of our heartfelt appreciation, We would now like to felicitate you with a memento and a sapling, a small gesture symbolizing respect, growth, and our shared vision for a sustainable future. I now request Sri Sachin Chaudhary to kindly do the honors.
Thank you. Thank you. Thank you, sir. Thank you all.
Once again, thank you, Kate sir, for gracing BWU WeldConnect 2025 and enriching us with your knowledge. Thank you.
Now is the time for the most awaited panel discussion on challenges before the power stations in view of flexibilization. I invite entire persons in the audience to occupy the chairs which are vacant in the front portion of the hall. All are requested to come forward and occupy the chairs so that the discussion should be warm and endearing. All the speakers, all the eminent speakers will be invited on the dais. We are arranging the chairs for the eminent panelists. Therefore, please wait for a few minutes for change in the dais. All are requested to come forward and occupy the chairs in the front rows. Please, all all the persons in the back rows are invited to occupy the chairs in the front rows so that the gathering should be, the panel discussion should be endearing and cordial. This session, that is the challenges before the power stations in views of flexibilization, is the most important session in this today's seminar on flexibilization, because there are some salient features which are going to be discussed in this panel discussion. First is managing peak demand. Increased use of electrical vehicles will definitely change the peak load, peak demand slots. Therefore, the management of peak demand will be a most important challenge in this change scenario. The second most important point is cost implications. Flexibilization, that is the sudden ramp in and sudden ramp out, will require capital expenditure for upgrades and modification. The third most important point is technical challenges of flexibilization. Because of the sudden ramp in and ramp out of the load, base load, upgrade is most important, and this upgrade will require capital cost expenditure. Further, operator training will be needed to a great extent to stabilize the combustion. Fourth important point is flexibilization of existing coal-fired boilers. We will have to upgrade the material of these boilers as well. The most important point is that is the current base load operation. We will have to shift from current base load operation to the new scenario where flexibilization will be the order of the day and sudden ramp in and ramp out will be required. This will require different set of skills for the operator in charge of the power station. Last important point is the grid stability and intermittency, because we will use ingress of unconventional energy sources, that is solar as well as wind power will have to be accommodated in the grid, and these both the powers, that is unconventional energy sources, are intermittent. Therefore, power generation will need, that is the thermal power generation will have to be modified in accordance with the ingress of unconventional energy. Therefore, grid stability will be the major challenge in this change scenario. Now almost the stage is ready for panelists. I will again appeal to all in the audience to occupy the front chairs so that the panel discussion should be cordial, endearing and interactive. The speciality of this session is that this session is going to be interactive, is designed to be interactive, and it will be a dialogue, not a monologue. In monologue, a person only speaks. Now is the time to introduce with the chief moderator of the today's function, Sanjay Joshi sir. It gives me a great pleasure to welcome you to the panel discussion at BWU WeldConnect 2025. This session brings together some of the most accomplished minds from the power and energy sector to deliberate on the evolving landscape of operations, technology and innovation in thermal power station and related industries. I invite Sri Sanjay Joshi sir to be on the dais as the chief moderator of a panel discussion. It is now my privilege to introduce the moderator of today's panel discussion, Sri Sanjay Joshi sir, who has contributed significantly to the implementation of both conventional and renewable energy projects from concept to commissioning. Sri Sanjay Joshi sir is a seasoned professional with over 33 years of diverse experience across the public, private and social sector as well. Out of this, 25 years have been dedicated to the power industry. He has started his illustrious career in Maharashtra State Power Generation Company and later spent more than a decade with IL&FS, that is Infrastructure Leasing and Financial Services. His leadership has extended beyond energy operations to social development as well, where he has played a pivotal role in scaling IL&FS and CSR programs to benefit over 4 lakh individuals across 13 states. Let us give a grand applause for his social work as well. He has focused on farmer welfare and women empowerment as well. Since 2018, Shri Joshi has served as a co-founder and director of Krushak Mitra Agro Services Private Limited, a startup recognized by Government of Maharashtra for its impact on agricultural sector. Shri Joshi is a qualified production engineer, a postgraduate in management and certified energy auditor all at a time. He is a fine blend, a beautiful and fine blend of technical, managerial and visionary experience. I am proud to present him as the moderator of today's panel discussion. Dhanyavad. Thank you.
It gives me great pleasure to welcome you to the panel discussion at BWU WeldConnect 2025. This session brings together some of the most accomplished minds from the power and energy sector to deliberate on the evolving landscape of operations, technology, and innovation in thermal power and related industries. Along with Mr. Sanjay Joshi on stage, I'm very happy to have you on board as the moderator for the session. I would also like to invite our esteemed panelists to join Mr. Joshi. Shri Anjan Kumar Sinha, Technical Director, Intertech AIM USA. He was also one of the speakers for today's morning session. Shri Pramod Kate, Consultant, Venkatesha Engineers and Consultants. Kate, sir. Shri Pradeep Mohapatra, Head O&M Adani Power Limited, Tirora. Shri Ibrahim Sheikh, Head Operations, GMR Varora Energy Limited. Shri Amit Bankar, Deputy Chief Engineer, CSTPS, Chandrapur. We now look forward to an engaging exchange of ideas and valuable insights. We shall soon start.
Good afternoon, gentlemen. I have very august panelists, to discuss today's last session, and everybody is waiting for, the most important. So we are hearing all the thermal power plant fraternities since few months or maybe a year, continuously listening this word of flexibilization, minimum technical load, technical minimum load. So many committees have been formed, and Government of India is, driving it, the Ministry of Power, Central Electricity Authority. But let me just, set the context for this discussion. So why this, so my analysis is why this problem has suddenly occurred. Because I think there was a spree of, all the coal-based power plant in 11th plan, 12th plan, between 2007 to I think 2015, 16, when the renewable energy was very expensive. And there was a business case to set up the coal-based power plants because of the gap in the demand supply. There was a tremendous power deficit. And all the developers, IPPs, the Act gave them a freedom. There was a set up of regulatory commissions, and everyone came and set up the coal-based power plants. But to the wisdom of everybody's developer, they chose the capacities, they chose the locations, and to my mind, there was not a very concerted effort of planning what capacities to be created. So the overall plan was there, but which location, where, at what stage, and then suddenly the leap of technology arrived in the renewable energy, and the costs came down significantly in the solar, and then the same developers, many people find a business case for setting up renewable energy. There was a huge flush of money available. A lot of investors, private equity funds, they came, they were interested. There was a whole issue of climate change which we are discussing, and then in that process, Government of India also gave its commitment to make the net zero by 2030 or 2050, in the temperature. And so that also again, so many new renewable energy, large capacity setups came up. So really, again, that was also, I am not sure whether we took into account what kind of thermal power plant capacity was in the pipeline, what is installed, and whether really, this will throw up the new challenges for the thermal power sector. So I would, therefore I would like to make this discussion into 4 buckets. One, of course, the operational challenges, which everyone, many of them are facing. What are the regulatory challenges to this in terms of the cost compensation, change in the regulation, the commercial challenges, financial challenges, especially to the IPPs, which have set up their projects through competitive bidding framework, and they had envisaged certain cash flows, financial, the lenders evaluated. So all of these coal-based power plants have set up with a very long-term vision. So they had a 25-year PPA, they had a 25-year fuel supply agreements. The life cycle of the plant is 25-30 years, and suddenly in the middle of, after 3, 4, 5 years, you have been asked to, no, now you can't operate at a full load. So you have to reduce and make like a, balancing like a gas-based power plant. So that kind of, whether really we have the ability to do that sort of a flexibility. Then, of course, the other challenge is the environment. So are we really mitigating the environment, and what are the climate change? And the other aspect is from the consumer's point of view. So I will frame these questions in these 4-5 baskets. And so I will start with my alma mater, Mahajanko. So I'll ask Mr. Bankar, so what strategy, Mahajanko is one of the largest state utility in the country, in Maharashtra. So Maharashtra is, like we heard in the morning also, is one of the largest state with the highest demand in India. And obviously it's going to have, its own issues. So we are also, Maharashtra is also taking up different schemes, Mukhyamantri Solar Yojana, rooftop solar, segregation of agriculture feeders, so many of solar. So in this whole, development, what is the thought process of Mahajanko in making, or have you evolved any strategy already, which units, to be made as a flexibilization or flexible operation units?
Good evening, everyone. Thank you, sir. Being a government entity, obviously we have to honor what the government decides. And rightly said, what government had decided is that at the end of next 5 years, every household will get 300 units free electricity. They will have their own rooftops. So there comes a thermal power station. We have 7 stations, 28 units running. So these units, even in these rainy days, what happens is we are facing around 3,500 megawatts, as in 660 megawatts. Koradi also is facing, and the newest of our gem, BHL Bhusawa also is facing backing down when we have rainy season. So, or when we have very good, less demand and high production of solar. So, what we are finding in last 2 years, this scenario is continuing. Since we are at the government based, what we find is the kind of investments which we require for our plants are not huge in those terms. We are adequate, governed by MERC and government, whatever the regulations are there. We are in such a bouquet that our generation cost is a bit high. So backing down is continuous. And backing down is as per DSM nowadays, everybody knows that. And this DSM is causing a very steep rate of ramping down and ramping up. My manual 500 megawatt Chandrapur, 92 to 97 units, unit 567 Chandrapur, the newest of them all at that period of time. The manual says 3.14 megawatt per minute. That leads to 45 megawatts in 15 minutes, and we get a ramp down rate of 75 megawatts, a ramp up rate of 75 megawatts sometimes. So this is causing us to boost to it, to meet to it, and this in turn at the back end is causing stresses, I presume, in the boiler, because we are talking mostly about the boiler. We are trying at our end to run it at throttle mode, the turbines at the throttle mode. The best we can do is keep the pressures high so that that ramp rate and ramp down will be eased a bit, but still the rates which are ramping up, ramping down is not very adequate. This is very evident in the form that in the last 2 years we have found that the leakages in the water wall zone have increased. The leakages in the outer side of the furnace has increased. Means earlier we rarely saw these leakages outside the furnace, but in the recent history, 3 or 4 leakages are there on the outer side of the furnace. This, I presume, I may be corrected please, I presume is a basic cause is this sudden ramping up, ramping down, and that's why we are thinking of abiding to that OEM recommendation of 3.14 megawatt per minute. So that is one thing we are thinking. Rest, having solar and having flexibility into our boilers. For example, my unit, Perli Unit 8 is a model for that. Their BHL has given its offer. Work is in process. Out of the 32 burners, 16 burners are being reduced to that modified burners, and both the PFNs are getting better instrumentation for anti-stalling things. These two things means for a start, Mahajanko is looking into that. We'll see further after this unit at Perli how it can ramp up. It is a 250 megawatt unit only. We'll see how better it will cope up right after that.
So you are evolving out of your 28 units, which units you want to cater specifically. So there is a strategy, which is being laid down. So what units of NTPC, would be there, DVC. So they are setting up, in the different multiple phases, first phase, second phase, third phase, for a 55% operation, load. But really, that throws as the other major issue is, of course, the quality of the coal. Now, I am not sure whether you really know what quality of coal you are going to get in the next 2 days or 2 days after, what kind of quality WCL is giving. There may be, in some cases, there are mines which are specifically allotted, but still there is a lot of, do you find, a lot of divergence, obviously from a design coal and actual coal, what you are getting?
Of course.
And the uncertainty of what quality coal you are getting. So is that also throwing a, a different dimension or challenge in this flexible operation?
It is a very huge dimension in what you said. Sinha sir in the morning himself said that we can run in 3 mills if we have 4000 CV. but that rarely happens at Mahajanko. Mahajanko, suppose I'm talking of Purli, I have only 2 mines, maybe one WCL and one Singrain is there. But if we come down very close to us at Chandrapur, I may have as huge as 12 collieries which I'm getting coal from. These vary from 3,400 to some going down to 2,800 also. So this is a huge difference, and I really can't manage that. And this sudden change in coal quality, the same unit one day is running with a coal factor of wonderful coal factor of 0.68, and the next day I'll have to run it at 0.9. So this causes a huge pressure on the operators as in my operation staff also, and this leads to that jumbling in the mind of what happens next. Khaparkheda has done a very good job. Khaparkheda has its known resources, so they get their hourly source feeding, and they try to forecast what kind of the load they are going to get. But when I come to Chandrapur, I see that Singrain is giving me Asifabad. Asifabad is just 160 kilometers from Chandrapur, but 2 rakes I get 3,400, and 1 rake I suddenly get 2,900 to 3,000. So these issues are there quite, we face in our belt, WCL belt generally.
So, Mohapatra sir, do you also face these similar challenges of coal quality variation, and because of that the operational challenges, even on a day-to-day basis, leave aside, the flexibility, to be achieved?
Sure. Actually, at our locations, we get a variety. Like I worked at Raipur, there 2 units are there. We got it from GMR. These are Dusan units. There we get 15 types of coal, and the GCP varies from 2,500 to 4,200. So even same coal, one day we get 3,400, another day we get 2,800. So that is always a challenge. In fact, now I am working at Tirora. There is a wide variation, because we need quantity also. For running 660 megawatt units, we need more than 40,000 tons of coal per day. So definitely there is a coal shortage, and whatever maybe the quantity also we need. So we gather the quantity. In fact, we manage the quality in terms of blending, in terms of how much we can load the boiler. Like suppose we have limited the coal flow to 410 tons per hour maximum in peak hours. Then we'll slightly increase. Let us see how much we can accommodate. So these are few challenges. Also, what happens, one very good observations I would like to share with everybody. Nowadays, unit healthiness, like boiler healthiness, as sir was telling during his presentation, Anjan Sinha sir, coal pipe healthiness, burner healthiness, in fact, boiler healthiness, boiler cleanliness, refractory healthiness plays a major role while handling with varieties of coal. When you blend varieties of coal, maybe having clinkering tendency. So we have seen the boilers which are brand new in terms of less aging after overhauling, in compared to boilers which are just due for overhauling. Let's say they completed 16 months, 18 months, 20 months. They are handling these worst coals is very difficult during load ramp up and ramp down. Maybe clinkering issue, maybe high exit flue gas temperature, other issues are there, flame stability issues. So I would say while doing overhauling, we should make our strategy so that my boiler is as good as new for next 2 years, to adopt best material, best maintenance practices, so that it remains in the same condition till completion of 2 years. Thank you, sir.
So in this slide, Sinha sir, so you are part of the committee which formed by CRC, CA, So do we really need to, so I read, so we need about 75 gigawatts of capacity to be allocated as a, flexible operation, by 2030, given, so I think whether that was for 175 gigawatt of renewable addition or 500 gigawatt of renewable addition by 2030, I'm not sure that, 82 gigawatts. So, I mean, even today also we have a maximum demand of thermal as 175 gigawatt and minimum is 115 gigawatt. So, there is a huge variation between the maximum and minimum demand. So do we really need to, given the most important challenge for all of these is the coal quality variation. So do we really need to identify the units and then allocate a uniform quality coal for those units which are specifically identified for flexible operation, so that the operational challenges are reduced to a great extent? So is there any thought process going on from that angle?
Yeah, very good question. In fact, I'll tell you, way back in 2019, we did a work on which units we should flexibilize. And then we had divided the plants into different units into 4 categories, 4 to 5, means which can flexibilize and at a very economically viable. It should also be economically viable. Why to spend unnecessary money on those plants which can be run on other modes? And some units we know that they'll never need to be flexibilized, low cost, close to 1 rupee. So, but old plants, then based on heat rate, then coal availability, that also exercise we had done. You can find even on the net some of the material, even my old presentation. So we had categorized those units. But again, after that, there was coal, a lot of things happened. Once government had thought that, okay, we have surplus capacity, and government was thinking of retiring. Then when there was scarcity, 21st of October 2021, I remember that date, when the IEX price, it rocketed up, and government was alarmed. They had to just put a cap. That indicated a scarcity in the market. Energy market, here you don't allow it to run on its own. So that gave an indication. That signal, government got that signal very well. So next, actually, there was things like, okay, all the plants should run, no more retirement till 2030. And then we had even shortage of coal. So that plan was also there, coal allocation and all. We had did other exercises even when I was in NTPC. But it is really very difficult to dedicate those coal to a particular unit. But again, now there are other means also how you can manage these things. Blending it didn't work, because for blending you need a consistent amount of supply of coal from those mines. Even if you're importing, then also there is no consistency. And I think that question you asked, anything more? And I'd like to add to the other speakers. See, first of all, you need to know that flexible operation, it's not because only of RE. It's happening due to many other reasons. Means supply and demand gap has always been there. And, and again, seasonal variations, other variations. June, there is going to be a very huge shortage. And previously, even when there was scenario of scarcity, lot of shortfall, the grid used to manage by load shedding. Hardest way, most expensive way. So it was there, and now it has come up, so we have to do it. So one thing is, want it or not, you have to run your plants on flexible mode. That is a reality. Now all those challenges are there. Coal, yeah, I agree that it is one of the biggest challenges. And in fact, coal quality also promotes flexibility. Suddenly your coal quality goes down and then you ramp down, even on its own. So that also leads to flexible operation. Now, only thing is you need a proper information on what coal quality you are getting, so that you can very quickly change your operating regime. So awareness is a must. I've been telling you in my presentation. If you are doing it without awareness, it can be disastrous. Also to Mahajanko, like water wall, yeah, this is a phenomena of flexible operation. But if you are not knowing what is happening, the damages will be great. There are many reasons for that. Yes.
No, so my point was, so we have all the standing linkages committee, so every month short coal linkage committee. Suddenly India decided that we will not import any coal, zero imported coal. Then suddenly 10% imported coal mandatory. So I really find a lack of consistency in the policy making also, and we are not doing a very, long-term planning. So everything is, once the event is occurred. So now we may have a shortage in June, But there is a phenomena that there could be early monsoon. So this year we are expecting early monsoon, and suddenly if there is a June monsoon, the agriculture demand will go down, and there may be a glut in the demand also. So these seasonal variation. So in this scenario, how the IPPs are looking of all these, especially those who have come from the competitive bidding framework, you have a certain obligations under the power purchase agreement. And so are you looking at amending those PPAs in the scenario? Is there any discussion happening with your power purchasers, of all these? Because the LD would instruct you, to ramp down or ramp up, and you will ultimately have effect on your PPA is for 25 years. You are going to affect on your availability, plant load factors, and so on and so forth. So is there any discussion happening from that point of view?
Basically, as an IPP, we are having a multiple PPA. So, like GMR, we are having a tie-up with, PPA with Tamil Nadu, then MSCB, MSCDCL, and Haryana. So, every PPA is having a different part. So, when we are dispatching the load to them, every PPA is curtailing the load as per his grid requirement. Like Tamil Nadu, the scenario is different, and in Haryana is also different. So presently we are not having any discussion with the PPAs for this curtailment. But it is already in the PPA that how much load they will curtail. So they are curtailing the load as per the requirement they are having, plus being a IPP, my cost of generation is slightly more than what Genco is going to supply to MSCDCL. So they are having some merit order list. So that is affecting us more, because we are planning the load schedule as per the day-ahead schedule. But suddenly they will come up, and within 6 cycle time, they will, time block, they will say curtail 100 megawatt. So that is going to affect my performance, because we are giving the power with very less margin to the PPA customers, being a private player. So that is the challenge we are facing.
So are you, is there any discussion happening at the regulatory forum or with your buyers, in this changing context, to redraft the PPA or relook at? So we had developed, in 2006-07 a standard template of a power purchase agreement, case 1, case 2.
Presently,
everyone gone through, all that, verbatim without any, change. So or do you feel a need to do that?
Yeah, definitely we have to look into that PPA agreement, because if I am forcing to do the flexible operation, that is going to hamper my plant performance, which is going to cost me the price. What price I am selling to customer and what curtailment he is doing to me, that is impacting on my cost of generation. So that part is not considered in present PPA. So that has to be come in effect, so that I am also able to cooperate with their demand. Otherwise, it will be difficult for me to survive.
Yeah.
Yeah, one thing on the PPA, somehow PPA has been very good for our country in providing energy security. But today it is restricting also. Because everywhere in the world you find that the market decided things. One thing I'll add here, it was my personal experience when first time when I entered into this domain and I collected knowledge, was my personal experience when I found the European market, how they deal with it. And just by the market mechanism, they changed. Here also, I have been stressing with the regulators and all to bring more market products. Like PPAs are there, it has been restricted, but there are a number of opportunities available, ancillary services in the central ISGS units. States, I don't know. But again, DSM was there earlier. Although it was not a market mechanism to earn money, but still in NTPC, I was there in the strategy group. And 1 year, I earned like few thousand crores for NTPC just by changing the strategy.
Demand time.
Yeah.
That is
No,
the
by
demand
changing
type.
the strategy.
Yeah.
How we should operate, which unit,
UI.
where it is placed, and how you should operate.
Yeah.
Just by that, we had earned a lot of money. And then ancillary services. AGC, NTPC is earning like anything. People from NTPC must be here. And that is an opportunity. So for all these things, when you go to the regulator, instead of just telling that, okay, we are suffering like this, it's better to ask for something like some other products. Then more like market-oriented products can be there. PPA also, CRC, they have given something in the PPA, something extra also. It's just a proposal. I don't think it has been implemented yet. But it is there. But before that, to all the generators, do you really know what is the cost you are incurring because of this flexible operation? You know, this cost number, it was not available in India. We conducted studies. First time, 2017, we did it for 4 units. 2 at NTPC, 2 at GSCL. Subsequently, we did it with not long back last year. We did for supercritical units. All those numbers are available. But you know, every unit has unique cost numbers. It will depend on a lot of other factors like design, then what type of coal you are fitting, how you are operating, all those factors. So please conduct analysis of what is your cost, what are the cost of the damages. And then you go to the regulator and you put a regulatory note and other things. So even we are willing to support. I can support anybody because I've done a lot of work with CRC, including this RTM, real-time energy market also. And one thing I'd like to compliment, especially Adani, Mr. Mahapatra is there. I think still I'll tell you in my bag I have their vision statement. Vision statement, please read it. You can find it online. They are on the right track. I give this example even when I go to NTPC. The way you have taken up flexibility, it's really commendable. It's mentioned in their vision statement. And probably Adani understands the future of this flexibility and as an opportunity. You know, there'll be a lot of market products that is going to come up. So that's
So before we move to the next, so in terms of the planning, I just have one question to Kate sir. So today we are looking, what is coming up, 400, 300. So we have a lot of pumped hydro, solar, wind, and we really never know, what. And all these coal-based power plants have a gestation period of 5 years, 6 years, 7 years, for their construction. And the technology is changing so fast, rapidly. So by the time some units get commissioned, you will have something new technology which will come up, by the time this unit get commissioned. So what should be our approach, going? So do we need a smaller size units given, so because there will be battery storage systems which will be coupled. So we had come up with a lot of, bundled scheme, renewable and thermal. So every 2 years we come up with some different scheme. And you just had, a session on the metallurgy, what type of, So to all of this flexibility in terms of the unit size planning and what type of metallurgy suits, this flexible operation. So what should be our approach? Should we go for a 660 megawatt, 800 megawatt or a 300 megawatt supercritical unit? So what is the need and who is, whether there is a real planning required in that aspect?
Definitely. Very good question, Rizab. Actually, I am requesting, moreover insisting, that you should not start that flexibilization operation all of a sudden. Yesterday it has declared to operate this load on the flexible load instead of basic load. That should not be decided. Unless and until you have adequate preparation. Unless and until you have adequate preparation, you should not go. You know that there are jerks, sudden vibrations, whenever there is low is coming down and this. So the problem of exfoliation will come. Whatever the inside oxide thickness, it is there in the reheater. So due to the jerks, that will be detached and ultimately it is going to the turbine. There are strainers. So that is getting trapped. but solid particles that will still enter to the turbine and that are damaging your blade. And then you are unnecessarily, you will be telling that, see, what is the cost of this flexibilization. Here, simple thing is that you are allowed that oxide scale on that material. If proper attention is given, as you asked the material specification, instead of that, you should go for T91, T92 material so that they can resist the higher temperature and the scale will not be formed. As you know, even 20 degrees centigrade rise in the temperature, that decreases the life by 1/3. So when we know that, exfoliation jerks are there. So first of all, you should make your plan to replace that. Because whenever we are actually planning for something, you should have a technological and economical evaluation of each unit. Another case is that whenever the loads are pulsating load variations, they are there. So this your water wall, it is a differential expansion is observed. And when differential expansion is observed, some of the tubes are heated up, some of the tubes are not heated up. Okay, those are connected to the outlet header. Outlet header is little bit sturdy, but all these stresses are getting concentrated to the stubs. So first of all, let us take the ultrasonic test, whatever test possible, whether that joint is healthy or not. And if it is not, you should go for replacement of this. Because you know, these are the problems, they are coming over there. Then you know that the expansion, boiler expansion and boiler contractions, that will be also doing it in a very fast manner. So your expansion probes, that should you caliber, you should go walk down survey and you should show whether the upward expansion is there and it should be moving towards rear side and as per the design clearances. Because if these load variations is very fast, then at certain point of time, these expansions are restricted and all these are getting terminated towards the boiler, and that will be damaging, snapping up of the buckstay, detaching up of the buckstay and the detaching of your critical pipeline hangers. Hangers, these buckstay supports, they are very neglected because they are acting like a stationary mode whenever the unit is running on base load. But whenever we are going for flexibility, this is to be taken into consideration. And coal is not in our hand. We are not getting the coal for which it is designed. And whatever some values during commissioning we have given, but what happens? We are not getting the coal of that quality. So therefore our problems, they are increasing. But in this case, as Patkar Sahab has really pointed out, whenever I was at Khaparkheda, I was knowing that the load is increasing or not, or after some couple of hours, the load will be increased. Why? Because in Khaparkheda, slagging indices have calculated. And whatever the coal having higher slagging potential, that has been displayed in the control room. So that shift in charge comes to know that, okay, after some 1 hour, Umred Komil is coming, so my unit will be stable and no chances. And if suppose he comes, that Gugus coal is coming, it is having the erosion prone of this clinker prone tendency, then he should increase the inspections of this, then he should go for a soot blower, soot blowing and the ash evacuation also. So unless and until technological and economical assessment of every unit is done, and whether we should support that base load or not, depending on that, then you go for the cost. Because the cost is, investment cost is more, and variable cost, it is again more. Why? Because at the part load efficiency, your plant load, the efficiency will come down, your creep and interactions will be there, outages will be increased, reliability will be decreased, and everything. So at least wherever coal is to be furthered, you go for slagging indices. Again, heat and mass energy measures are to be taken. Heat absorption logistics is to be studied by just inserting heat flux meter into the soot blower. So we should come to know whether at what area it is not getting, when the soot blower is getting, soots is getting accumulated at which portion. And then you should go for the correct targeted port is to be designed, and then that magnesium hydroxide slurry and that is to be poured. This investment is okay, and that is called the TIFI, that is targeted in furnace injection. But when we do not know our coal is having a slagging tendency or not, and we are actually doing so many efforts for to see that the clinkering will not there, then it is my sincere request, unless and until adequate preparations are there, we should not go for flexibilization. Whatever may be the size of the unit, 600, 500, 400, and even if supercritical unit, whenever it is running at 50%, what is the use of supercritical, sir? It is designed for that 221 pressure and this much temperature. If you are reducing pressure, then it will no bore supercritical unit. Whatever may be the unit, first of all, from our side, we have to make adequate preparation. Okay.
But the challenge is from a DISCOM side. So what DISCOMs are thinking, I need a cheaper power to give to my consumer. He's not bothered. So when I was with Mahajanko, we had, initially we had separated and we started, framing the PPAs between DISCOM and, Mahajanko. And there was a clause in the state regulation, that first you should finalize your demand projections and then you go into the PPA. And we had a huge debate. DISCOM said we are not going to give, demand projection. We said fine, that's your call. But the challenge is, we are, working in very much silos, so suddenly someone is offering at a 2 rupees. So at ILFS we did this, Badla was a first, 2 rupees 35 paise was the first when the tariff arrived for the solar. It was just everyone, was quite surprised, to get that tariff. But so everyone says, okay, I need a cheaper power. But what about the PPAs which you had signed with earlier, the parties? You cannot, so every organization is looking in piecemeal at its, in a commercial manner, rather than having, an integrated approach. And I feel, the state regulators are not playing that role to an extent which should be, played as a, a planning kind of activity. There is not only tariff determination is not the only activity. It's a holistic view they have to take. So what is, the private sector is how, you are looking. So many of the private developers, I think, have stopped thinking of putting the new coal-based power plant. It's only the state utilities which are doing. So at Mahajanko, so you are setting up, 660 megawatt, 500. Now, given the experience of Koradi, which is operating, is there a renewed thinking, in Mahajanko that, okay, let's go back to 210 megawatt units?
That also would be a good point of discussion. But right now, efficiency also matters. Whenever you are generating, you should be generating at the best. So, and if I again go for 210, it would mean that I would be raising the cost. So instead of doing that, I would be putting in better units which are generating at a cheaper cost, except the capital cost. Other than that, what we see right now is there is a lot of investment going on in coal also. Because 85% is FSA I have signed for. I have to take that coal. So if I am not generating that much money and that much amount of investment is there on me also. So Mahajanko is looking into going ahead because many of our units are almost 30-year-old. Means 210 megawatt units are 40-year-olds. Means Bhusawar, Nashik and Chandrapur, Koradi also. Apart from that, 500 megawatts, 500 megawatts were the first of India, 92 to 97. They are also about 30 years old. So aging also is a factor. If we are looking forward, we have to look into putting in new units with higher capacity.
So, yeah.
So there are two things. India's development will be coal-driven. This was discussed even at the PM level. Actually, after a lot of deliberations and other things, they have arrived because we have plenty of coal resources and other things, they are just driven by the West after they have developed. It's very clear since last few years, government has been saying this. But one question, in fact, two questions I'll ask. Do we really know our demand? That made our planning flawed. We don't know our demand. And then how it is going to increase. Suddenly it was because of the economic activity, especially post-COVID, the way demand grew. We are not able to estimate our demand. In fact, we take the way it is done, it is flawed actually. Then when you talk about solar, cost 2 rupees or whatever it is it really 2 rupees? So there are a lot of things, battery cost, it's just being misled. I worked on it, still we are very far off. I have a comparative slide. I didn't show it here. So for flexible operation or for any, like even for grid balancing, what is the cheapest option? And now I have been actually advocating with the policymakers, RE curtailment is one big resource. Just curtail it, it is a cheaper resource rather than doing it. It will save some of your coal flexibilization cost. And then otherwise, you see, economics will drive the whole thing. Everywhere it has done in the world, here also it should do. Because you are not a saint to take all the sins of the world upon yourself, because others have polluted the world. So RE curtailment, and now I think the policymakers, they are getting inclined towards. I told not much plan for 1% to 2% of the total RE. And it is actually being done. You know, China long back when they put in a lot of RE in the northwestern part, they had 40% curtailment. Then they came out with ancillary services, regulation down, and they were able to reduce it. So it's just economics. And again, another point that was discussed, which technology is better. See, as per my experience, I have tested almost all sizes of boilers, not very small ones, 200 to 500 to 660 to 800. And I found the supercriticals, they're best suited for flexible operation. Even as per the design, they have thin wall components, so ramping is faster. Only thing that you have to note is you shouldn't go below your Benson point. Means you have to operate in the dry mode. Till then it is much better. Even the cost of cycling study that we did, it was cheaper than 220 or this thing. So my recommendation is, okay, even to the government, go for all these supercritical. Now why to go for all those old, inefficient when better technology is available?
No, but is this in the supercritical, do we have the technology for lower sizes? 250 megawatt, 300 megawatt, and operate it at a full load rather than operating a 660.
Okay, size, yeah, size. Yeah.
So why we should look at a smaller size, not subcritical, but a smaller size supercritical technology? We should look at those kind of options.
Yes, agreed. Because see, flexible operation, we are talking about only ramping. That is not flexible. Even startup shutdown, that will happen. And maybe in the week you'll find Saturday, Sunday demand will be very low. So week-long shutdown means you run for Monday to say Saturday or Monday to Friday, whatever it is, and 2 days. Else, other parts of the world also plants has been operating like this. So that way, smaller size supercritical would be better.
Thank you. Now, since Bankar sir has also raised a cost compensation, we'll move to the commercial, segment of all of this. So from a operating staff perspective, there are operating challenges. From a management perspective, the commercial issues are more vital. So, like you have a offtake commitment for coal, and there is a demand. You have a commitment towards the transmission charges because you have contracted a transmission capacity for a certain capacity of the load, and at the same time you have your tariffs also determined based on a certain availability, certain PLF. Your lenders have evaluated all your projects at everyone has a standard financial model, 85% PLF, 7%, 8% auxiliary consumption, which is not really happening, and all your cash flows are going haywire. So, how we should look at these cost compensations? So, the CRC which looked at cost compensation only from a capital investment perspective. What is the additional capital investment required for a boiler modification, TG modification, auxiliary modification. But the other associated costs of, let's say he doesn't offtake, because of this, I don't offtake, the 85% coal or a 65% coal. You are saying, so all FSAs, I guess, had a 65% commitment when the standard FSA was drafted. And now you are asking to operate at a 55%, load. So what will happen to those FSA obligations? Is Coal India willing to reduce those offtake commitments? Because that will affect their profitability. He'll say, you have signed a FSA, you give me a compensation. The transmission utility will say, you have contracted for a certain capacity, these transmission lines are built for that. Whether you are transmitting that capacity or not, I am not aware, you have to pay. So these additional cost compensation also have to be. So, Aapka Mohapatra sahab, you Adani, being at the forefront as one of the largest, private sector utility. So I guess you must be at the forefront of discussion of all these flexibilization apart from the NTPC, DVC, and some state utilities. Adani also must be part of, discussion of these, how the compensation mechanism have to be evolved. So is there any headway going on? So for state utility, everything is cost plus, but for a private sector, it is not cost plus. So what thought process is going on at these?
I would first like to highlight the type of power scenario at Adani. We are at 17 gigawatt capacity, and our chairman's vision to go to 30 gigawatt by 2030. For that reason, we are doing a massive capacity addition, greenfield as well as brownfield. And most of the units are 800 megawatt size. So the previous question I would like to highlight the type of capacity addition government is looking at 80 gigawatt as soon as possible. So we should go for bigger size units unless we cannot achieve that much of capacity. Maybe smaller size units suitable for flexibilization, but the capacity, because renewables are not coming up that speed, even though they have a plan. That is one thing. Like profitability, I have seen at Adani, whatever power, even PPA mode or PPA and merchant combined or purely merchant plants, they are doing well. At cost front, because the demand, even though coal we are getting very less what we need, or sometimes at higher cost, still the type of demand happening across the year, even during the winter season also, rainy season also, the type of demand is happening. So at cost front, power is more profitable and it is day by day increasing, I think. So maybe, as you said, by cutting down coal sourcing or transmission tariff, compensate transmission tariff, there may be some losses, but it will not affect the power profitability.
Okay. So that's the viewpoint, but I think Mahajanko, are you also going or you are suffering from these losses?
No, we also are suffering for these losses, but the basic point is generation side project tenure is 36 months, say, but transmission side project tenures are around 5 years. And that is the major cons, because generation is healthy, generation is coping up. But the point is, at some period of time, we'll come and find that transmissions and distributions are getting overloaded, because standard of living has increased. Morning load is okay, morning load industry also is okay, but evening load is, apart from that solar also, evening load means our standard of living has increased. So every house has a, I am coming from a very humble background and still I find that I do have an AC at home. So this kind of load is growing, and consumer load as well as industrial load is quite demanding, and generation side may be a step ahead, I presume. But transmission side would be a bit behind distribution side also. That is causing a lot of backing down at our ends also, generation side ends also. This is what I feel. Second is distribution wants its rates lower. So suppose it gives me a backing down at thermal side, but my hydro plants at Koina are continuously generating. When water is more precious, but we don't say that it is precious right now, because right now it is available before, means I have my quota at Koina. So my, those units are running 1700 megawatt and I have backing down here at thermal side. This also is happening because that mix of rate distribution also needs it. So that is causing a load on us thermal generators.
So, is there any assessment of, the trade-off? So we say, the RE as, the clean power and all. But when we are operating these coal-based power plants, at a lower, so we are polluting kind of, there are challenges of emissions which will come up, when we operate at a lower load, slagging, so the issues of the... So is there any analysis which have really happened, so whether this flexibilization is, what sort of pressure it is putting on the environment, and is there a balance being struck, for the clean emission-free RE technology? To my mind, it's not completely emission-free, because there are, globally there are many countries which do environment impact assessment for all the RE projects. India does not have that standard. So all the wind projects overseas, they have to have 1 year. So the South Africa has a regulation that you need to do 1 year full comprehensive EIA even for a wind project. So we are, covering the desert, whether that is causing any desert ecology damage. We don't know, whether anyone has studied the damage to the desert ecology by covering the deserts. So is there any analysis which is done as a trade-off between, the additional pollution or emission for a lower load operation versus the RE?
Yeah, that means trials are going on. Means if suppose you are going from base load to the part load, definitely it is going to impact the environment. Okay, sulfur is one part, NOx is there, then CO2 is also there. So now the part is coming from SOx to now CO2 direction. We are moving towards that. So government is putting more legal compliance on that part also. So that is also going to impact if suppose I am going to run my unit on the part load. So that study is also going on, and what will happen to compensate that environmental impact, that is also we have to see.
Yes.
See, emissions, when we talk about emissions, you need to talk about specific emissions. By part load operation, CO2 will go down because we'll be burning less coal. So net CO2 will go down. But however, specific, because you are consuming more coal, specific CO2 will be up.
Yes.
Specific
will be high.
Yes, yes.
Because it is
But
my
overall,
combustion.
yes.
It is my combustion which is going to impact on the environmental parameter.
No, but environmental overall you are saving on CO2.
Yes.
So that is the gain point. Then if you are able to maintain it proper, even on the low load, other thing like SOx will
SOx
come down.
is okay. SOx
Because-
means it
because,
is on
yeah.
the what percentage you are having in the coal.
Yes, and
Suppose
you are
I am
burning.
firing the coal on lesser side means SOx is going to definitely
Yes.
reduce.
Yes.
But
And NOx
it is
will
having with the combustion, how my combustion is taking place.
Yeah, combustion means that will affect your NOx.
Yeah.
Okay, so NOx will be an issue definitely, because if you are not able to maintain your combustion,
Yes.
that will be an issue. But all other parameters they'll come down, and then overall, if you are able to integrate that much RE, the so-called clean power, then you'll be benefiting. The overall environmental benefit will be there. Yeah.
And there is little bit impact on pollution. I am telling you, for that, combustion optimization is to be done very correctly. Because even if on the higher load or low load, if your fineness is not monitored, then these fine particles, they will be burnt within hundreds of seconds. So when they will burn, immediately that carbon monoxide layer will be formed, because activation energy of carbon monoxide is less, and that carbon dioxide layer, another form above that carbon monoxide layer. Now whatever oxygen is coming, and whenever the coarse particle they are in the combustion, at that oxygen has to cross that layer of CO2 and layer of CO. So therefore definitely that combustion will be in the oxygen deficiency. So in this case, carbon monoxide, that will be definitely getting increased. Yeah. Carbon monoxide will be, so that for the perfect combustion optimization, you see that the dirty pitot tube test and this clean air flow test plus this orifice measurement, it is all necessary. Unless and until then, because if it is not done, there is no monitoring and control of this thing, definitely your pollution will start accordingly. And SCATC damper control philosophy is to be assured very fully. Because in so many cases it is observed that the damper is moving from this 0 degree to 90 degree. And the pressure drop across the damper, it is actually 75% it is being utilized from opening from 0 to 30 degree. And from 30 to 90, there is no effect. So whatever you are closing the damper or this thing, so the damper, whatever 0 we are telling, that 0 is to be adjusted. And in so many power stations, that 0 is not getting, and so air will be coming up. So that is disturbing the combustion. So actually we go for, you invest the cost and you go for that resin enriched spring steel seals, that is cold bulb type seals on this. So this is actually related with the combustion efficiency, whatever may the load may be. That is.
So to add to that NOx issue, we could then, for the units, new units we have so far, 600 megawatts we have so far already. For the old units, maybe for the overfire dampers A and B, we'll have to go into, means maybe Adani would already have it, privates would have it, but governments do not have. Those two are manual, OFA A and OFA B. So those we could have converted in with positioners, and those we can open and control the NOx also for these low loads.
With the low NOx burners, the new
yes,
technology of the low NOx burn.
Right,
No,
sir.
so my point was on a specific emission, the PER. So we have, the CDM norm which was defined, so what is the specific, emission PER, and then you defined a, carbon credit norm. So at so 100, I am operating, let's say, a 600 megawatt unit at a 400. So at a per kilowatt hour basis, what is my emission because of the lowering? Vis-a-vis, so why I am doing that for a 200 megawatt RE capacity. So so the trade-off, we really, I think no one has analyzed that, and we need a analysis to do really, which path we are, walking on. That was my point. We have a lot of questions from the audience which have received for the operational challenges, and I would request anyone of it. So these impact of, the frequent ramping up, down, on the, so there's a net heat rate you have already highlighted, there's an impact on the auxiliary consumption, and ultimately it is the outcome of that is, your cost of generation is going high, and then you are again, on a merit order dispatch, you have been asked to further. So it is kind of created a vicious circle, for a, so the operating team is, I guess, I feel, is really worried from, so they would have a KRAs, that you must maintain a very high efficiency for that, all these engineers. And these are things which are not in their control, so backing down and all. So how do you maintain, the KRAs of that? I think those, a lot of issues. So we discussed some of that already, the coal quality variation. But is there, so limitation on the number of ramping cycles per day? As per the regulations, is there any limitation? So what should be the ramping up, ramping down number of, because it's not only affecting the boiler life, it's also affect more on a turbine side also. Turbine side also, a lot of effect. The generator also would have, impact on these frequent ramping up and ramping down. But still, we see that the frequency, so I was reading one report, for about 40 days or so, we have a frequency which is going on a more than 50.5 hertz. Now, I think so. We were in an era when we joined 92, 93, the frequency was going from 48.5 to 51.2. So it was kind of a quite normal. Now, because of the one nation, one grid, the additional lot of capacities, we have stabilized those things. But still, in spite of all of these, so the frequency going up is also must be causing effect on the generator life also. So how, we take care of all these? So is there really, so Central Electricity Authority in 2010 defined some technical standards. So I think it's high time we need to relook at those standards. So one, existing unit modification, and whatever new capacity which is coming up, what should be the technical standards for those units? Do you think that those regulations are need to be changed? Technical standard?
See, the OEM has given certain cycling time for the 25 years, suppose. So if I convert that into 1 day, it will come 2 or 3 cycle per day. Means that flexing operation, what is permitted by the OEM is 2 to 3 only in 1 day. So how the CRC or regulator is going to accommodate that for the flexible operation? That is our question also, that how we are going to affect the machine. Means this cycling, definitely it is having impact on the boiler, it is impact on the turbine. Because whatever cycle operation you do, there is an impact. But how controlled way you are going to reduce this cycling, it is another part. Means you have to go for the automatic control, CCS running of the machine, less intervention of the operator for ramping up or ramping down. Because operator to operator, it is varying. So that is also impacting on the life of the machine. So this is the another part of the flexing operation. But how much flexing I should do in 1 day for the machine is question for us also.
Actually, there are some standard limits from 100% load to 70%. that is 3 megawatt per minute. Then from 60 to 50, then 2 megawatt per unit, and from 50 to 40, which is very dangerous span, because so many boilers, they are giving very much good response at 50% load, but it is not necessary they will give good response for 40%, and here there is 1 megawatt per minute. So if you calculate like this, then definitely actually 3 to 4 cycle sudden load variations, they are actually as per design.
So since he has raised the issue of, the competency of the staff, to operate. So now you are one of the, eminent examining panel, for the boiler operators, boiler engineers. And also, so does this, so it is affecting in a way residual life of, the plant. So do we need an amendment to the IBR, so what should be, so I read one of the presentation of NTPC wherein they were talking of a first RLA at 6 years. If you are really doing a flexibilization and a 55%, all these ramping up, ramping down, you need a RLA maybe after 6 years. So one, do we really need, the IBR to be looked at, because of all these dynamics? And second, in terms of making ready the boiler engineers, the boiler attendants, boiler operators, so there is so much of jargon of terms which is coming up, the security, economic constraint, economic dispatch, and then AC. So how, we are preparing the next generation of engineers? Do we really need to change the syllabus or look at the, relook at the developing the competencies of the future, the power plant engineers?
Definitely. Here, power station has to make adequate efforts to actually go for such a type of flexible operations and the reliability, availability, and safety and sustainability. At the same time, the power engineers, they have to do a lot of preparation so as to upgrade their scale in order to fit to the regime of the new operation. Same is the case with the boiler attendants, boiler and these boiler BOE, boiler operation engineers. Here in this case, I am telling you, whenever suppose if you are carrying out the flexibilization, it is to be carried out in 3 stages. First is, you just review your engineering performance. Up to this, what has been happened? Where are my which portion, my pressure part, which portion is weak? And what is to be done, that is a priority, that is to be first of all made strengthened. So that for that history is required. So your first step is that, for that, you just go for the part which you know, for that RLE is not required. You know that your economizer have got so many leakages, it is erosion profile mapping is disturbed, and so I want to replace this. So instead of RLA, we should give concentration on the condition monitoring of the pressure part components. Every overall, you should carry out deposit quantity analysis, though in table 1 or table 2 it has written quantity analysis, deposit analysis. But in overall, you should go for deposit analysis, and really if deposit is more than 40 mm per centimeter square, then you go for chemical cleaning. Same is the stress. Whenever overall is there, you should go for the stress rupture steps. Some of the tubes are to be cut, and you can measure what type of stresses are coming on superheater and reheater tubes. Then whenever there is opportunity, you should measure the inside oxide scale thickness, and there is also allowable limit is 65 microns, 65 microns, that is 650 microns, 0.65 mm. So you know that now this overall, if it is reached to the 550 microns, then in the next overall I have to start. So for that, no RLE is required. And RLE is that way, the condition assessment of the pressure part. So instead of bringing some resolutions, some new amendments in RLA, we should give stress on the condition monitoring of the pressure part components.
So in a way you are saying that we should use more and more NDTs, to assess the stress in the pressure parts and the other, auxiliaries. And what about the, so do you see the amendment in the syllabus or the course curriculum for the boiler engineers, boiler operators, for all these to make them ready?
Because these examinations, these are of very basic types, in which actually we ask what are the combustion requirements, and this and this. And with this basic knowledge only, he had to, now I have told you, that power engineers, they have to upgrade their skills so as to fit for the new regime. So when we know this basic knowledge, then definitely we should be getting adopted with this type of challenges. And for that, basic change in syllabus is not required.
Okay, fair point. So I also, we also need to look at the climate change. So we have seen, the many a times the generation from the wind suddenly goes down. There is a variation in the climate. You have a higher monsoon or lower monsoon. The wind patterns are changing. So this, we are on one side, we are adding a very high, RE capacity based on solar and wind. But we really need to have a very long-term climate change model. What is the weather, the temperatures are, how the temperature profile is changing, how the wind patterns are changing. And it needs a lot of investment into the weather forecasting. We have a very bad history of, forecasting the, weather. We don't know, after 4 years, suddenly you declare that yellow alert, red alert, and nothing will happen. And when there is no alert, you will have a very high, showers. So all of these, so we need a very long-term AI-based models, I guess, in all these climate predictions. And that will, because all of these plants are, life of 25, 30 years. So, okay, 15-minute scheduling is one part, but you really need to have a long-term assessment of how my plant is going to operate, and what precautions I have to then accordingly take in the design of the plant. So we really need to invest a lot into the weather forecasting, scheduling. So we should have a month-ahead plan, so which unit to be banked, which unit to be, and then at a macro level, and then at micro level, I think the planning, you can have a 15-minute scheduling. But so my point is that we need to have all of these a very 360-degree approach, and all the institutions, entities have to be part of that. This is not only the problem of, I think the power sector. We need to have coal ministry in that. We need to have a pollution control ministry. We need to have the environment and climate change ministry. So all of these need to act in a very much coordination if we really want to take our power sector, and meet the energy demand of all of our citizens at an affordable cost. So, so from a consumer point of view, he was initially penalized for a high power, renewable energy cost when the wind was 6 rupees, 7 rupees, solar was at 15 rupees. Now those costs have come down. So as a consumer, I am feeling, okay, now my tariff will go down. And suddenly you have all this flexibilization and you are putting a cost compensation. So from a consumer perspective, this is really nowhere going, he is not at all facing, So in the morning they were saying that DISCOM has to pay the money, but that's, on a limited, solar, so that will be at a 15-20%. But as a consumer, I would say I'm not bothered. You have put up the RE plant as a business case for someone else's benefit. NTPC has put up as his own business, meeting demand, but it's a business case. They are a professional company, it's a listed entity, they are working for their profits. So why in all this process I should get suffered because of someone else's lack of planning? So what is the viewpoint of a consumer, and when it will come, so there will be a lot of petitions, I guess, and then the consumer forums will chip in when all these, the discussions will come up as when CRC will put up at a regulation. So is there any deliberation happened when you had part of the CRC consumer? So the cost compensation defined. So was a consumer point of view was taken into account?
No, actually, there was on the compensation, one is already implemented. I think it was implemented in 2017, compensation mechanism. The other one till 40%, and then there were some other components also added to it. They published the white paper, then stakeholders consultations and all. It was going on. I'd seen all the points that came up, even from the generators. These things didn't come up. I know it's very complicated when you talk in terms of consumers. It's very complicated thing. See, we didn't talk about cross subsidies, paying for free electricity given to others. Somebody has to pay for it. In fact, we are paying for the passenger freight subsidized. We are paying it from our electricity cost. It's too complex, in Indian electricity sector, it's too complex when you talk on terms of cost. These things happen, and in fact, CRC in 2017, they have already successfully implemented it, but none of the states, I was just checking any state, none of the states have implemented it. And there are a lot other factors, because of which this is not happening. I presented to a few states also. Gujarat, their regulatory commission, their chairman and all. And then they told, no, we have a mandate. Regulators are not free. Regulators get mandate from the government, and actually there should be independent body as per the design. So these things actually we'll keep on discussing, and I don't think that in terms of consumers anything will happen. They have to pay the price somehow. And electricity is such a sensitive thing. It's government's headache to supply this electricity. And consumers who can afford to pay, they have to pay. It's like this. And one point before we miss out, I just like to add, not very relevant to this question. We're talking about this, what are the thing changes that needs to be done in terms of training, courses, and then even what should be the life, any inspection methodology. One thing is, any plant has a life of say 25 years, it's economic life. Otherwise, I remember last boiler, what is the life of a plant? It's immortal. It's immortal, I'll tell you, Amar. Only thing, economic life, in terms of economic life, is said 25 years because it's built into the PPA and other things. And practically any component you can replace. So think in terms of economic life. And then, every cycle, it should be doing it. Generators should count every cycle. And there are two popular methods. One is EOH, watch what you find in the turbine, Siemens and other things, equivalent operating hours. Other is what EPRI and what we follow is equivalent hot start. Equivalent hot start standardized, we have taken it as a unit and then we measure in terms of that. And every plant, say it is designed for some cold starts. And hot start, cold start, warm start means they're all in the ratio, 3:5 or something like that. We have this ratio and calculation. So you should be accounting for that. And as you said, sir, it's very rightly that condition monitoring equipment is a must. So have some measurements on each this thing, and then you have an accumulator. Means then when you complete 25 years, then you go to the regulator, okay, this end of this economic life. Forget about safety and all, anyway you have to do it. Sometimes somebody consumes many times, 25 times the actual damage, even in one start. Some of the starts, they actually damage the machine because of some wrong operation, water hammering or something like that. So that is a different thing. But for normal, when you're operating for the grid, you should account for every cycle and check that, ensure that you get the money. Otherwise, you won't survive in the business. That is a fact. Yeah, another question.
No, so we will now take some questions from the audience. I think we had a very enlightening discussion. So maybe, so I have tried to cover whatever questions had come to me, many of that, but if maybe some. So is there any question from the audience? Do you want to, so can we run the mic to the audience? Anyone has a question from the audience? Yes, Mr. Degwekar.
Hello, myself Sachin Degwekar, DYC Koradi. My question to Sina sir. Sir, during the morning session, you said that in a power station in the south, there were explosions due to some operational practices, and after your suggestion, they have overcome the explosion. What were the operating suggestions you have given to them?
Can you just repeat the question, please? Explosion, right? You are saying?
Yes, yes, during the morning session.
Yeah. I was mentioning about the bottom mass hopper. Are you referring to that?
Yes, you have shown the picture and there were some 17 explosions which took place. And
Yes. That was bottom mass hopper explosion. And actual issue was the hopper was under design. The OEM was BHEL. I can tell that, and they had done 2 previous studies. And they had finally concluded that there are explosives coming from the mines. I'll tell you, let me share you the thing and what recommendations you can talk to me personally. So, 2 years report, and then somehow I went there. Then I studied, then I started collecting the coal samples. I spoke to the mines, and then collected data from where those coal supply, which plants are being supplied coal from that mines. Then I checked with those stations. This incident had happened nowhere else. Then again I went back to the station. I told them, "Bhai, aapse koi dushmani hai? They are sending dynamites and other explosives only to your plant. So this is not true." Then after analyzing, then it's very easy. You calculate the amount of ash generated on the coal quality, on the ash samples that they had given. And then you see the hopper design and the capacity. It was under design. So that was precisely the reason. And now you cannot change the hopper. It's too expensive. Then you have to change your operating procedures. One easiest thing is to increase your de-ashing cycle. Then there were some changes in the combustion system, airflow and all those things, that instructions I had given, and operating procedure modifications, that document I had sent. And they followed it, and after that, that was the last. They didn't have anything of that sort. Because when you identify the problem, then you know how to deal it. Even they could have done it by themselves. Okay. 500 megawatt.
Anyone? Anyone has a question? Okay. I think it seems that a lot of questions from the audience, whatever they're in mind. I am sure this 1.5 hour discussion is not enough. It's a very deep subject. It needs a continuous deliberation because it is a very dynamic. And once I had attended a Nord Pool, training program. So Europe, you were saying, it's a more of a market driven. So what I learned in that, the more the long term you look at it, the risks are increasing. So a 25-year PPA would have the highest risk. A 25-year FSA would have the highest risks. You don't know what is going to happen, So we have mines. All mines have a mine development plan. They know layers. They have testing. What coal is coming from that mine, everything is done, the mine development plan, OB, ratios, everything. So it's not true that, you cannot predict what coal is going to come from that mine. It is just the mindset of the Coal India Limited. So whatever comes out, because it's a monopoly structure, and those are disadvantages of the monopoly, maybe, we are suffering. There's no competition in the, in that segment. But, I would end on a very lighter note. So all these, thermal plants. So you said, don't refer ChatGPT, but before that I had referred ChatGPT to assess, a 500 megawatt plant, how much steel and cement it takes. So it takes about, 100,000 tons of steel and cement. So it's like a very strong bond. And you are, expecting, that steel to be like a rubber, flexible, with a coefficient of elasticity. So I think on that note, I would like to thank all my panelists. It is a very, enlightening discussions. And I would conclude this panel discussion, and very thankful to all the audience also for listening very patiently to all these discussions. Thank you very much.
Thank you once again to our moderator and panelists. We now move on to the felicitation ceremony. I now request Sri Bhanu Rajgopalan to come on stage to felicitate Sri Sanjay Joshi with a memento and a sapling as a token of our appreciation. I would also like to present a memento and sapling to each of our panelists. Shri Anjan Kumar Sinha, Shri Pramod Kate, Shri Amit Bankar, Thank you, Banu sir. I would like to call upon stage Shri Dhaval Antapurkar to present a memento and sapling to Shri Pradeep Mohapatra, Shri Ibrahim Sheikh, thank you once again to each one of you. I hope the audience had a very engaging session. I would like to now hand over the mic to Mr. Bhanu Raj Gopalan for the closing remarks.
Our honorable panelists, thank you so much for being here. This wonderful audience, distinguished guests, the Director of Steam Boilers, Joint Director of Steam Boilers. Am I audible now? Okay. Today we had some wonderful speakers. Shri Anjan Kumar Sinha, Shri Pradeep Joshi, Shri Gajanan Wankhede, Shri Shamal Chatterjee, Shri Abhas Chanekar, and of course Shri Pramod Kate. I'm sure they delivered some enlightening wisdom to everyone here regarding the most essential process in engineering, welding. I'm very happy that we selected the topic and we converted our Boiler World Update Connect series, the maiden event being called Boiler World Update BWU WeldConnect. It has been a successful show thanks to everybody in the audience. And what a wonderful panel discussion we had. Special thanks to Shri Sanjay Joshi for always being very supportive to all our events. He drove from Nanded especially for this event. He spares time for Boiler India every time, and he came down for this, and what a wonderful moderation. I am very, very thankful to the panelists, Shri Mohapatra, Shri Sheikh, Anjan Kumar Sinha ji, Kate Sahib, and Bankar Sahib. Thank you so much once again. I'm sure this has been a wonderful event. I would appreciate if any of you have constructive and positive feedback about this event. I would also appreciate negative feedbacks. That will help us improve in future. We hope to conduct such event very frequently in the future in all regions in the country. And especially, we want to continue this event in Vidarbha every year. Thank you once again. Thank you so much. हाँ मैं सोच ही रहा था. Sri Gajanan Vankade, please come up for the picture. Sri Chaudhary. Dr. Chandekar.
हॅलो हॅलो अँड हॅलो, एक मिनिट. बरं चालेल चालेल. एक मिनिट फक्त थोडंसं लक्ष द्या ना, एक मिनिट. विधी विधी कम ये इकडे. हा जो जेवढा इव्हेंट हा सगळा जो केला, ह्या पडद्यामागची एकमेव कलाकार, तिच्यासाठी जोरात टाळ्या होऊन जाऊ दे एकदा. आणि पूर्ण एंटायर टीमसाठी OBDच्या पण तिचं पूर्ण म्हणजे कौतुकच आहे. हां येस, थँक्यू.